Hello and welcome to the one-shot video of Git and GitHub. In this video, we are going to start with very basic and we are going to go till advanced. We are going to start with basic Linux command and we are going to end with Git hooks. This video is further classified, is further breaking down with 15 section. Each section contains a topic. Because we are going to do a deeper dive in each topic, this will give you the idea what that topic means. So no matter what, whether you are a student, whether you are a fresher, or whether you are a working IT professional, this video will give you a good insight on your knowledge with GitHub. We are not just going to cover few basic commands, we are actually going to see how does Git architecture look like. We are going to see what are objects, what are the type of objects that we have in GitHub. We are going to see how does it work, what are the internal mechanism of GitHub, how does Git development operation works. These are all the things which you will find in this video. By the end of this video, I will add the PPT, the presentation that I am using throughout the video so that you can just do the revision. And at the same time, I am going to add one cheat sheet which will help us for the revision. My name is Shubham and I have been into build and release over the past 3 years, and here I am documenting my knowledge on Git and GitHub. Now to get started with, all you have to do is take a notebook and a pen and just watch the video. I would request you to create your own notes so that you can remember what actually is going on, because once you write it, then and then only you will be able to recall the things, right? So yeah, just take a notebook and a pen and get started with this video. So yeah, welcome once again and let's get started with Git and GitHub in one. So yeah, let's begin with Git and GitHub. And to begin with, just want to tell you that Git is also known as source code management. Okay, let us move forward. So yeah, here is my profile. You can check my credentials on my LinkedIn profile. Okay, let's move forward. And here in the next one, we are going to see what actually are the things that we are going to cover in the entire video. So as I mentioned earlier, this video is further classified, is further broken down into 15 section. So in section 0, we are going to cover shell commands. Okay, then we are going to learn about the internal mechanics of Git. We are going to understand how Git works under the hood. Then we are going to see what are the low level commands in Git. Then we are going to see what are the working tree. We are going to see how Git manages your project files. We are going to see few Git operations, few basic operations. Okay, and then we are going to learn about Git branches. We are going to see some GitHub workaround tips and tricks for the GitHub workflow. Post that, we are going to learn about Git branch. Okay, then we are going to see how we can merge those branches. We are going to see what should we do when we are getting any conflicts. Okay, we are going to learn about remote repository. Okay, then you will get to know what is the difference between Git and GitHub. And then we are going to see in section 7 what are the sort of GitHub operation we can do over the hood. Now next is we are going to see what are pull requests and how do we make a pull request. Okay, now we are going to learn about forking and tagging. We are going to learn about rebasing, git ignore, git log. We are also going to cover the important part, that is the important section, which is Git development operations. Okay, here we are going to see few advanced workflows for the development. Then we are going to cover about GitHub pages, and last, that is Git hook. So there are multiple things, many things that we have to cover in this video. All right, to begin with, let's start with the introduction. Okay, so we are learning Git. Okay, now what Git is? Git is DVCS, which is also known as distributed version control system. And what GitHub is? GitHub is a repository hosting system. For now, just understand that GitHub is a place in cloud where we are storing our files, and many people who are working on that specific project can access those files, right? So that's why Git is known as distributed version control system. Shubham, what do you mean by DVCS or distributed version control system? Let's get started with that. But before even going for a distributed version control system, let us first understand what is centralized version control system. Now, as you can see, the name only says centralized, meaning something is in the central and their version controlling is been done. So centralized version control system is not locally available. We always need to be connected to the internet for performing any action. So here the demerit was, if the central server get failed, you will lose the entire data. And that's why Git came into the picture, which made our life very easy, which is known as distributed version control system. In distributed version control system, every contributor will have their own copy of the main repository. That's the main reason why you have .git folder in the first place. Everyone will maintain a local copy of their own, which contain all the metadata which is present in the repository. I hope you now understood why GitHub is known as distributed version control system. All right, okay. Now, before even we start with section 0, let us first start with few terminologies which will clear our understanding with the Git, right? Because these are the terms that I will be using more frequent, so that you should be aware of it. Now, whenever I am using the word repository, I am just talking about a folder, okay, where the clone has been done. Second, working directory. Working directory is the place where you see the files physically and where you will do the all the modification. Commit, so commit is a change in the file, okay? So even if you change one character, even if you introduce one space, a commit id will be generated. That is been indicated, that is been tracked with the use of sha1 hash. Now the last one is git tag. Now as we go for shopping, we see the tag and we see the rate, which brand it is, what is the rate. That is the main significance of tag. And here tags, that the same thing, tag assign the meaningful name with specific version in the repository. So yeah, that was all about the introduction, and now let us directly jump on section 0, that is shell commands.
All right, so welcome to the section 0, where we are actually going to do a deep dive on the basic Linux essential commands, which will be helpful for us to understand Git in the first sense, right? Now, if you are someone who have a little bit knowledge of the basic commands of Linux, feel free to skip this section. However, I would recommend you to go through the section, go through the commands, because it will definitely add some value in your learning. Right. So yeah, let's get started. Now, one question, Shubham, do I need to install anything in order to go through this section? Yes, definitely. If you are working on Mac system, you already have the terminal, so no need to install anything. But if you're on Windows, okay, you just need to install Git Bash. Now, how to do it? Just open a new tab and just write Git install, okay, and this will be the first link that you have to take care of, and go on downloads, and you will download the Git Bash based on your operating system. Okay, yeah, so now the prerequisite for this section is done. Now let's get started with the actual commands. Okay, so yeah, so this is the list of commands that we are going to cover in this section. There are two more slides that we are going to cover in the same video, okay, because this will definitely add some value to our learning. Okay, let's start with the first basic command, that is mkdir. Okay, mkdir stands for make directory. Okay, it is used to create directories. Now, what do I mean by directory? By directory, I'm referring to folders. Just like Windows, we have multiple folders which we can create by just doing a right click. In console, you can just type this command followed by the folder name, and your folder will be created. How to do it? So let's go to the hands-on, and yeah, this is the place where I am going to do the changes, right? So there are few more commands that we are going to cover. So let me cover those as well, and then we'll cover all of them at once. Okay. So mkdir, we are already clear that it is used for creating a folder. Second, PWD. PWD stands for print working directory, which actually tells me my current place where I am hopping into, where I am currently working into. Okay. So let's say you are working on console and you're not sure where you are currently present. So this command comes into handy, and it will actually help you out to know at which place you are currently present. Right, because in Windows, whenever we are navigating to each and every place, there is an area bar where you can actually see the path where you are present. Basically, it tells you that under C colon users admin, this is the place that you are currently present. In Linux, we have PWD, which works the same way. Third is list ls. Ls command is used to list the directories and files. Okay, it is also used with some attributes which will help us to give some add-on value, which actually help us to see the hidden files and folders. There are multiple attributes which we can see with the help of man, which is manual, which we are going to cover in the coming slide. Next is cd, which is used for change directory. Now, in Windows, if you want to navigate from one folder to another, what you usually do, you just double click, go inside the folder, and that is how you do the navigation. And if you want to go back, you just click back and you just go back to the previous directory, right? CD does the same thing in console. Next is dot. Okay, basically it is a single dot. So dot represent the current directory. Okay, and the next is double dots. Basically, it is basically an alias of the parent directory. Okay, so now let's do the hands-on for the 6 commands which we just discussed right now. Okay, so first of all, I just want to list whatever contents are present. So I'll just press ls, and it will display all the folders and the files which are present in my current location. Okay, now Shubham, where are you currently located? So for that, I'll just present PWD. It will tell me that you are currently on user slash Shubham Gaur. So that is the path that I am currently standing into. Okay, now how do I navigate? Okay, so just like Windows, we have desktop. I have created a folder named desktop so that it would be easier for me to explain you and for you to visualize where we are currently located into. Okay, so yeah, let me just change my directory to desktop and I hope that the font is visible to you. So let me just do a zoom. All right. Okay. So pwd ls, and since we want to go inside desktop, I will write change directory to desktop. Enter. All right. Now this is the place that I am currently pointing to. Now, how do I check it? In order to verify it, just write pwd and it will tell that you are inside users, you are inside Shubham Gaur, and you are inside desktop. This is your current working directory, and that's why it's printed with the command pwd. All right. Moving forward with the next command is mkdir. Now, since we are learning Git and GitHub, let us create a directory which will be the source of truth for us, a place where we'll keep all the files and folders for this specific tutorial. Okay, so mkdir, and I'll write learn GitHub. Done. Now let us navigate to the directory, and in order to validate whether this directory is created or not, just do a small ls and it will list down all the folders and files which are currently present. Okay, so this is the folder which we just created. All right. Okay, now let's get back. Let me just do a clear. Clear command is actually used to clear the console. Okay, so whatever data which was displayed here, it actually cleared it. Okay, now let us go inside that folder. So I'll just do cd learn GitHub and enter. And when I do pwd, it will display that this is the current working directory. Now you might be wondering, okay, Shubham, you have given us the demonstration for mkdir, for pwd, for ls and cd. What about dot and double dots? How do I check it? Now, if it is a folder, we'll just do ls hyphen la. Okay, hyphen is an attribute as an option which we are passing. Okay, it is an additional functionality which will help us to see the hidden files and folder. When I do enter, so here you can see a dot which represent the current directory. Okay, and a double dot which is an alias for the parent directory, right? Let's jump forward. Let's move forward with the next commands. Here we have something called editor. Okay, just like Notepad, in Windows, we have something called Vim editor. We have Nano editor. I personally like Vim. That's why I am going to cover Vim editor. However, feel free to go for Nano as well. It is somewhat similar, but yeah, you just need to make sure of few things where when you are saving the files. But Vim is a good editor. That's why we are going forward with the Vim editor. Second is clear command, which we already saw. So let's say, let me go back and let me do ls again. So when I listed down the files and folders from desktop directory, okay, there are multiple things which are currently present, and I don't like to work on a cluttered environment, right? So in order to clear that, I make use of clear command. Okay, it is just clearing the console, clearing the screen to fresh start with the next commands. Now, second is tab, which is used for autocomplete. Now, you might have been saying me that I haven't been writing desktop completely. Okay. Now, what do I mean by that? So basically, the tab button is actually adding some value. It is helping me to do the auto completion of the files and folder. Now, how to do it? Just type cd, and now we created the folder named learn GitHub, right? I'll just type LERN, okay, LEARN, and it actually auto completed the folder name. Enter. Now, if you want to demonstrate this once again, so I'll just create one file. Okay, for creating a file, we have something called touch. Okay, so let me just create an empty file. So I'll just write touch hello.txt. Okay, now, if I want to read it, we have something called cat command, which we are going to cover in the following slide. Okay, but first, let us enter the data inside that folder using vim command. So I'll just write vim followed by the file name vim hello. Enter. Now this is the console that you will be looking into. Okay. Now if you want to type anything, like if you are trying to type anything, it won't allow you to enter the data, right? So for that, you just need to go into insert mode. For that, just press I. Okay. And now if you can check this specific section, it actually says that you are into insert mode. Now I'll type the data. So I'll write, hi, this is from hello.txt. Now, what if I want to save this file and quit this file at the same time? I'll just press escape, colon, WQ, enter. Now, Shubham, I have entered the data. Now, I want to validate whether the data which I have entered in the file meaning hello.txt file, whether it is present or not. Just do a cat, your data is displayed. Okay, there is one more utility which is actually handy for us in order to print the message on console, that is called echo. Okay, so echo followed by whatever you write in the code, it will actually get printed over here. So I'll write hello from console and it will print the data on the console. Okay, so right now we covered Vim, clear, tab for auto completion, echo command which prints the data into the screen. Now, what about man? Okay, man stands for manual, which is helpful for us to understand the significance of the command and along with the following attributes it can be used with. Okay, now it would be hard for a user to remember all the attributes for a single command. Okay, so how would we remember it? Basically, you don't need to remember. You can definitely search on Google. And secondly, if you are not if you're not accessible to internet, you can definitely make use of manual command. Okay, let me just clear the screen. Remember, we just made use of ls-la earlier to list down the hidden files and folders, right? So how did I know about that command? So basically, man command definitely helped me in that. So I'll just write man followed by ls command. Okay. When I press enter, it will give me the description, why it is used for, and what are the attributes it can be used with. So first is name. It is list directory contents. Okay. I know it is overwhelming if you are doing console for the first time, but believe me, if you are practicing it daily, it will definitely add some value in your learning. Okay. And it is a description where it will show what this command is capable of and with or what sort of option you can make use of it. So if you scroll down, it will give you all the necessary option through which you can use it. Okay. And that is how I came along with the ls-la. Okay. If you want to go out of the manual, just press Q and you will be out of the manual. Okay, go back. And last is scrape, which is used for searching lines in a file. Okay, now Shubham, I am not sure how to use scrape. We are making use of manual again. So man, scrape. Okay, it is showing as a general command manual and it is showing the description as grep is a utility that search for a given input, selecting the line that matches one or more patterns. Okay. Grep is used for simple patterns or basic regular expressions. Okay. In order to simplify this, grep is used to find the text which is stored in a file. Now let us do a demonstration for grep. Let me clear it. Okay, let us edit the hello file again. And here, this time what I'm going to do is, hi, this is from hello text. This is for grep operation. And we love to learn. Okay. So when I do cat, basically I'm reading this file and it printed all the things which we just showed it right now. Okay. Now, what if there is a requirement where we are supposed to search for a specific keyword in the file? How would we do it? We can make use of grep. Okay. How do we do it? So basically just do cat followed by the file name. Here you'll make use of pipe. Okay, so pipe is basically used for taking the input from left hand side, meaning this part, this will be acting as an input and it will filter down with the use of grep and you need to type the data that you want to search for. So here I need to search for the term operation. So I'll just write grep operation. It will read the file and wherever it will find the term operation, it will highlight and will show you that this is the place where the term is present. Now, if you want to check where the term txt is present. So I'll just write txt, and it will search for that expression and will print on the screen. So that is the utility and that is the power that grep gives us in hand. Next, and the last slide. Okay, touch. So touch is basically used to create a empty file. Okay, now there are two parameters that we are talking about. Okay, let me just clear the screen. Okay, now if I list it, you can see there is only one file which is currently present. Now if I want to create a new file, so should I need to create it with touch and then edit the file? No, basically you can do it with vim itself. It will create the file and add the data at the same time. Let us do the demonstration. Now when I type vim, and this is the file2.txt, okay, and when I go at insert mode, I'll write hi from file2, and when I do escape colon wq, okay, 1 second, escape colon wq, okay, and when I do a get file, you can see the data is printed, and when I do ls, you can see there are two files which are currently present. Let me do clear ls-la, and you can definitely see there are two files which are currently present. Hello, the file which we created earlier, and a new file, file2, which we created just right now. Now, how do we make use of touch? So basically, touch is a command which is used for creating empty files. Okay, so touch file from touch.txt. When I do ls, you can see this file is currently present over here. Now, what if I want to read this file? Now, since there is no data which is currently present in this file, okay, you can see it didn't printed anything over the console. Okay, so that is the power of touch. Now why basically we should consider touch in the first place? Now basically, let's say you are given with the requirement where you have to create hundreds of file with the same regular expression. How would you do it? Through vim, one by one it is possible, but it will take you time. Now with touch, definitely you can do it. How to? So here we go. So just write touch. Now you are given the requirement that you want to create file 1.txt, file 2.txt, file 3.txt till file 100.txt. If you go manually, you will definitely achieve it, but it will consume a lot of time, right? So that's the best part touch can help you with. So basically just write file followed by the curly braces, okay, and the extension that you want to provide. Now within the curly braces, you need to give him the parameter that will be helpful for him to create the file. So 1 till 100. So this is the requirement which I received because I was told to create the file 1.txt till file 100.txt. Okay, when I press enter, the file is created. How do I validate it? Just write ls-la. Okay, and you can see all the files from number 1 till 100 is present. Okay, let me just clear the screen and show you by using ls, because ls-la will give you hidden files and folders, but ls will give you the files which are currently present, which are unhidden and present in the current root. Next, cat command we already saw to read the file, rm command to remove files and directory. Okay, so let us create a directory inside this folder. So I'll just write mkdir folder. Okay, and when I do ls, here you somewhere you can see the folder name folder. 1 second. And here it is. Okay, here you can see the folder is created. Okay, now what if I want to delete a folder? I'll just write rm, okay, hyphen rf followed by the folder name. Now, Shubham, we understand rm meaning remove. Why we are using hyphen rf? So basically, we are using it to delete the folder along with the parent directory. Now, what do I mean it? So let us try it without hyphen rf. It will give us some error. It is showing that rm is a folder. It is a directory. Now, will it be the same case with the text file? No, it won't be. So let me just delete one of the files from here. So rm file, let's say file, let me delete this file, file 78. So file 78 dot text. Okay, and when I do ls, file 78 deleted. Okay, now in order to avoid that, okay, we are making use of rm-rf. Okay, so when I use rm-rf followed by the folder name, it will get deleted. Okay, because folder is considered as a place where all the data is been stored. That's why it is telling you that it is a folder, and for that you need to provide some additional attributes, and here we provided a -rf. Is there any alternative command? Yes, definitely there is. So let me just create a one more folder. So mkdir folder. When I do ls, the folder is present here. Now next is uh one sec. Okay. Now in order to delete the folder, I'll just write rmdir followed by the folder name. Okay, and that is how you can delete a folder. Rmdir works as the same as rm-rf. The only key difference is rmdir will only delete a empty folder, but rm-rf will delete all the child files which are currently present within the folder. All right, now let me just clear the screen, and these are the files which are currently present in the console. Okay, cat to read the file and rm to remove the files and directory. Now let us do a revision of whatever we learned so far. Okay, in nutshell, let me go back. Okay, let me just clear the screen again, and let me just delete all the files which are currently present here. So rm-rf, and when I do star, whatever will be present over here, it will delete it. When I do ls, you can see everything which was present in the current directory, it is deleted. Now how do I validate where I am present? So I'll just write pwd, and you can see I am inside learn GitHub. Okay, cool. Let me clear it. Now what if I want to create 10 files, okay, with the same pattern? So I'll just make use of touch file, and I want to create file from 1 till 10, and this is the extension that I want to follow. Now how do I validate it? Just press ls, and this is how you can see it. Now what if I want to enter the data in file1.txt? I'll just make use of vim file1.txt. I'll write hi from file1, escape colon wq. All right, and when I do cat, it is basically used to read the data in file1, and I am making use of tab to do the auto completion. Okay, so right now we covered all these commands. Let me move forward. Okay, vim editor done, clear done, tab done, echo done, man done, grep done. Okay, now if I want to check whether file1 the text is present in this specific file, I'll just write cat file1.txt, and here I am giving a pipe, okay, which will act as an input for the grep, and I'll write grep, and I want to search the text file1, and that is how you can see you searched the text specifically, right? So yeah, that was all about section 1, where we just covered very basics of Linux, which will be helpful for us to move forward with Git, right? So yeah, that was all, and see you in the next section.
Alright, so let us start with the section 1 where we are going to learn about the internal mechanism of Git. Okay, right now I am not directly jumping to the command because I just want you to understand the most important aspect of Git, because if you are able to understand this specific concept, it would be easier for you to visualize what are the things Git is doing at the back end, right? So yeah, let's get started with the internal mechanism of Git. All right. So the internal mechanism of Git starts with Git initialization. Now, Shubham, what do you mean by Git initialization? So, whenever you are working on any directory, Git initialization specifies that this is a working directory which is owned by Git. Okay. Now, when you run Git init command, it will create few hidden folders and files, which will be helpful for us to track down the changes. Okay. There are a few files named as head file, config file, description file, okay, and there are few folders, that is hook, info, objects, and references. Okay, in this section our main focus would be on objects. Okay, so there are four types of objects that we are going to cover in this specific section, right? So first of all, let us try to initialize git repo. Okay, we are going to take the same repository which we created earlier, and now when I do ls-la, you can see nothing is present, right? Now it's time to do git init. So git init. Okay, now when I again run lsfnla, you can see .git folder is now present. Now this .git folder is hidden. Now Shubham, why this folder is hidden? Okay, is it done purposely? Yes, it is done purposely, because if you delete .git folder, it will lose its functionality of Git. Okay, you won't be able to perform the history tracking and everything, right? So that's the basic purpose. That's the basic reason that that folder is being made hidden. Okay, now if I show you over the Explorer, okay, so this is how that folder looks like, and when I open it, these are the files which are currently present. Now let us try to read each file one by one, and let me just go inside the folder. Make sure you are adding dot in front of it so that you are just specifying that we want to enter inside that hidden folder. Alright, let me just clear the screen, and when I do ls, these are the files which are currently present. Okay. Now, what is head and what does it contain? So when I do get head, it will just show me the output where my current branch is heading to. Okay, right now it is showing that the references are heading to master, and here we are currently at branch master. Okay, next is configuration. So when I do get config, it will show the default configuration. Okay, it will show which user is currently doing the changes, what changes has been made. Okay, and what are the username, what is the email address, all the things will be present over here. Now, since we haven't done any sort of configuration, these are the only things which are currently present. Next up is description. Okay, right now there is no description present for this repository, but when you add a description, it will be displayed over here. Now, moving forward to the main one, that is objects. So now I'll go to the objects folder, and when I do ls, you can see nothing is present apart from info tags. Now, all right. So that was all about Git initialization, which will create a structure for you to get started with Git, right? Now let us see what are the type of objects that Git offers. There are four types of objects that we have in Git: blob, tree, commit, and annotated tags. Blob usually takes care of file, okay. Tree usually takes care of directory structure. Commit takes care of it takes care of the snapshot of the commit message, and annotated tag is basically other references to the commit. Our primary focus will be for blob and tree, right? Now, these are the four types of object. Now, let us try to create one, right? So, how these objects are being referenced. So, basically, these objects are being referenced by hash. Okay. Now, what do you mean by hash? So, hash in Git is a unique fingerprint. It is a HHA checksum, secured hash algorithm. Okay, which is used for tracking down the files and folders. Okay. Now, let us create one object, okay, and try to check how does Git store the value, right? So for that, let me clear the screen, bring the console over here, all right, okay. So let me just do an echo, it, okay, and it will bring the command over the console, right? Now, let us create an object. So in order to create the object, we have the command with hash object stdin hyphen w. Now what does it do? Basically, it will generate an hash for this object, the echo hello Git, which is written over here. Okay, and it will consider as a standard input because we are using a pipe, and hyphen w will store the data in the Git database. Alright, so Git hash object hyphen standard in hyphen w. Okay, now what we are doing, we are just telling it that whatever we are printing over the console, consider it as an input, okay, and create an object for it that would be a standard input during the runtime and store the data in the Git database. When I press enter, you can see a hash is generated. Okay. Now, next thing to observe over here is, I have written over here is object directory plus file name is equals to hash. Now, what do I mean by that? So, when I open the Explorer again, okay, we are inside object. You can see there is a folder name A0. So, basically, the initials of this hash is the folder name, and that is how Git is tracking the changes. When I open the A0 hash, A0 folder, you can see the remaining hash value is currently present in this file from 218 till 4D. Okay, so that is how Git is tracking down the changes. And now, if what will happen if I run this command again? Will the hash change? So practically no, because we are not making any sort of changes. But what will happen if I just make a small twerking over here? So let me just. Alright, and here you can see the checksum is changed. Now what will be the folder structure look like? So basically we are expecting that 71 would be the folder name, followed by 114 till 85 will be the checksum. So now let me go back, and here you can see the 71 folder is created and the remaining checksum value is present over here. So that is how Git is maintaining the commit hashes under the objects, right? Now, what sort of objects do we have in Git? Okay, we already covered we have four sort of objects: blob, tree, commit, and annotated tags. Okay, now we are tracking these changes using hash. Okay, and there are multiple sort of hash that we have in Git. Now, which hash is used by Git? So basically, SHA checksum is something that is being used by Git. Okay, it is a 40 digits long character hexadecimal value. Okay, so if you count over here, this string is 40 digits long. Now, if you want to generate a checksum, okay, you can do the same. Now, just open a new window and here just write MD5 generator. And here you can just generate the hash value. And that is something that is happening behind the hood. So hi T, and when I do generate, this is the MD5 value and this is the checksum value. Now, looking at it, you might be having a doubt that can two files have same commit? The answer is no. Now, why? Let me explain it. But before jumping to that, let us cover what sort of different hashes we have. So we have SHA1, which is of 160-bit, which is used by Git. MD5, okay, 128-bit. SHA384, again, as the name says, it is 384-bit. SHA 256 of 256-bit, SHA 512 of 512-bit. Okay, it supports SHA1 and both SHA 256, and it is slightly migrating from SHA1 to SHA 256. Right now, let's move forward. The question was, can two files have same commit? The answer is no. Okay, why? Let me just explain it to you, and then we'll go to the mathematical concept. So, the commit in Git is been maintained by timestamp. Okay, two users, if they are working on a same file, okay, they won't be getting the same commit hashes because they will be working on different time. They will be different user. It would be different email address, and these are the different parameters through which it decides that the commit IDs are different. Okay, now. What this phenomena is called? This is called hash collision. Basically, when two users are working, okay, and even if a single user is working, okay, you cannot expect two files to have a same commit, right? So, how does it make sure that two files are not having the same commit? Basically, there is a formula. Since in Git, the checksum is of 160-bit hash, meaning there are 2 raised to 160 possibilities of unique hashes, and that is why it is making sure that two files are not having the same commit. Okay, theoretical, it is not. Theoretical, it may be possible. Practically, it is not. Okay, because it is checking the entire commit structure. It detects the unexpected changes. And third, SH is actually replacing SHA1, which is actually making it easier to understand that these changes, hash collision, are not being get populated, right? So in real world scenario, the chances of two files having same commit is practically zero, right? So this is the formula. You can see 2 raised to the 16. These are the permutations and combination it tries. So basically, these are the specific combination it will try, and that's the reason you won't be getting same commit in two specific file, right? So yeah, that was all about objects. We learned about hashes. We learned about can two files have same commit. Okay. Now in the next section, we are going to cover that what are the low level commands that it has to offer us, right? So yeah, that was all, and see you in this section. All right, so let's start with section 1.1, where we are going to learn about Git low level commands, right? One of the command which we already covered earlier. Okay, so the command which we covered earlier was the hash object command, which is used to create an blob object, right? Now we are already aware that in order to create an hash, there are two things which are required. Okay, that is content, object type, length, and it is equals to hash, right? So when I say two things are required, meaning like it will take one input from you, okay, and based on that it will create the object, right? Now how does that hash is created? Basically, it will ask you for a content. There will be an object type. Now we have four sort of object types in Git, okay, blob, tree, commit, and annotated tags. Our main area of focus here would be blob and tree, right? Commit and annotated tags we are going to cover later, right? then followed by object length, and this length is usually in bytes, and there is something called delimiter, and when we sum up all of them it will become an hash, right? So there are three sort of low level commands in Git. The first one is git hash object, which is used to create an object. Second is cat file, which is used to read the data from that hash object. Third is mk-tree, which is used to create a tree, right? An object type of tree, right? So yeah, these are the sort of object types that we are going to cover, but our area of concern would be blob and tree. Okay, so yeah, let's get started and let's try to create one hash object, right? Now we are inside on our Git repo, and when I do ls happen ls, and when I do dot git, okay, we are inside our dot git folder. Okay, and here you can see all the data is currently present, right? Now the initial thing that we are going to do is we are going to create one hash object. Now Shubham, how to do it? Okay, let me just clear the screen. So it is easier as it sounds. So just need to write echo hi team. Okay, this is something that we are printing on the console. But what I'll do, I'll just make use of this pipe. What this pipe will do, this will take echo high team output as an input and will give the next command as an input, right? So here what we are going to do is git, okay, object, hash object, okay, hyphen hyphen stdin, because we are going to take a runtime input and we are going to store the data in the GitHub database. The initial thing is done now. Now what will happen if I rename this command? So basically it will remain the same, it won't change anything. But what will happen if I change some sort of value? So here I'll write in Q and here our hash value will get changed. Okay. Now when I do ls hyphen la and when I go inside the object, okay, and when I do ls again, you can see there are two folders which are created. So if you see 7c, this is the one, and A021, which is also here, right? Now when you go inside 7c, okay, you'll see the remaining hash value which is currently present over here. And same goes for E0 as well, right? Okay. Now let me go back and here let me explain you what we have done so far. So basically we just created one hash object which was actually taking one input as in standard. Okay. Alright, so it will take a standard input instead of a file and then it will write the data with the help of -w to the GitHub database. Now, what if I already have one file created? Can I store the object in the GitHub database? Yes, definitely. So for that, let me go outside the Git folder. Okay, now I am currently on desktop. If I do pwd, you can see I am currently on the desktop. Now what I'll do, I'll just create one file. So I'll just write echo outside file, okay, and I'll store this value in new dot text file. Okay, now when I do pwd, you can see it is currently present in desktop. Now again I'll go to learn git GitHub repo, okay, and now again what I'm going to do is I'm going to create an object based on the file which is stored out of the git repo, right? So what I'm going to do is I'll just write git hash object followed by the file name. So basically it is new.txt, okay, and then -w. Now we got one hash value. So that is something used for creating an hash object. And here we use the same. Now one thing to observe, does Git hash store file names? No, it doesn't. It just stores the value. Okay. Now how do I read the value? Well, definitely you can read the value with the help of git cat command, which we are going to cover now. What cat command is used for? It is actually used to inspect and analyze the object which are stored. Okay, for example, let us take the example of this commit, right? So let me just copy it, and what I'll do, I'll just write git cat file, okay, and -p followed by the hash id. So what it does, it will actually read the content of the object which was created. Now what if I want to know the size of the file? So instead of -p, just replace it by -s. Okay, it will show you the size in bytes. Next is if you want to know the type of the object which is created, right? It will show you the type as well, whether it is a blob, whether it is a tree, right? So here you got the object type as blob. Let us go back to the PPT where it is actually telling you what this command actually does. So here git cal file -p followed by hash, it will print the content of the object. When you use -t, it will show the type of object, whether it is a blob, whether it is a tree, whether it is a commit, or whether it is a tag. When I say tag, I am referring to annotated tags. And when you do git cat file followed by -s, it will actually return the object in size. Okay. Let us move forward, and this time what we are going to do is we are going to make use of the third low level command, that is of git and GitHub. Now we are already aware that tree object type consists of two blobs, right? So for that, what we need to do is we need to generate two hashes. So let me just generate two hash file for here. So I'll just write echo GitHub, okay, and it will again take it is as a standard input, and here we'll write git hash object, and we are going to take a standard input stdin, and we'll store the data in GitHub database. Next is here I'll replace this GitHub with Git for now, and we got the another hash. So these are the two hash that we are going to do, right? If you want to read the content, then again you can make use of git get file, and here if you provide this hash along with the parameters, if you provide -p followed by the hash, it will print the content of it. Remember, it is not storing the name, it is storing the object, right? Now let us try to create a tree, right? Tree object using git. Okay, it is simpler. There are few things that you need to follow. That is, this is the syntax that we need to make sure while we are working with the tree. So here I'll write echo -e because we are going to pass few values during the runtime. Okay, so yeah, here the first thing that we are going to pass is the mode. Basically the mode is the permission. Just like in Linux we have a different sort of permission, read, write, delete. So just like that we have different modes in Git. Okay, here we are going to pass 100.644 100.
And what is the type of object? Basically it's a blob object, so I'll write blob. Okay, next, followed by it is asking for an SHA. So here instead of SHA you will pass this commit ID. Okay, and the next thing that you need to remember, instead of space we are going to mix of tab. Okay, I'll press tab, and then you need to provide the file name. So basically here the name of the file would be file1.txt. okay, so this is something that we have followed. So what we are doing is we are going to create a one hash file for it. So echo -e followed by hash. Okay, and here we are providing the file name. So here we are going to append it to tree.txt file. So the first thing is done. Now the next thing is what we are going to do is we are keeping everything as same, but here the second thing would be, here we are going to change it as 2, and here we are going to append the data. That's why I am writing double greater than symbol, and here I am just removing this hash value with the new one. So what is the new one? This is basically the second object which we created, and I'll just replace it with the existing one. When I press enter and when I do cat tree.txt, you can see this is the data that we have stored. There is one modification which is required over here. Is, let me just open it via Vim, and I'll just go over the tab which we added, and here we are going to add some tab spaces, and it will actually work. So this is the desired output which has been required in order to create a tree object. Now the last thing would be just do a cat followed by a pi, because it will consider the output of cat tree, okay, as an input. Now what is the output of cat tree? Basically this is the output which is actually, let me clear it, and here this is the output which is present, right? Here what we are going to pass is we are going to pass in pipe, and here the next thing is git mk3. Okay, here you can see there is one more hash which is provided. Now how do I verify whether this object type is a tree type or not? So definitely we are going to make use of cat. Okay, so let me just go back and I'll just write git cat file followed by -p, because it will print down all the data which is currently present here, and this is something which is present inside it. Now what if I want to know the type of the object? So I'll just replace this p with -t, and here you can see it's the object tree.
okay, instead of blob. Earlier we validated it using the blob object type, and this time it is a tree object. Now if I want to validate the size, okay, so definitely the size will be in bytes, and this is how you will validate the size. Okay, so today we learned about how you can create an object, a blob object and a tree object. Okay, how you can make use of git low level commands, that is git hash object, second git cat file, and third is git mk3, right? In the next module, what we are going to learn is we are going to learn the working tree of git, right? This is one of the important section where we are actually going to start with the actual journey of git, right? So yeah, that was all for this section, and see you in the next one.
All right, time to start with section 2, where we are going to learn about Git working tree. Okay, now Shubham, what do you mean by Git working tree? So basically, it is a working tree which defines how the files are gonna traced from Git repo to the working directory, right? Here we are doing, okay, and we are going to see how actually files are being dragged in Git. Okay, we already learned about object types in Git and how to create them. We technically learned about how do we create a block type of object and a tree type of object. For this specific demonstration, we are going to create a tree type of object, and we are going to see few Git commands also, where we are going to see how the changes are being navigated from Git to staging area and then to working directory. Staging area is also known as indexing area, right? So yeah, these are the things that we are going to do today. Okay. Now here comes the first thing, that is Git read tree. Okay. So what Git tree read tree does? Okay. Git read tree loads the specified tree object into the index area without modifying the working directory. What do I mean by that? It simply says it will bring down the changes from Git to the staging area. That's it. So that's the basic purpose of Git read tree. Okay. Now here, if you see the screenshot, there is one command that I have executed. So basically, it is just used to search for an object type in of file type object in Git. Let's do a practical demonstration. So what actually I performed there was I was just finding, okay, the all type of files stored in my .git folder. So we have something called find, okay, and here what I am going to do is find in which place. So basically I want to find it in Git in objects folder, and the file type should be a file. So type -f Git object, and here, okay, sorry, my bad, and this should be -type. Okay, and here you can see there are multiple files which are present. Now how do I validate which file is of which object type? So for that we have git get file, okay, and here we'll just pass the hash. So 66b7 hyphen t, so it is a blob type of object. Okay, now when I go to the next one, that is this one, 5664e, this is again a block type object. Now let's go further. We are actually searching for an tree object type, and I just want to demonstrate that whatever files is being listed here is working fine. This is again a block type object. Okay. Now, if you're wondering how I am entering this, so I think you are already following along the previous video where we actually learned that the hashes are the combination of the directory name followed by the file name. Okay. So here it will be 7c B8A. Okay, this is again a block type of object. Okay, this will be the last one I'm trying. If not, then we are going to create a tree type of object. Okay, all right. So BAD27. Okay, yeah. Finally, our luck is good, and you can see this is a tree type of object. So, what we did actually right now, we actually find it in the .git object type, .git object folder, and we search for the file. And how do we specify it? We specified it with -type. Okay, so that was the parameter we actually did. Okay, now let me just go inside .git. Okay, and let me just clear the screen. Coming back to the actual thing is working tree. Okay, now what we are going to do is we are going to create one tree type of object. Okay, and post that we are going to move that change into the staging area. Okay, by using git read tree. And that is what this slide is trying to say, that it will load the changes from Git repository to the staging area, and it is also known as indexing without modifying the working directory. directory. Okay, so what we are going to do is, let us create two blob objects. Suppose that we are going to create a tree object type from that object blob object which we created, and suppose that we are going to move that change from .git to the index. Okay, so here we go, echo uh, tree one. Okay, and here we are going to write git hash object stdin for standard input, and we are going to store it in Git database. So that's why hyphen w. Now, doing the same with another one, but here this time it would be 322. Okay, done. Let me just copy the hashes. Okay, now if I show you git get file, and I hope you already remember, if you're following the previous video, we can see the type. This is a blob type object, and this is the size. If you want to read the content, this is the content which is present. Now the next thing would be, we want to create three out of it. So let me write migration dot text file, and here we are going to pass the mode. Okay, so this would be 100.644, and the type of the object that we are providing is a block type of object followed by the hash, and here we are going to give a tab, and here we are going to write a delta 1.txt. That would be the file name. Again, 100.644 as in mode, then again file type. Now this time I am going to pass the hash value for the second one. Again the file name delta 2.txt. Okay, the file is now created. Let me do escape -w2, and when I do git get file, okay, one second, we are going to first create it as a tree object. So cat migration.txt and git mk tree, and you can see we have created this hash which will be actually a tree object type. Now let us validate it. So get file, let me copy this hash, and I want to see the type of object, and as you can see, this is an tree object type. Okay, now moving forward. Now what does this says? Right now we are on git repository. Okay, and we want to move this change from git repo to the index area, that is staging area. So for that, what we need to do is, we are going to do git read tree followed by the hash which we copied, okay, from the earlier one. So one second, git read tree and the hash. Okay, the changes are done. Next thing is, let's move forward. Now once the changes are moved from .git to the staging, we are going to list and check whether the changes are actually present in the staging area or not. And how do we do that? We are going to do that by using git ls files. So git ls files, and you can see delta1.txt and delta2.txt, the files which we created, are actually listed here. Okay, so what we did, we actually moved the changes from git repository to the staging area. Okay, now moving forward to the next step, that is moving the change from staging area to the working area. We are now at this level. Now from index area, we are going to move it from to the working directory. Now how do we do that? We are going to do it by git checkout. Okay, and next is index -a. So index -a, and in order to run this command, it actually thrown an error that this operation should be run in the working tree. So let me just go outside the git folder, and here you can see I'm inside master in my git repo. Now I'll again run the command git checkout index -a. Now what happened, it actually moved the changes from staging area to the working directory. Now how do I validate it? We can validate it by using git status, and here you can see we have delta 1 and delta 2 present in our working directory, right? So here, what did we perform actually? Okay, let me just show you. We migrated the changes from git repository to the staging area. Post that, we moved the changes from staging area to the working area, and lastly we validated whether the changes are actually present in the staging area or not. If you are wondering what are these untracked files, so these are the files which we created earlier in the previous video, and that is something that is showing that it is an untracked changes. right? So here we learned about the Git working tree, okay, where we migrated the changes, where we migrated the hashes from Git repo to staging and staging to working, right? So yeah, that was all about this specific section where we learned about how Git working flow works, okay. In the next section we are going to learn about the Git operation, right? So yeah, stay tuned and see you in this section. All right, so in this section we are going to learn about Git operation, okay. In the previous section we came across with the object types. We have block types, right? So in this specific section we are going to cover commit object type, right? Now Shubham, what do you mean by a commit? Okay, because we have been hearing a lot about commit and hashes. What actually this commit thing is? A commit in Git is a snapshot of your project at at a specific point in time. It will record the changes made to the file and save them into the .git repo. Okay. Now, what sort of things will it record in .git? Okay. So basically, with the hash, okay, with this hash, it will track all the changes. Now, the second thing is what, apart from the file changes, what additional info will it store? It will store the timestamp, date and time when the changes were made, and second is the person who made the change, and the third is its email address. But how does Git actually know who is making the changes, right? So for that, there is a small configuration that we need to set up while starting with the project itself. Okay, that is called Git configuration. Okay, so here we are configuring two sort of things, that is username and email address. There are two sort of configurations present in Git, that is a global configuration and a local configuration. Shubham, what is the difference between global configuration and a local configuration? Okay, a global configuration is like a one-time activity where you are specifically specifying that you will be the only one who will be working in this entire project. Okay, and going forward, you are the only one who is going to work in the remaining projects. Let me make it very clear. For example, this is the laptop in which I am recording this session, right? So I am the owner of it. So there is no need to set up the local user for it. I am going to define it as a global user where I am aware that I will be working in this laptop. So that's why I'm doing a one-time activity, that is a global configuration. Now, when do we use local configuration? So there is a specific project where you want another user to work on it, but that is a temporary laptop that we are working on it. So there comes a need of a local configuration. Okay, I will show you how you can make a global configuration and a local configuration in this specific section. Let me go to the console. And here what we are going to do is, let me just create a new repo. So mkdir commit hash, this would be the name. Let me just go inside it and I'll do git initialization. Now, since I mentioned earlier in the previous video, we have been running git status and we have been creating commit hashes, meaning that I already have done my global configuration. So when I do git config hyphen list, you can see my username and email address is already set. This is a global configuration. Now, how do I make a local configuration? Now, see, if I show you how to do a local configuration, the steps will be the same for global configuration as well. So what I'll do, I'll just do a local config this time. So git config hyphen local user dot name followed by the username, and here I'll just write the path. This is the username that I want to set for this specific project, because whatever commits will be made under the name Siddharth. And I want to set an email address, like whenever Siddharth is making the change, that this is the email address that should be right along with it. So get config hyphen local user dot email, and here I'll write Siddharth's email address, email.com. Okay, so this is the configuration that we made. How do I validate it? So get config hyphen list, and this will list down all the configuration that has been made so far. So here you can see there are two names, that is user.name Shubham and user.name as Siddharth. Now since I mentioned earlier, I am doing two sort of configuration. One which I did already, that is a global config. So global configuration is displaying over here, and second is a local configuration which we did right now. And same goes for the email address. Okay, but the thing is, I want to know whether here the repo in which I'm currently working into is a local configuration or a global configuration. So git config hyphen local, and it will display in the current repo which user will be working on. So user.name, and here it is Siddharth, and let me validate the email address as well. So user dot email, and here it is siddharthaji at gmail, right? So I think we made the thing clear about local configuration and global configuration in Git. Now we are actually ready to learn about the file structures. Okay. Now see, in the previous section, we learned how we can create an object. Okay. We created blob object, tree object. Okay. In this one, we are going to create an commit type of object. Now, before we even move forward, I just want to highlight one thing. Commit is just a wrapper around tree. Now, what do I mean by that? So when we actually create a commit, I'll show you what do I mean by term wrapping up on tree object type. Okay. But for now, just keep in mind, this would be the change flow that we would be following, and this is a traditional flow that is followed over the globe. Working directory, staging area, and then Git repo. Staging area is also called indexing, right? Now, there is one more thing I wanted to show you that we are going to perform today, that is this complete Git lifecycle. Okay. What we are going to do is we are going to create two files. Okay. The initial state of the file remains untracked. Okay, and the journey it will follow will be from untracked to track. Now when I say untracked, it would be the green section that I'm talking about. Okay, now what will happen when you create a new file? By default it will be untracked. Now when you move, and here the area where you are currently present is the working area. Now you will need to move from working area to the staging area. So for that we will run git add, and it will move the changes to staging area. Okay, now still the changes are not under tracking. Now how do I make the changes to be tracked? For that I'll just need to do a commit. So git commit -m followed by the commit message that needs to be done. Now Shubham, you mentioned earlier we are making a new commit. What's the need of marking a commit message? Okay, now we as a human tend to make mistakes, so that's why commit that SHA value is actually hard for us to remember the things. But when we run git log, it would be easier for us to understand against which commit what changes were made, and how to highlight that. That can be highlighted by using -n. The parameter that we are passing, it will give us the free hand to write down what changes were made in those file in this specific commit. Okay, if things are going above your head, don't worry. I am going to show you everything in practical, and when you are doing things along with me, things will be easier for you, right? So yeah, once all the changes are done, okay, the changes will be under track. Now what we are going to do is I am also going to show you the statuses, which will help us to understand how the files are been moving from one place to another, right? And then now let's say if accidentally you made the changes from working to stage, and you don't wanted those changes actually, how you can revert that? That can also be done in Git itself. Okay, right. Moving forward, so git status. So you already might be familiar with this command, because in earlier section I just ran it, right? But I didn't explain it, so I just wanted to explain you in this time. So what git status command does, it shows the current state of the working directory and the staging area. Okay, now what sort of things it will show? It will check which files are modified, stayed, or are untracked. Second, it will identify the files that are needed to be committed. Okay, now what do I mean by that? So I'll just show you here itself. So I'll just create two files, vim file1 dot text, and here I write this is first file, escape colon wq. Okay, and there will be another file that I will be creating, that is file2 dot text, and here I'll write this is file2 dot text, escape colon wq. Okay, now when I want to read the file, I'll just write get file1.txt. One more thing I wanted to add, like if you want to read two files at once, you'll just need to pass the file name twice, and here you can see the text is displayed actually. Okay, right. Now the thing is, what will happen if I do git status? Okay, I just want you to go through this diagram again. Now see, now this is the first time I have created this file. The initial state would be untracked file. Okay, now what git is suggesting, in order to add this file to the next stage, that is the indexing area, you just need to run the command git add followed by the file name. Okay, so I'll just write git add file1.txt. What actually did we do right now? We actually moved the changes from untracked, that is the working area, to the staging area where the indexing happens. Okay, now what does git add command does? Okay, git add moves changes from the working area to the staging area, which is also known as the indexing area. It will prepare the files for commit, okay, staging specific changes or entire directories. It will also stage individual files or all the files. Shubham, what do you mean by individual files or all the files? This is something that I will show you at the very last. Why? Because right now we just want to follow the procedures that is been given to us. Okay, I am not doing anything extra. We are just doing the same that Git is actually suggesting us. All right. So here, what we did, we actually performed this same command which was present over here to include the changes whatever we want to commit. So when I do git status again, you will see it is saying, hey, earlier, there were two files which were untracked, but out of those files, there is one file which is moved from the working area to the staging area. And that is this new file which is marked under green. Now, there are two things that you can do. One is you can unstage this file by running this command, or second is you can move forward by creating a commit. Now, Shubham, okay, I don't know how to create and commit. You told how to create a blob type of object. You told how to create a tree type of object. How do I create a commit? So you can create a commit by using git commit command. Okay. Now, what git commit command does is it will capture the state changes with a descriptive message. Now, who will provide the descriptive message? It is us who will provide that message. Okay. Now, it will create a meaningful checkpoints in the history. Okay. When we run git log, it will actually help us to track down the changes. Now in industry, we use two types of project management tool. One is Jira and second is Azure DevOps. Okay. In Jira, we have something called, in Azure DevOps, we have something called AD hash value. That is the ticket ID. That ticket ID will be an identification point for us for whatever changes were made. Okay. Now in your commit message, what changes are expected? Basically, it is the AB hash followed by the message that you want to pass. Okay. For now, let us take an example that you are asked to create an index.html file, and how do you track it? Okay, if you give some random commit message, it will be hard for you to track down the changes, right? But if you have that specific thing to provide a descriptive message, that will be easier for you to track as well, right? You just need to open the ticket and you'll just get what changes were made, what bug fixes were made, and what feature it belongs to, right? So yeah, that is just for recording things. Now, okay. Now let us follow the same. Now, right now we are at which place? So let me go back again to the diagram. So we were in the working directory. Now after doing git add file1.txt, we are in the staging area. That is the indexing area. Now what we want to do is we want to mark it under the tracker, meaning my changes are finalized and now I want it to be present in the git database. Now what I want to do is I will move it from staging area to the .git. So for that I'll write git commit -m followed by the commit message. So now since this is the first file, I'll just write added file1.txt, commit is done. Now, what this thing actually is. Okay, so this is showing the main branch name. This is showing as root commit. Shubham, what do we mean by root commit? Root commit is simpler terms. It means that it is the first commit that is been made against it. Okay. Now the next thing is the hash value against which that commit has been made. It is showing that one file is changed and one file is inserted. And this is the mode, creation mode, and what file is made, what file is been moved from staging to .git, that is the file1.txt. Now there is one more thing I want you to do. If you remember, there are few low level commands which we learned in the previous section. I am going to test the same. So when I do git cat file name followed by the hash, I want to see the type. Now see, we created a commit type of object. Next is I want to see the size, and what if I do -p. Now see, here the thing is, when I mentioned earlier, commit is just a wrapper to tree object type. This is what I meant. Okay. Now, what sort of object does commit store? It stores the author's username and author's email address. Okay. This is the author username. This is the committer email address. Okay. Now, apart from this, Shubham, I don't understand what this thing actually is. So basically, it is the Unix timestamp which is actually helping Git to record when this change was made and who made the change at what time. Okay. Now, if you want to debug it, just copy it, go to the browser and search for Unix timestamp converter. Here you will find epoch converter. Paste the value. One second, let me delete it. Okay, paste the value which we copied and convert it. Now here you can see it is showing the data in human readable format, and it is showing me data in my time zone. So today is Saturday, March 8th, 2025, and I'm making this commit on 102.119, and here you can see this is the time that is actually been recorded over here, right? So far so good. I think you already learned about this thing. Now let's say that there are multiple commits that you made, right? So how do I validate, how do I know that how many commits I made in that specific file? For that we have something called git log. What git log does, it displays the commit history, creating a meaningful checkpoint in the project history. Now, when I say a meaningful checkpoint in project history, basically, see, if you remember, I mentioned that we are using Jira and Azure DevOps for project management. There we are assigned with the specific ticket ID. A ticket ID will be used for the track down of changes. Okay. Now, the third thing is it will view the commit details like author, date, and message, the message that we pass on, and it will also list the history in reverse chronological order. Okay, now let me go back and let me just make few more commits in that file. So I'll just write vim file1.txt, and there is one more thing that I want you to observe, because see, if you go back to this diagram, you can see we moved the changes from untracked to stage, and then the changes are been tracked. Now, what about this orange box, modified? Okay, now what is the actual meaning of modified? Meaning a file which was existing, I am now changing it. That is something which we call modification. So I'm going to just perform the same thing. What I'm going to do is, after this line, I'm just going to write this is a modification, escape colon WQ. And when I read the file1, you can see this is the new line which we added. Now, when I do git status, you'll see it is saying, hey, okay, there was a file which was present earlier, and that was a new file. And now what is happening, after the changes were moved into the tracker, someone actually modified it. Now I have two questions. Do you want to add this file into the staging area, or do you want to restore it to the default one? And right now, your current area where the file is present is the working area. That's why I am showing the modified section as red. What do you want to do? Now, since we are at this point, I want to move it under stage, and then I want to move it to the tracker. Okay, so I'll just write git add file1.text, and I'll do a commit. Before that, I'll just want to show you git status, so that it will show you that the changes have been moved into the staging area. Now the next thing is I want to mark and commit against the changes that I made. File1.text modification line added. Now, the next thing is, okay, Shubham, right now you have made two commits, but what if I want to see the commits? How do I do it? Should I go to .git and object and check for the hashes? No, it would be hard for you to track down all the changes, right? So for that, in order to make our life easier, we have something called git log command. What it will do, it will display all the commits that were made so far. So what I'll do, I'll just clear the screen and I'll write git log and enter. These are the two commits that we made. Okay, and here it is showing that who made the changes. Basically it is Siddharth. Now where this value is coming from, it is coming from the configuration that we made earlier. Now since it was a local configuration that was made by me on this specific repo, that's why the author here is Siddharth. Now what will happen, Shubham, if you don't specify local, it will take the global value. Okay, so instead of Siddharth, it will show you Shubham Gaur. I will show you that thing as well. And again, apart from that, what additional details we get? So basically, this is the commit message that we passed earlier. Okay, and it is showing me the hashes. Okay, and it is showing the header, and it is pointing to the master. Now, Shubham, okay, I agree. You mentioned that you defined local in this specific repo. That's why the committer name is showing as Siddharth. But the thing is, I also want to see how does it behave with global one. So what I'll do, I'll just go back outside this repo. I'll create a new one. So I'll create a local repo for you to for you to understand why it will take the default one. Okay. So here, when I go to local repo, I'll just write git in it, and then what I'll do, I'll just mark a new file. So I'll just create touch new file, and when I do git status, you'll see it is under working area. Okay, here you can see. Now I'll just add it to the staging area, git add staging, sorry, git add the file name. Next would be git status again. Now it is under the staging area. I'll just mark a commit, git commit hyphen name, new file added. And now when I do git log, you can see it is Shubham who is doing the commit. Now why? Because it is the global user Shubham who is making the changes, right? Now you should understand why there is a need of local user and a global user, right? The commit which was made in this file is something which is coming from a global user. Now when I go out from this repo and go back to our normal one, so it was commit hash earlier, and when I do git log here in this point, you will see all the commits that are made in this specific repo are coming from the person named Siddharth, right? That is the actual difference between local configuration and a global configuration. Okay, let's now move forward. Git log command is done. Now, what is git restore? Okay, this is something that we need to take care of. Now, what git restore does, it actually used to discard the changes or unstage the file. Now, let's say you have been working very hard. You have been given a ticket and then suddenly you realize that you actually messed up. Okay, you added the changes into the staging area. Now how do I move the changes from staging back to working directory, or how do I recover my code? So actually what happened in line number 10, I added some extra text which was not supposed to be added, but right now I also forgot what changes did I made. Now since it is not present into the tracker, how do I revert back the changes? By any chance, is it possible to bring back my changes which were present earlier, and I want to move this file into the working directory? Yes, it is possible with the help of restore. How do we do it? So for that, what I'm going to do is I'll just again do a vim on file1.txt. Okay, and this time let's say I delete this line. Okay, now again I am adding something and I removing something. That is something that we are making change into, right? So I am actually modifying this file. So what I'll do, I'll just do I'll save this file, and I just want to show you what changes I made. I deleted that file, and instead of it there is one extra blank space. Now, when I do git status, what would be the as per the file life cycle? What would be the current status? It would be modified. It is showing that earlier, there was one line which was present. Now someone actually deleted it, and there is a blank space present over it. Okay. Now me being a busy person, what I did, I actually want to move those changes from working to staging, but actually, this is something that I am doing by mistake. So what I'll do, git add followed by the file name file1.txt, and now suddenly it clicks at my mind while I was doing CAD before even committing. I found that oh, this line is actually missing, and it was present earlier in my working directory, because this is something that we did accidentally, right? So what I'm supposed to do? Do not panic. So clear, run git status again. Now see, git only my headphone is not working. Okay, the battery is less. Okay, no worries. So here the git only itself is telling us what needs to be done, right? So here it is showing if you don't want to commit the changes, you can restore your file back. How to do it? Just write git restore. Now since you are in stage, you just need to write stage followed by the file name. It is file1.txt. Done. All right. Now what would have happened at the backend? I'll just need to validate it using git status. Okay, it is again back to working directory. Let me show you back in the diagram again. What happened? Uh, the changes were in tracker. I again went back. I did some modification and moved it to staging. Then again, I realized that change was done uh, unpurposely, right? That wasn't the intention that I wanted to. I didn't wanted to delete that file. That's why what I did, I moved the changes from staging back to the working directory. Okay. Now, Shubham, what will happen if I do get file1.txt? Will it bring back me the line which I actually added? No. Why? Because the changes are still present. Okay, it is asking you whether do you want to move the file from working directory to the next area. For doing so, what you need to do, you just need to run a git add. Now the second is, if you want to restore the file to the default one, can it be done? Yes, it can be. So I'll just write git restore followed by the file name. So what is the file name? It is file1.txt. Now Again, will I get the line this time? So let us do get file1.txt, and here is the magic of get. That is how you can recover the data. Now since you haven't marked the changes into the tracker, that is into .get, you were able to recover the lines which you were added, which you have deleted earlier. Now when you do get status, okay, you can see the file is still on tracker, right? Meaning nothing was done, right? So that is how you make use of git log, git restore. I think this actually makes some sense, and it is helping you to understand how does git works behind the scenes, right? We learned about git restore command. What it does, it actually helps us to move the changes from staging to working directory, and also help us to recover the changes which were deleted earlier, right? Okay, it can be anything. Now, regarding checkout, so this is something that we are going to learn in depth in the next section. But for now, I just wanted to tell you what Git checkout is used for. Basically, Git checkout is useful for creating branches and for switching the branches. What are branches and how?
I'm going to tell you in the coming section. For now, if you want to create a branch, for that, just write git checkout -b followed by the branch name. So it would be new branch and the branch is changed. How do I know whether the branch is changed? So basically earlier it was master, this time it is new branch. So for that I'll if you want to double verify, just write git branch itself and it will show you the pointer. So this asterisk indicates the pointer which is pointing to the current branch. Now Shubham, you mentioned that checkout is used for switching the branch. You are creating a new branch. I don't understand. So see, if there is a new branch that you want to switch into, you need to pass -b, because what it will do, it will create a new branch from the current existing source and will do the checkout. Now if there are two branches, if you see, there are two branches which are currently present over here. Okay, now if I want to go back to master, how would I do that? I will just git checkout followed by master, and it will switch back to the master branch, and it is showing that switch to master branch. Git checkout is used for creation of branch. It is used for deletion of branch. It is also used for switching from one branch to the other. Okay. What is the significance of branch? We are going to see in the coming section, which is very important in software development. We need to understand why it is important to understand the branching strategy and branching concept. Is something that we are going to cover in the following section. This was just a trailer for you to know what we are going to cover in the next one, right? For now, let us revise whatever we learned so far. We learned about git status, which tells the current state of the repo. Second is git add, which is used for staging a file for a commit. Third is git add dot. I mentioned in the starting itself that I will show you git add dot at the last itself. So this is the perfect time to show you the same. So let me go back to the terminal and let me clear it and see. When I do ls-la, these are the files which are present. And when I do git status, file 2 is currently in working directory, right? Now let us assume a hypothetical situation where you are working in the project for the first time and there are, let's say, 10 to 11 files. Let me just create a new file. So touch file from 1 till 100, let's say 10 for now, and the extension would be dot text, and I do ls-la. Okay, these are the files which are present. When I look at status, you can see these are the files which are currently present. Now, Shubham, it will be very hard for me to do to add individual files and then do a commit for the same. By any chance, is it possible that I can move the complete suite of file into a single commit? Yes, it is possible. How to do it? Basically, you'll just need to add it to the staging area by adding that. But please avoid using dot because it will consider all the files which are present in the current branch in the current repo, right? When I do git add dot and when I do git status, it will say that these are the new files which are detected. And now, do you want to move it to the next area, that is from working to staging? Yes. So I'll just do git add dot and followed by I'll just do a commit that will move the changes from staging area to the dot git. Let me just write git commit and here I'll write adding baseline changes. And when I do git log, you can see the commit message which I added, that is adding baseline changes under one single commit. Okay. Now what will happen if I do git show? What it will do, basically it will show whatever changes were made in that specific commit. It will define everything: who was the author who made this commit, at what time he did the commit, what is the commit message. It will show you the diff. Okay, it will show you that this is a new file which was created, this is the mode. Okay, and in that file these are the changes which were created, right? Okay, this, don't worry, we are going to cover in the following section. Just wanted to show you how do you run git add dot. Now, Shubham, what will happen when I do git status again? Now, since everything is under tracker, there shouldn't be anything that should be present over the working area. So here it is saying on master branch, there is nothing to be committed and your working tray is clean, meaning you are good to go, right? So that is something that git add does. So, but please remember, avoid using git add dot. But if you're working on a baselining, you can you feel free to use git add dot. But technically, you should only move the files which you have been working on. So for that, just use git add followed by the file name. What it will do, it will move the changes from working directory to the staging. Next is commit. So basically it will save the changes with the commit message. And who will provide the commit message? It is we who will provide the commit message for us to identify what changes were made at that specific time, right? If I show you here git log, okay, it will be harder for you after 3 or 4 months to understand what baseline changes you made earlier. Now, since if you are someone who is working with Jira or Azure DevOps, you will be having some ID, right? So you'll go and see, okay, AB hash 63458 is the ticket, and against that I added some baseline changes. But what were those baseline changes? You can just go back to that Azure DevOps ticket, open it, and you will see the description. Everything will be present on the ticket. So that is something that will be help you to understand why does commit help us and what is the importance of project management tools such as Jira and Azure DevOps. Okay. Right. Moving forward, Git log, it will show you the commit history, okay, in chronological manner. And second is Git checkout, which we saw. So basically it is used to create a replica of branch from a specific point. And then the second thing it is used for creating a new branch and switching it to the next branch. The third thing that Git checkout does it is also used for deleting the branch, which I am going to show you in the next section. Okay. So yeah, I hope this actually helped you to understand the basic commands, the basic Git flow, the basic flow of file in this specific section, right? So yeah, that was all for this section, and see you in this section, that is Git branch, where we are going to do a deep dive on branches. We are going to see how branching strategies has been followed and what do we mean by code promotion in software development, right? So yeah, that was all, and see you in the next one.
All right, time to start with section 4 where we are going to learn about Git branches. Okay, now Shubham, what do you mean by branches and that too in Git? Okay, so just imagine a tree where there are multiple branches. Okay, if you are able to visualize it, it would be easier for you. Okay, so let's say there is a requirement where you are currently working on. Okay, and then there is a new guy, a new intern walks into your company and he actually starts working on it, but there is a concern since he is an intern and like he might be good in programming, but you don't trust him in terms of coding because he is someone who is new to your development environment, right? He doesn't know the application, how the architecture works, like, right? So you don't want the base code to be get messed up, right? So what you will do, you will create a branch. So what branch will do, so let's say if you are working on a master branch, it will create an exact replica for that developer. Now, since he has the base code, he can work accordingly, and then once the code is validated, you can merge the changes in your main branch. That is how whatever latest changes he or she brings us into your company can be merged into the main branch. Okay. Now let's consider a scenario that after merging, you saw some bugs which arose. Now you need to solve it. Will you solve it in the main branch? No, you'll definitely create a new branch, fix on it, test on it, and then you'll merge it into the main branch. Okay. Now coming up to the definition, there is a beautiful diagram which I have created, which will help you to understand how does branching strategies work and incorporate how we incorporate it. Okay. So a branch in Git is a lightweight, movable pointer to a commit. Okay. It allows you to create separate lines of development within a project. For example, uh, we have development environment, we have testing environment, we have staging environment, and finally we have production environment, right? The production environment code is considered to be as one of the stable code which we deploy to the customer site. Okay, the customer actually uses it. We cannot give a customer the testing environment images or the development environment images. Why? Because it is something experimental that we are supposed to give in future, but it is not currently not ready, because there are multiple phases that code have to traverse through. For example, after the development, unit testing is been done. Post unit testing, it goes to QA. After QA, some validation has been done. There are some automation suite which are running at the back end to stabilize the product. Once a QA gives a go ahead, then there is a management meeting. Post that decision is done, that production code is now ready to be deployed into the customer site, and that is how the code has been migrated. Okay, now coming forward to the same topic, that the main branch is the default branch, and in the most of the repository this will be the by default branch. You might also see master. Now what is the difference between main and master we are going to cover in the next section, but for now just consider main will be the default branch in most of the repository. In your case it may be master. Okay, branches are used to develop features, bug fixes, or experiment something safely. Okay. Now let's consider a scenario. You have a stable code which is currently working into the production environment. Now there is a new requirement. You are actually working to optimize your code. Now, Shubham, what do you mean by code optimization? So basically, I'm just talking about. So let's say when you click on submit button, okay, the data is to post into the database. Okay. Now while you were retrieving the data, it used to take 3 to 4 seconds to load into the screen. Now, when you are doing code optimization, when you are adding the indexing into the code, okay, it will load the data faster. Okay, instead of 3 to 4 seconds, it will load in zero point 0.5 or 0.8 seconds. So that is something which is enhancing the performance of the product, right? So you cannot do that thing directly on prod environment without even testing. So that thing can be done into development. Now, how to do that? Basically, here comes the picture of development branch. Okay, because this is the place where most of the experimental things has been performed, where the changes is been tested. Post that, it moves forward with the following environments. Now, what do I mean by following environment? Development, test, staging, and finally on approval, it goes to production. Okay. Branches simplify collaboration and improve code management. Definitely. Because development branch is the area of developers. They are responsible to manage it. They own it. Okay. So whatever things happen into development, it remains with the development. After that, once the PR is merged into pre-release or release, now it's the decision that needs to be made by the QA or the release engineer. Right? Moving forward. Now, what is head? If you remember, earlier when we listed .git folder, yeah, so we are inside the .git folder, and earlier if you remember there was a file named head. Now what will happen if I read that head file? It will tell the references where it is currently pointing to. Now this head can point to a commit, or also it can commit, it also can head, it also can point to a branch also. Okay, so in Git, a head is a pointer that represents your current branch, and it points to the latest commit on that branch. Okay, so whatever will be the latest change, it will point to that specific branch. Header is actually used for identification in which branch you are currently in. Okay, we are going to create multiple branch to demonstrate this specific change, because header is an important concept for us to understand, which will actually tell us where the current change is highlighting to. Head always point to the tip of the active branch. When you switch branches using git checkout, which is a command used to switch the branches, the head moves to that specific branch. Head can also point directly to a commit, and in detached head state. Okay, if you want to change the head, if you want to see how does it work, you need to use the command git checkout followed by the branch name. All right. So these are the commands that we are going to perform today. Okay. So let me go back again here. Let me just create another repo. So mkdir branch GitHub. I'll go to the repo. So this is branch GitHub. I'll do a git initialization to make this repo as a git repo. Now what I'll do, I'll just create a file. So I'll just write touch file1.txt git status git add file1. git commit -m, adding baseline file. Okay, so here we are done. Now what I want to do is, now consider this is the file where my production has been running. Right now, no code is written over here, but I don't want the new intern to mess up this file. So what I'll do, I'll just create a branch. So I'll just write git branch name. So the branch name would be development. Okay, when I do git branch, you can see there are two branches which are currently present, and if you notice the branch is currently marked as green, and second there is an asterisk. This asterisk is an pointer which indicates that the head is currently pointing to that branch. Okay, if you want to validate it, just go outside, go in and do a cat on the .git head file. Here you are seeing that the references are pointing to master. Now what will happen if I change the branch? So for changing the branch, we have the command git checkout. So git checkout followed by the branch name, it is development. Now you see here instead of master, development is written. Okay, and now if I run git cat, it see here the pointer is actually referring to development branch. And again, if I do git branch, you'll see it is currently pointing to development branch. Done. Now the next thing is, now consider that I am that developer who is working on this specific project. Okay, and this is the file that is given to me. Now as a developer, I'll just work on it. So this is the initial code, escape :wq, and when I do git status, okay, it is showing as the file as modified. I'll just add a commit, git add followed by the file name, and I'll just mark a commit on it, git commit -m, added line 1. Okay, and when I do git log -1 line, okay, these are the two commits which are currently present in my development branch. Now, Shubham, will it affect the master branch? Definitely no, because we created a snapshot. So when you do git branch followed by branch name, it will create a branch from that specific point to a new one. Now, if I check out, when I change the branch to master, okay, and now when I do git log, okay, you can see only one commit is present, and if I try to read the file, there is nothing which was written over here. So here what we did, we created two replica copies of it, one with empty line and one with the line, and that is into the development branch, and that is something, one of the use case of development branch. Okay, let me go back. So we saw git branch, which is used to list down all the existing branch in your repo. Second, git branch name, which is used to create a new branch using console. Third is git checkout branch name, which is used to change branch. Okay, so for example, earlier we were into development, we did git checkout master because we wanted to check out to master, and we are now into master. Now let's see if I want to go back again to development. So what I'll do, I'll just write git checkout development, and you can see right now my header is pointing to development branch. Okay, next is if I want to delete a branch, how would I do that? So for that, you can run the command git branch -d followed by branch name. Okay, now here see, since I am already in this branch, I won't be able to delete it. So for that, I need to check out to main. I checked out to main branch, and now I'll delete it. What it is showing? Error. Are you sure? Do you want to delete it? If you want to delete it, just write git branch -d development. All right, done. And you can see the branch is now deleted. Now when I run git branch, you can see there is only one branch which is currently present. All right, let me just clear the screen. Okay, now next is, if you want to rename a branch, how would you do? So we have something called git branch -m followed by the old name and a new name. So let's say I'll create a new branch. So git branch, okay, git branch, and let's say instead of development, I write development with double T. Okay, and the branch was created. When I do git branch, you can see there are two branches which are currently present, right? Now I want to rename this branch. How do I do that? So as per this, what I'll do, git branch hyphen m. This is the old name and this is the new one. When I do git branch again, you can see the name is now renamed. All right. So that those were few of the basic commands that we learned today. There is one more thing that I wanted to tell you. Now, let's say you are currently on master and you don't want to create the branch and then check out to it. You can just do it using a single command, right? Git checkout hyphen b. What it does basically, it will create a new branch and will allow you to switch into that specific branch. How to do that? Just write git checkout. Let's say this is pre-release branch. Okay, and next is I'll just write one more flag, that is hyphen b. What it will do, it will create a new branch and will switch you into that specific branch. You can see pre-release are now present here. Now when I do git branch, you can see the pointer is currently heading to pre-release. Now if I do cat dot git slash head, it will point to pre-release branch again. All right. There is one more thing that I wanted to cover, that is Git GUI, GitHub Desktop. So let me just open my console browser. I'll just write GitHub Desktop download. I'll just go to this link and we are going to download for Mac system. Okay, if you are on Windows, you can download for the same. The link remains the same. Just go here and download for Windows. Okay, based on the architecture type, whether it is 64-bit or 32-bit, you can download it. Now let's just wait for some seconds. Once it is done, we are going to install GitHub Desktop. Now, what actually is GitHub Desktop? Basically, GitHub Desktop will help you to understand Git. It will give you a GUI. Okay, whatever is done in the command line, it will help you to visualize those things and it will make your life easier. All right. So basically, it is mostly used to see the history and everything. Whatever we are going to do using console can be done on GUI. So as you can see, now the desktop is downloaded. I'll just extract it and install it. Okay. Okay, now you can see it is asking you to sign in. Okay, for now we are just skipping this step because we are going to see GitHub sign in the next one. Okay, now here it is asking you to configure Git. Okay, if you remember, we initially learned about git config command, right? Git config hyphen f and global user dot name. So it is actually taking the username and email address from that specific configuration. So yeah, I'll just click on finish and it will configure GitHub desktop for me. Okay, so for now, let me just keep it as is and let me just go full screen. Okay, now since we are working on local, I just go on add existing repo from local. We have two more options: either we can clone a repository from internet or either we can create a new repository on local. But since we already have one, let us go with the flow. All right, let me just recheck the repo name. So we created branch hyphen git. Okay, all right, let me just close this window as well. Okay, all right, so let me click over here and here we are going to choose the path. Okay, so I have kept it under desktop and this is the repo name, add repository. Okay, so this is the GUI of GitHub desktop. Okay, so let us explore this tool. Okay, this will show you the current repo. Okay, now if you want to add more repo, just click on here and there are three options: add existing repo, create a new one, or clone repository. Okay, you can clone a repository using GitHub or GitLab. Okay, second is it is showing you the history. Okay, whatever changes were made, this is the file which was affected and whatever changes were made will be shown over here. Okay, now here it is showing the current branches. Okay, we used git checkout followed by the branch name. It is actually changing over here. Now let us do the practical. Git checkout, git checkout master. Okay, now I am currently heading to master, and if I do a cat on the header file, you can see it is referring to master. Now when I go back to desktop, now you can see the current branches master over here. Now let's say we are making some changes. So vim file1.txt and I am writing this is for GitHub desktop. escape colon wq git add dot git commit hyphen m base change v1. Okay, now when I go back, you can see base change v1, the commit message, whatever we written over here is present. The file which was affected plus the lines which were added is present over here. Okay, now is this change present on pre-release? If you want to check how do you do that, you'll just go to git checkout pre-release. The branch will get switched to pre-release and you can see there is nothing present. If you want to switch branch using GitHub desktop, how do you do that? Just click on here and go to the branches. Right now that change is present on master, but it won't be present on development. Let us go back there and you can see nothing is present on development either. Now when I go back to master, you can see the change should be, yeah, it is present over here. And here when I do git branch, you can see these are the branch and here the header is currently pointing to master, right? So yeah, that was about GitHub desktop. Don't worry if it is something which is overwhelming for you. We are going to cover this in depth in the following videos. But for now, just wanted to give you a gist. This is the tool that we are going to use. We are going to use both GitHub desktop and CLI so that things will make sense for you. Okay. There is additional thing that I would request you to install, that is Visual Studio Code. If you want to install, just go to the web and write VS Code download. Okay, and based on your system configuration you can download it. If you are on Windows, just download it from here. If you are on Mac, you can download it from here. Okay, simple, nothing required. Moving forward, Git flow. This is the important section. This is the important topic that we are going to discuss. Okay, now in Git flow there are specifically two things that we need to consider. Technically three things. First is the main branch, second is supporting branch, and third is the tags. Okay, what are main branches? So basically we have master branch and the development branch. Now Shubham, why these are called the main branches? Okay, so let us see the two segregations of main branch. The first one is master branch or main branch. It is considered as a stable branch which is ready for production. Okay, second is development branch, which is used for integration of new features and the ongoing development. That is the reason why development and main branch are known as the main branches. Second are the supporting branches. Those are called feature branches or hotfix branches. Okay, so feature branch are used to develop new feature, and then once the feature is ready, it is merged back to development. Now second is hotfix. Now let's say something you just deployed into the production and it actually created some issue. Okay, now it is an issue which is creating a bottleneck for the users to access it. For example, let's take a traditional example where you are doing a transaction using your credit card. The amount got deducted, but it is not reflecting on the screen. This issue is something which is due to the backend. You cannot ask the user to wait for 1.5 hours, okay, because there is something called SLA, service level agreement, that the company has to meet up, right? So in order to solve that, there is immediate patch fix which is been given to it, okay, and that patch fix is known as hotfix. If it is not making sense, there is a diagram, okay, which will help you to understand what feature branch, what supportive branches are, and what are the main branches. Release tag, so basically it is used for marking the version. Okay, so major version, minor version, and the hotfixes. So those things are marked using the release tags. Moving forward, so this is the diagram that I was discussing about. Okay, now let's discuss all the flow, whatever we discussed so far, using this diagram. Okay, so this is the development branch that is currently going on. Okay, these are the production changes which are currently flowing. Okay, now let's say the development is completed. Okay, and before development, there is something called feature. Okay, so once the feature is ready, it gets into the development, and once development is completed, it will merge all the changes accordingly. So let's say this is the development branch and these are the feature branches. Okay, now once the feature is ready, it will get merged over this specific point. Now once this feature is ready, okay, we'll get it deployed to the next environment. We have something called pre-release and release branches, which I have mitigated it for now, but we are going to cover in the next one because I wanted to make the picture very much clear for you to understand. Okay, that's why let's consider that the changes once get integrated into the development branch, it will flow to the next branch, and that is master branch for now, which is the production branch. Okay, so Once those features were ready, it got merged into development. And once development is done, there will be an integration testing done. There will be testing done by QA team, and post that the changes will get merged into production. Okay, now in production there is something called release version which we are marking. Okay, and that marking is done by release tags. Okay, how to create the tags we are going to cover in the following videos, but for now just consider release tags as a marking point which defines that this is the point till which the development was finished and these features were pushed over to the production for identification of what changes went when. Okay, now we identified on production image 0.5 is deployed and the customer is facing issue. Okay, now since it is something which will hamper the service level agreement and it is becoming a bottleneck for the user, we'll provide immediate hotfixes. Okay, now that hotfix will be created from master branch. Okay, the reference will be the master branch. Okay, and once the changes are done on this hotfix branch, it will get directly merged into the master branch. Okay, the source will be master and the destination will be master. Because we don't even have that much of time, because we won't be able to create feature branch, then we are going to merge into development, post that review will be done, and on approval of QA we will be merging into master. So that will consume a lot more time and we won't be able to meet the SLAs. In order to mitigate that, there is one decision that has been taken by. Once the hotfix changes are done, and there is one more thing that I wanted to tell, that hotfix changes we don't directly deploy it into production. There are some level of testing which has been done by the team. Post approval, we merge those changes, we test it on the hotfix environment and get it merged into the master branch. Okay, now moving forward. Now once this hotfix is merged into master, it's our responsibility as a developer to merge those hotfix changes into a regular development branch, because whatever hotfix went into the production, it should be present in our local. Why, Shubham? Because let's say if that hotfix create an issue afterwards, you should have that specific change, right? And those specific change should be highlighted in the lower environment also. So that's the reason after merging the hotfix changes into the master branch, we merge it into development, pre-release and release branches. Okay, now let's say that issue got resolved and next sprint comes where you are giving a new feature. Now this is the feature branch, we did some additional changes and it got merged into version 1.0. This is the tagging. Okay, now once this change is ready, there is testing done by the QA team, and post approval from QA team and management team, we get it deployed into the production branch. Okay, and before there are few more pages that falls under SDLC, that is client approval and remaining thing, which we have skipped for now because I just wanted to tell you how does the code promotion works in Git. Okay, so let me just summarize it once again. The we create a feature branch or bug fixes branch. Now once the bug fixes or feature is ready, it gets merged into development. From development, some sort of testing is done, and on approval from the QA and from management and approval from the client from the staging environment, we get merged those changes into master. Okay, if we face any issue, we take master as a source, we do the hot fixes, we perform some sort of testing, and on approval we get merged into the master branch itself. At the same time, we are raising a PR to development and pre-release, so that whatever changes we promoted into the master branch, it get reflected into the development, pre-release and release branches. Now the next phase, that is sprint 2, where we are currently working on the additional enhancement, and once that enhancement is done, we get it tested by the QA, and on approval from QA and client on UAT and train, we get it deployed on the production. And that is the basic promotional and branching strategy that we follow. Okay, so here let us discuss the point. Development branch get merged into okay, so developed feature are getting merged into the feature branch.
And once the feature branch is ready, it get merged into development. After testing, the development branch is actually merged to the upcoming branch, and that is to master. And if we face any issue, any bottleneck is there which actually will hamper the SLA, we actually take hot fixes for the urgent fix. Okay, so yeah, that was the promotional strategy that we discussed. In the next one, we are going to see GitHub workaround, where we are going to do a deep dive on GitHub desktop and GitHub itself, right? So yeah, that was all. And yeah, one more request before we move forward. please install Visual Studio Code for the following video, because it will definitely save some time and it will be helpful for you as well. So yeah, that was all, and see you in the next one.
Alright, time to start with the next section, that is GitHub workaround, where we are going to learn about how do we make a clone of a GitHub repo which is stored in central, okay, into our local. Now, when I say it is stored in central, meaning it is somewhere stored in cloud, okay, a central place from where multiple people can work around together, no matter where they are staying from. Okay, you can be in India, you can be in Europe, you can be in Asia. Okay, so based on that, you will be working on it. Okay. So the first command that we are going to learn today is git clone command. Okay. Now, what actually the purpose of this command is? It copies a remote repository into your local machine. Okay. So when you clone something, what happens? Basically, you download the entire code base with the history. Now, where do we store the history? So if you remember, we store the history in .git folder. So what will happen if you delete the .git folder? So basically entire story will get deleted. Okay. So that's why that folder is marked as a hidden folder. Now, second is it establishes a connection to the remote repository. Okay, so how this connection works, we are going to see in the following video. But for now, basically, since it is stored in a remote place where multiple people can work together, okay, that's why a connection is required so that multiple people can push their changes into it. Okay, because in a company, you are not the only one who will be working in a project. There will be multiple people who will be working on a same repo. Okay. Third, it is ideal for starting a work on an existing project. Why? Because again, there will be multiple people contributing to the same project, and there might be different sections they might be referring to. Okay. Okay. The git clone command is the first step to start contributing into a project efficiently. Okay. Now, Shubham, okay, we learned about git clone command, but how actually we do it? So let's go to the web, and I'll just type github.com. So this is my profile, by the way. But yeah, when you first go, you'll find something like this. This is the GUI of GitHub. Okay. If you haven't created your account, you can simply sign up using GitHub. Okay. And yeah, once you are done, you'll be redirected to this page. Now I'm not signing in. We are just going to explore how it look like. Okay. So for now, let us go to open source, and here you'll find three sort of repository: topic wise repository, the ones which are trending, and third are the collections. So let's go with the trending repository. This repository changes by time based on the trends. Now, on what basis does it change? So basically the number of stars and number of folks. Okay, number of stars, basically the people who like their work, they put their stars into that specific repo, and the third is forking. Now, what do we mean by forking? Forking meaning creating the same replica into your own account. Okay. Now, how does forking work and how we do it? We are going to see in the following video. But for now, just uh, we are just going to see an overview where we are actually seeing what is the meaning of GitHub repo, what is the meaning of central repo. Okay. So this repository is stored in central server. Okay, which can be accessed by anyone. Okay. So yeah. So what we'll do, we'll just go to this repo. Okay. Hack site dip live cap, and there is this green button. Okay, so before going that, I just want to show you the GUI. How does it look like? So this is something called a readme file. Okay, readme file is basically just giving an introduction. What does this repo does? Okay, so it will contains of all the details, the disclaimer, the licenses, how to use it, and everything that is required to get you started. So basically this is the repo that we would be referring to. All right. So yeah, let us move forward, and here you'll see this is the place where you'll find multiple branches. So here you can see they have privacy, they have PR894, there has something called experimental branch, they have UI branch, and finally the main branch. There is something called tag. What are tags? So basically tags are just used for marking some milestone, okay, which we are going to see in the following video. In the previous video, if you remember, we already learned about the tags, right, where we marked version 0.5. Okay, that was a milestone set. Now based on the feature availability and feature enhancement, we upgraded it to the newer version to 0.1, and like it was 1.0 version was released. So tags are used for those specific things. Okay. Next is these are the files which are stored in this repo. Okay, and again these are the branches, these are the tags. So if you click on branches, you will find all the branches which are currently present. You will file active branches, you will file the stale branches meaning the branches which are not in use currently. And if you go to all branches, you will see all the branches which are currently in use. Okay, now let me go back to the repo. Here are the tags. So as I mentioned earlier, here they have created multiple tags. So this is the latest tag that they have, that is version 1.8. Okay, which is marking one milestone that yeah, this is the release that they have done for. Okay, yep. Now let me just go back again. Now, since in open source world, you are not the only one, there will be multiple people contributing to the same project. So yes, there will be issues. There will be some cons and pros which will be reported. Those issues will be reported here, and yeah, that would be addressed using this section. Okay, there are pull requests. What is pull request? So basically, once you solve an issue, once you do an enhancement and you want the reviewer to merge the code into the main branch, you create a pull request. Okay, here is the discussion section. We have something called GitHub Actions. We have projects for management. We have wiki, security, and insights, which we are going to see later. For now, let's just focus on cloning. Okay, so here we have something called this green button, which allows us to take a clone from GitHub. Now, Shubham, you will see there is something called download zip. Now, what is the difference? What will happen if I download it? Okay, if you click on download zip, it will download this specific repository into your local. But the only difference will be you won't be able to download the .git folder, meaning you won't be having the history. Okay, so yeah, let us wait for it to download it. And second is using the CLI command, that is clone command. So first let us see what we get using the download option, and second, when we do the clone, what additional information we get. Okay, so yep, the name of the repo is deep life cam. Let me just copy it. Okay, the download is completed, and now let me just open the terminal. All right, I am inside desktop. Let me just clear the screen. Okay, let me just go inside download. So cd download. All right, and here we have something called, so ls, and when I do ls, the this file name, actually we are searching for this file, that's why I'm doing a grep, and you can see this file is downloaded in a zip format. Now what I'll do, I'll just extract it. So tar hyphen xvf deep life cam and cd deep life cam, and when I do a clear and when I do ls, these are the files which are currently present. Now the main area of concern is, did it downloaded the history? When I do ls -la, you can see something called .github, but there is nothing called .git. Now what is there inside .github? Let us explore that as well. Okay, there is something called issuer template, but we don't have header, we don't have hooks, we don't have index. So basically this is the code which they have downloaded from the main branch, but without the history. All right, so yeah, this is known as downloading the code file. But let me just remove it again because we don't need it, and let me remove the zip file as well. I can zip. All right, clear. Now coming next to the next one where we are going to do the cloning. So let me just copy it. And how do we clone it? So basically this is the command which we would be utilizing, that is git clone followed by the git repo. Okay, it is easy as it sounds. So I'll just do git clone repo link. So what it will do, it will clone it from the central server, download it along with the branches, along with the history. We are going to switch to the branches and see what all logs we get. Okay. So as you remember earlier, we have something called Git Log, which tracks the history, which will show who made the commit, when made the commit, and with the help of commit message, why that commit was made, right? Now, since it is a big repo, it will take some time. You can just choose some lighter repo as well. But yeah, for understanding purpose, this is a good repo. Okay. So yeah, let us wait for some time. Alright, so the repo is downloaded. Let us go inside the repo. Now this time we don't have to extract it because It is cloned from the central server. Now, if you notice something, we are already on the main branch. Okay. When I do ls, these are the file. When I do ls -la, you can see the .git folder present here. Remember earlier I mentioned when you do cloning, you'll find entire history, but when you do a download zip, you won't be able to find it. Okay. So yeah, when I go inside the .git folder, you'll find all the structured things which were present inside the .git folder. So here you'll find hook, index, info, logs, object, and paragraphs. So when I do get index, it will show where the directory is pointing to. Clear? So it was let's happen LA. Sorry, it was head. So when I do a cat to the head, it will show where the current directory has been heading to which branch. So basically, it is heading. It is pointing to the main branch. Let me go back. Clear? LL. Okay. Now mentioned earlier, we will be able to see all the branches. So let me run git branch happen all, and you can see all the branches which we saw in the central is present over here, meaning it did a clone and it is showing us here. Okay, clear. Now next thing would be git log happen one line. Okay, and here are all the all the commit IDs which were done. Here you can see all the tags which were present over there. Now since we did one line, we are just getting a single line description. Now if I remove it, you can see who made the changes. Remove Mac addition temporarily. It was done by KRSHH or Wednesday, March 19. Okay. And there was a pull request which was merged from Addy, okay, into main. And this was done to fix the face swapping crash due to name face embeddings. Okay. So you'll find all the logs which are present over here. Right. So yeah. So this is known as Git cloning. Okay. Taking a copy from the central to your local. Okay. Now let us go back. Now moving forward with the next topic, the important topic, that is git diff command. Okay. Now what is the purpose? This command compares the changes between two versions of the file in the repository. Okay. So the first thing is it compares the working directory with the staging area. It shows the changes that are not staged yet. And second, it compares two commit and shows the differences between the specific commit. The command that we would be utilizing over here is git diff followed by the commit IDs. Okay. So for now, let us take the example from this repo itself. So what I'll do, I'll just run git log -happen one line. And what we are going to check is we are going to check what is the difference between this tag and followed by this fixed space. So let me just copy it. Git diff commit ID 1 followed by commit ID 2. So whatever changes were done are actually in front of us. Here you can see the indexes. Okay, this was the earlier file. Okay, and this is the new file. This is the specific. This is actually highlighting on which line number that change was made. Okay, earlier the line count was 14. Now the new line count is 15. Okay, and then what changes were removed? So basically this line was removed. The one is showing in red is removed, and the one which is in green is showing has been added. Okay, so whatever changes were done is been specified over here.
All right. So this action was done by done in modules, processor, frame, face swapper.py. Okay. So this is the old file. This is the new file. The exact description of diff changes can be seen over here. That's why I have marked on all the changes that will help you to understand the git diff. Okay. So now if you run this same command on Windows bash, you'll find a warning. So in that warning, you'll find that in the working copy of new file, lf will be replaced by crlf in the next time git touches it. What is the meaning of it? Lf stands for line feed and crlf stands for carrier return line feed. Okay, so these are different line ending styles. So LF is common in Linux or Mac. Okay, that's why I didn't receive any warning. But since if this command is executed over Windows using bash, you'll find common in Windows. So that is used by crlf. So that's why it is giving us the warning that LF will be replaced by crlf. This warning occurs when you are switching the environments, that is cloning Linux style repo on Windows. Okay, it is just a warning. Your changes are still be tracked, so don't need to worry. Now Shubham, what is the meaning of this diff? All right, let us go back. We are talking about this thing, diff hyphen git model processor swapper py and b model processor swapper py. Okay, what is the difference? See, the only thing that you have to worry about is this file name, and second, this a and b. Okay, a changes are the one which were present earlier, b changes are the one where the modification is been performed. Okay, so this is called git diff metadata. Okay, where a/new file is the older version which is of the previous commit, and b/new file is the newer version which is the current working directory. Okay, here it is pointing to the index, and here you can find two hashes. Okay, and the third one is again the file mode indicating the standard file tags. Now note, this thing is the second commit is not valid because it's temporary hash presenting the uncommitted changes. Only the state changes and the committed changes are assigned to the valid object IDs. Now in this case, these are the valid object IDs, but in order to demonstrate the same, let me go back and let me create a new repo itself. So mkdir git diff cd git diff, okay, git init. All right, now let me create a new file, and here it would be vim new file.txt, and I'll write this is committed changes, escape :wq, git add new file, git commit -m initial changes. Okay, now when I do git status, you won't find anything. It will say that a working tree is clean. All right, the next thing would be, what I am going to do is, let me run git log once again, git log, and you'll see the first commit has been made. All right, done. Now what I'll do, I'll again edit this file. So vim new file.txt, and I'll add one more line. This is non-staged change, escape :wq, git status. Okay, here you'll find the modified changes over here. Okay, now what I'll do, I'll run git diff. Now see here what it is trying to explain us. Okay, now if we take a reference of this specific section, you'll find it is saying that a is the new file, a was the older file and b is the newer file. So here a/new file represent the older file, okay, and b/new file represent the newer file. Okay, here we have two hashes which we are going to demonstrate, which we are going to read using cat file, and here you can see it is specifically saying that the minus indicates the older one, okay, the committed changes, and the +1 indicates the new changes which has been added. Now see here it is showing you that this is a committed changes, meaning this is already present, but the one in green mentions that this is the new change that will be implemented. Okay, now what this thing is called, I am going to cover in the next slide, but for now just remember that this indicates that the earlier there were only one file which was created and there was only one line which was added, but again after the changes you can see there was one file which is created, but yeah, there are two lines which are currently present after the changes. Okay, let me quit it, and now what I'll do, I'll just run a git cat command. So git get file followed by the hashes, so which we copied. Let me just go back. All right, we need to copy the hashes again. All right, git diff Ctrl+C/Q, git get file followed by the ID. So let me just see what do we get when we do a cat file for this one. See here it is showing that this is the committed changes, okay, meaning this is a valid hash. Now Shubham, what will happen to the next one? Okay, let us demonstrate that as well. Basically this is a temporarily hash. Okay, if you do cat file, you will say it is not a valid object name. Now why it is not a valid object name, let us learn over here. Okay, this is not a valid object because it is a temporarily hash which is representing the uncommitted changes. Because yes, correct, we learned earlier, right, that we won't be able to get a commit ID unless and until we are moving it to staging area and then we are committing it, right? Right now all the changes are present in the working area itself. So since we executed git diff command, okay, it actually assigned us a temporarily hash. Okay, now next is, yeah, we already covered that hyphen hyphen a represent the old file, hyphen plus plus b represent the new changes which are going to implement. Now coming up to the next part, that is at the rate. So git diff, again we are going to cover this thing. What is the meaning of this? This line is called hunk header, okay, or hunk marker in git diff. Okay, it provides important context about where the changes are occurred in the file. Okay, let us break it down. So -1 2, it represents for the old file. So this specifically represent the old file. Okay, so it states that it is starting at line 1 with 2 lines in the original version, and the second is +1 3. In this case it is +1 2. It is starting at line 1 but now with 3 lines. In this case it is starting with one file but with 2 changes, 2 lines. Okay, so starting with line 1 now with 3 lines in the updated version. At the rate represent, it marks the start of the hunk. It is the block of changed lines. All right, so yeah, that was all about git diff, how we do it. In the next section we are going to learn about git branches. We already did the introductory section on git branches, but here we are going to see how actually things are been done using git branch merge, and how do we solve merge conflict, what actually merge conflicts are, and how do we solve it in the real case. Okay, in this section we are going to make use of Visual Studio Code. So I request you to download Visual Studio Code or VS Code or any code editor of your choice, but for this specific demonstration we would be specifically using Visual Studio Code. All right, and in order to demonstrate the changes we are going to make use of GitHub Desktop as well. Okay, GitHub Desktop we are using for visualization. VS Code we would be using for solving the merge conflicts. Okay, so yeah, see you in the next one.
All right. So in this section, we are going to learn about Git branch and merging strategy. What are actually merge conflicts, and what are the situation in which merge conflict arises, right? So the first thing is what actually is Git merge, okay? And when do we face the conflict? So basically, what actually merging is? Merging is basically you have one baseline branch which is currently going on, okay? Once the base development is completed, okay, there are parallel features and bug fixes which are currently going on. Now, will you do that patch fixes or feature development in your main baseline branch? No, right? For that, you will create a parallel branch, and there might be a possibility that multiple developers might be referring to the same file. Okay, so once the changes are ready, you will be merging those changes to the baseline branches. In that case, while merging, you will face the merge conflicts, in which case you will face the issue. So basically same line and same file when referred by the developer, it will create a conflict, because definitely it's an obvious thing, because Git won't know which changes to keep. That's why it will give you a conflict like, yeah, in the baseline branch in line number 10, you have written this is the change. But in the upcoming change, when you are merging, that line is been replaced with the new code. Now the question is, which one do you want to keep? In that case, it will ask you, and the mechanism that here which is used is git conflict. Okay. Now, how do we perform git merge? So basically, git merge is performed by git merge followed by the branch name, which we are going to demonstrate in the same video. Okay. What is the purpose? So basically, it combines the changes from one branch into the current branch. Okay. So this is the base, okay, of git merge. Okay. Now there are three sort of merging type. Basically, two classified into three. So the first one is fast forward merge. So basically there are no divergent commits. Okay. Basically you have a main branch, you create a new branch, and then you merge the changes into the main branch. Okay. So it is known as fast forward merge. Second is three-way merge. So it occurs when branches have divergent changes and Git combines the changes from both the branches. Okay. Now I know it might be difficult for you to understand based on theory, but yeah, I'll show you a IO file. Okay. And secondly, we are going to perform it so that things will be easier for you. Okay. Let us first discuss about what is Git conflict. Okay, which we already covered. So basically, this is the theory. Merge conflict occurs when Git cannot automatically resolve differences between branches. And how to resolve a conflict? So basically, you need to identify by using Git status, and then you can open the conflicting file. And like this is the section that you might see. Okay, for solving conflicts, we are going to use both GitHub CLI and second Visual Studio Code. Basically, VS Code provides you some additional functionality which will make our life easier to resolve the conflicts. However, we are going to do it with both the things. Next, moving forward with the fast forward merge. Now, how fast forward merge is done? So this is the diagram which represents the same. Now consider this is your main baseline branch. Okay. this is the branch which you will be using. Okay, now once the changes are done, okay, what you will do, you won't be merging the changes to this existing branch because you don't want to disturb the changes. That's why you will create a new branch from the main branch. Okay, and you will do the changes over here. Now once it is done, you will be merging those changes to the main branch. So basically your old head will point to the new head. All right. So that is about fast forward merge. Okay. Now, what is the purpose of this? So basically, it moves the branch pointer forward with no divergent coming like this. Okay. Now, when we should use fast forward merge? Because when we want to make a linear history, okay, at that time we should make use of fast forward merge. And here, no additional commits are made on the target branch since branching is offered. Okay. Now, moving forward. The next is three-way merge. So what is the purpose? So it combines two branches that have diverged by creating a new merge commit. Okay. How three-way merge works? So basically, it requires three commits. One is the current branch head, which will be pointing to your branch. Then there will be an incoming branch head, the latest commit on which you will be merging. And third is the ancestor branch. It is last shared commit between the both the branches. Now, how to do it? That is the step which is currently written over here. First, let us do fast forward merge, okay, which is based on this diagram. All right. Okay, so let's do it. So let me just create a new repo for it. So mkdir merge. Okay, git init. Okay, now let's do fast forward merge. So for that, what I'm going to do is I'm going to create a new file dot text. This is initial commit. Equal wq git add dot git commit hyphen m initial commit. Okay. Now we have added the first commit. Now what I am going to do, I am going to add few more lines over here. So echo new line, and it should append to the new file. So basically, if you remember, echo is used to print the command on the console. This delimiter is known as append, which will add a new line to the existing file. So when I do this and when I do cat, you will see apart from this is initial commit, we have the new line present over here. What I'll do, I'll just do git add dot git commit hyphen m followed by second change. Okay, now the things are done. Now when I do git log hyphen one line, you will see there are only two changes. Okay, these are the two changes which are currently present. Now what I want to do is I will create a branch from this specific point. So what we have done, we have created a main branch. We have done few initial changes. Now from this specific point, I am going to create a new branch. Okay, so done. Git checkout hyphen v feature. Okay, now how checkout is used? So basically checkout is used to switch the branches, but since we want to create a new branch and we want to switch, that's why we made use of checkout followed by hyphen v, which actually helped us to create a new branch and switch it into a new branch. Okay, now when I do git log hyphen one line, you'll see the same commit is present over here. Okay, now here it is showing that our header is currently pointing at two places. Basically, the two branches are pointing to the same header. Basically, it is feature and master, both are on this specific commit. Okay, Q clear. Okay, now the next thing is I am going to add few more changes. So vim new file, and what I'm going to do is I'm going to add new line. So new line from feature. This is done. Git add dot git commit hyphen m from feature, and then I'm going to create a new file. So touch file one dot text, and then git add dot git commit hyphen m feature 1.1. Okay, now let me just do a clear git log hyphen one line. Okay, now you can see there was an initial commit, there was the second change. Now here you can see the master is heading to this commit, and then we added two more changes into the feature branch. Now the next thing is we want to merge the changes from feature to the main branch. What I'll do, I'll just check out to master, git checkout master. Okay, clear. Now, if I run the same command, that is gitlog -19, okay, you'll see there are only two changes which were present earlier. And now you can see the head is pointing to this commit. Okay, and here there are only two changes which are going to present. If I do ls, you will see only new file is present. The new file 1.txt which we created in feature branch, it is not currently present here. Now, as a developer, what I want to do is I want to bring all those changes from feature branch to this master branch, because now my code is mature enough. Now all the initial validation is completed. Now, based on that feedback, I'm going to merge the changes to master. So how do I do it? I'll just have to run git merge followed by the feature branch. Okay, now see here what it is saying, updating the hash value. This is the hash where master was pointing. Okay, and it is the method which is used is fast forward. Okay, now which files are been added? So file 1.txt and new file.txt contains with one new line. So that's why it is showing. So here it is saying two files are changed and there is one insertion which has been done. Okay, now again the create mode, blob and file.txt. Now when I do ls hyphen ll, you'll see the new file is present. And now when I do cat to the new file of text, you will see new line from feature is present in our master. Now again, when I do git log -1 line, the commits from feature are also present into the master branch, right? Right now, our head is pointing to both branch, that is master and feature. Now, Shubham, what will happen if I delete the feature branch? All right, so let us delete the branch. So git branch -d for delete and followed by the branch name. Okay, now we have deleted the feature branch which was pointing at this hash. Okay, now let me clear and do git log -19. You'll see now the head is pointing to master because the feature branch is deleted. But even after the deletion of feature branch, core changes are still present there. Okay. Now let us validate the same ls-ll. You'll see the new file is present here and the file name.txt is also present. Now when I do cat to new file, you'll see the new line from feature is also present. This validates even after the branch deletion. After merging, if you delete the branch, or changes will be present over there, right? When I say there, it is the master branch. Okay. Now, this is the place where you will say that, yeah, the changes are done, we are good to go, and we can deploy the changes into the production. Okay. Now, if you want to do further enhancement, you will create a branch from this specific checkpoint, and then you will do the further development. Once the changes are done, you will merge into master, right? So this is called fast forward merge. Now moving forward to the next one, that is three-way merge. So basically it will combine two branch and have a divergence by creating a new merge command. Okay, here we are going to try one more thing, that is ORT. What is it? I'm going to tell you in the next one. And also one more thing that we are going to demonstrate is the merge conflict. As I mentioned earlier, merge conflict occurs when you are editing the same file in the same line, right? Okay, so how to perform three-way merge? So basically you will create a main branch which will contain the history from ABC. Then you will create a new branch from B standpoint, and then you'll add two more commits. And when you merge, you'll definitely face merge commit, and then you'll see that the thing that we performed is basically a three-way merge. ORT, operational transformation strategy, is also the same like three-way merge. So basically, let us go through the theory. Okay, the ORT, that is operational transformation strategy in Git, is a default merge strategy. Okay, because the command remains the same, that is Git merge. Okay, it is used for resolving complex merges. It efficiently handles multiple changes across the branches, ensuring accurate conflict detection and resolution. Now, what are the features of ORT strategy? First, it is faster and more efficient for large code base. Second, improved conflict detection. Third, handles directory names and path changes better. Fourth, basically reduces unnecessary merge conflict by improving file matching accuracy. Now, when to use ORT strategy? So basically, when it is used, basically it is automatically applied when we make use of Git merge for complex scenario. And secondly, it is ideal for solving three-way merge with divert branches. Okay, so that is the reason why ORT and three-way merge are actually related to each other. Now, if you want to see a visualization for both of them, so basically this is the diagram that represents the same. What is currently happening over here is we have a baseline branch, and from B standpoint, that is from B commit, we have created a new feature branch. Okay, in that feature branch, we have added a new additional commit. Okay, now what will I do? I'll be merging the changes, I'll get a conflict because the same file has been referred. Okay, and that's the reason you'll feel the merge conflict, and this is how you will be doing three-way merge and ORT strategy at the same time. Here we are going to make use of Visual Studio Code, for which we have been waiting for long. Okay, now first of all, let us go to the theory, whatever it is trying to say. So the diagram key elements: commit B is the ancestral branch, the starting point. Commit C is the latest commit on the master branch, and then a commit E, latest branch on the latest commit on the feature branch. So here, initially the header will be pointing to the master. Now, once you create a new branch, the head will point to the feature branch, and once the merge conflict is solved and the changes are merged into master, the header will be pointing to the main branch. Okay. Here, merge conflict node, it's typically a complex scenario where the ORT can efficiently resolve. Okay. Now, the conclusion, this diagram illustrate both three-way merge and the ORT merge strategy, right? So yeah, let us do the demonstration for the same. All right, let us go back. Clear. Okay, let me create a new repo for you to understand how ORT and three-way merges are done and how we are going to do the merge conflicts. Okay, so let me just create a new repo, that is npdir merge master cd. I need to rename it. So yeah, if you want to rename any repository, so basically you can make use of nb also. So this is the repo which I want to rename, and this should be the new name, merge master. Okay, now when I go inside merge master and I need to do git initialization, let me just do a clear. All right, now I am currently on master. So as per this diagram, what we are going to do is we are going to add an initial time. So when new file dot text, this is from main escape colon wq git add dot get commit hyphen m. This will be the a commit. Okay, I am just specifically uh, replicating the diagram which I have created so that it will help you to understand how three-way and ORT strategy is been done. All right. So yeah, a commit is done. Now second, what I'm going to do is I'm going to add a new file. Again, file one dot text. This is from main again. Escape colon wq git and file one git commit hyphen m. This is branch. This is commit b. Now when I do git log hyphen hyphen one line, you will see we have commit a and commit b. Cool. Now from this specific standpoint, I'll create a new branch, that is git checkout. Okay, hyphen b followed by the branch name, that is feature. I created a feature branch from it and I switched into it. Now what I'll do, I'll add few more commits. So what I'm going to do is I'm going to open file one.txt, and here instead of this is from main, again I'm going to replace this main by feature. So this is line one where we are expecting that conflict to occur. Git add file one.txt git commit hyphen m, and here as per this diagram this will be the commit d. Okay, done. All right. Next would be the further enhancement. So for that, what I'm going to do is I'm going to add a new file. So touch new.html, and here I'll write. I'll again, uh, you know, okay. Let me just add some content into it. So vim new.html, and here I'll write body hello. Just adding random text. All right. So yeah, let's say this is the content that we added. Now I'm going to add it into a staging area. Git add new.html, git commit hyphen m, followed by the commit next one, that is e commit e. Okay. Now when I do git log hyphen hyphen one line, you will see we have commit a, commit b, commit d, and commit e. Okay. Now let us check out to master branch. Git checkout master. Okay. Now again, when I do git log, you'll see we have commit A and B. The changes that we had on feature branch are not currently present over here. So for that, what I'm going to do is I'm going to add few more commits. So here, when I do ls, I'll change the new file. So when new file, here this is from main branch. Okay, I'm going to add a new line. This is another text. escape colon wq, git add new file, git commit -m, and this would be the c commit. Okay, now when I do git log hyphen one line, you'll see we have commit A, commit B, and commit C. Now the header is pointing to master, and this is the commit where it is pointing to. All right, done. Now we are done with the initial setup. We have created a commit A, commit B, commit C on the main branch. From commit B standpoint, we have created a new feature branch and we added two more commits. Okay. Now what we have to do is we want to merge the changes from feature branch to master. How to do it? So the commands remains the same. The only thing is we are going to face merge conflict this time. So yeah, git merge followed by feature branch. And here it is saying that since you are performing uh, merging, there is a merge commit that you have to mention. All right. So here I'll write git branch feature. Okay, merging branch feature and adding additional changes. Okay, escape colon w2 to save it. Okay, now here it is saying that merge is done by ORT strategy. This time we didn't face merge conflict, so why? Let us check that. First of all, let me do ls. Okay, and what I'm going to do is let me just do cat for new file, because a commit merge conflict was expected. This is another line. Okay, and second one was when we are going to do a cat on file1.txt. Okay, and here it changed the line from this is from feature again. Okay, now the next thing that we want to do is let me just check out to it, check out feature. Okay, and let me just edit the file1.txt I, and here I am going to write few more lines, few more lines, skip colon wq, and git add dot git commit -m new git checkout master. Okay, clear ll. And here what I'm going to do is I'm going to edit the same file, that is file1.txt, and I'm going to delete this line, or I'm going to keep it till here again. Skip colon wq, git add dot git commit -m merge on. Okay, now git status. Okay, now git merge feature. Now here you'll see it is saying that auto merging file1.txt. There is a conflict, merge conflict in file1.txt. Okay, automatic merge failed. You have to fix the conflict and then conflict the result and then commit the result. So for that, what you need to do is run git status. Here you see both modified, because in feature branch also you have modified the same file. In master branch also you modified the same file. So what you have to do is vim file1.txt, and this is how a merge conflict happens. Okay, here it is saying that earlier it is showing that a gain is present in the current branch, which is where the header is pointing to, and these are the incoming changes. How to solve it? So basically you just need to remove this thing manually. Okay, and based on the changes that you want to keep, you will just remove it and you'll accept the changes, escape colon wp, and the changes will be done. But is there any shortcut? Is there any good way that you can do? Yeah, we can do it using Visual Studio Code. So let me open this on Visual Studio Code. So code dot. All right, VS Code is here. When I go to file1.txt, here it is saying two things. The first thing is, do you want to accept the current changes? Now, what are the current changes? Here, where the head is pointing to. And second is accept incoming changes. This is the one it is talking about. Or do you want to accept both the changes? Okay, so basically here I want to accept both the changes, that's why I'll click here, and that is how we solved the merge conflict. Okay, I'll just save the file by Control S. We'll go to the terminal again, git status, git add file1.txt, git commit -m merge solved. And when I'll do a cat for file1.txt, you'll see both the changes are currently present over here, right? So yeah, that was all about Git merge conflict, and three sort of strategies that we have in Git. Okay, so let me just do a revision. Today we learned about what are Git merge. There are three types of merging that we have. Okay, one is fast forward merge, second is three-way merge, and third is ORT merge. What is Git conflict? When you change the same file, same line, you'll feel the merge conflict. Okay, and then the next one is fast forward merge. When you'll see when you want to keep a plain history of the branch, you'll make use of fast forward merge, where you are keeping a baseline branch from that specific standpoint. You are creating a new branch, and once the changes are done, you are going to merge the same branch. Okay, so basically your header will point to the two branches. Now the second one is three-way merge and ORT merge. Okay, which we saw. Basically, we created a branch. From the standpoint, we created a new branch. We did few initial commits and then we merged those changes to the main branch. Now here we faced a merge conflict and we solved it using Visual Studio Code, right? So yeah, that was all about today, where we learned about merge conflict and how we perform merge. We saw three sort of merging strategy, right? And yeah, that was all. In the next session, we are going to see about GitHub, how to set up a GitHub account, and how do we work with a remote repository, right? That was all, and see you in the next one.
All right, so time to start with sixth section where we are going to learn about GitHub, where we are going to create a GitHub account. We are going to see how does the UI looks like, and we are going to explore GitHub, right? So yeah, let's get started. So for this, we are going to go directly to github.com. So this is the UI of the actual page where we are going to spend a lot of time. Okay, so this section specifically is for the people, those who haven't created their GitHub account. But if you have your account already, feel free to skip this section. All right, so yeah, let's get started. So let us create a new account on GitHub. So let me write my GitHub account. So I'll write Siddharth at gmail.com. Sign up for GitHub. All right. So here it will ask you to fill up this form. So you just need to enter your username and password, whatever you prefer, and based on that, you can proceed with it. So yeah, let me just write the password for it. Username would be all right. Country would be India, and you can just opt out this thing and click on continue. It will ask you to verify your account, and then you can take a visual puzzle or an audio puzzle. Let's take a visual one. Okay, now it has sent you one code which you might have received on your email. So let me open the email address, and here it will give you this thing. So copy the code, go back to the page and paste the code and click on continue. Okay, now your account is created. Now you may log in with your username and email address, right? So let me log in with my username which I selected while filling up the form. So this would be Siddharth RG. That was the username which I chose while I was creating the account. And let me just log in with the password which I just put while I was creating it. So yeah, this is how the UI of GitHub looks like. So right now you are in the dashboard. It is the home page which will be redirected to you when you first time log in into it. This is the feed section where it will give you some tutorial regarding GitHub, GitHub Pages, Code with Copilot, and GitHub Actions. Okay, so GitHub Actions, Copilot are the products of GitHub itself. Okay, and here you can just explore it. Okay, so let me just tell you what are the things that you have to take care of while you are just exploring it. Okay, so here on the top right corner, you can see this green badge. This is the place where you'll be mostly navigating because you can navigate to your profile. Okay, you can see the repositories. Okay, you can see the projects that you are working on, the packages and the stars. Okay, stars meaning if you like any projects in GitHub itself and you would like to mark it as an important thing, you can mark it as a star, right? Now, what is this thing? This is basically tracking whatever changes you have done in an entire year. It can be tracked over here. Okay, so this green dots mentions when and on which date you made the contribution for, right? So yeah, so since we joined it on April 2025, it is showing that you joined GitHub on this specific date, right? That is also been tracked. Here, if you go to repositories, you'll find repositories which you have created publicly and also the private ones. Now, Shubham, how do I create a new repository, right? Because till now we have been doing it with command line, we have been creating it on local, but how do I create it on GitHub itself? So here on top right corner, you'll see new button. Click on new and you can just write a repository name. So the repo name would be, let's say, GitHub tutorial. Okay. Now you need to keep one thing in mind that this thing Siddhartha is the username, so it will make your repository unique across. Okay. Now whether you want to make it as a public repository or private repository, you can choose as per is. But what do I mean by public repo? Basically, public repo is like anyone can see. Private repo only specific people can see, which whom you will giving the access to. Okay. There is a readme.md file. So basically, do you want to add a readme.md file so that the people can get a gist of what this project is created for? For now, you can opt it out and just click on create repository. Now you can see the repository is now created. Now what it is asking, you can just follow these steps to do the first commit and your file will be present over here. Okay, let us go back to GitHub tutorial. Let me go back to the profile again, and here you can see your file. Okay, the repository is present. If you go to repositories again, here the number indicates that there is only one repository created in your account and which is updated just now. If you go inside it, this is how it looks like. All right. So yeah. So here you can even mark it as a star. Okay. So it will be highlighted into the star section. So let me go back again to your profile. And here, if you go back to star, your profile will be listed over here. Okay. Yep. All right. So let's do the first commit on this specific one. You can do it using command line. So yeah, let's do it. So let us clone this repository first, and or else if you want to do a commit in GitHub itself, how would you do it? You can just include a readme.md file. Okay, or you can create a new file. Click on create a new file, and here just write first .txt. This would be the file name, and here I'll write hi. This is my first file in GitHub. Okay. Now once done, click on commit. Here it would be your commit message. Now, as we discussed earlier, if you're working in a big organization, you need to follow some AB hash value, right? Because you won't be the only person who will be working the project. But for now, since we are learning, let us give a weak comment. That is create first commit. Click on commit changes. Now, what is happening here is you have just created a file and it is present over here. Now, Shubham, earlier we used to run Git log, okay, and there we used to see the commit made by the person when it was made, right? You can go it over here. GitHub actually keeps the track of all the changes that you have done so far. So here you can see the commit ID and against which what changes were made. Okay, so this line was added. That's why it is saying that against this commit in the main branch, this file has been added. Now, what will happen if I just make some modification over it? Okay, so let me just go to the file, click on edit, and GitHub. Okay, GitHub website. Okay, and here I'll write one more line. This is another line. I'm adding two more text. Update on the existing file. Now, if I go to history again, you can see there are two commits which are present. First is create first and second is update first. If I go to update first, you can see the earlier line was changed to GitHub website and there is another line which was done. So file changes, two lines in total and there is a one line which has been modified. Okay, that is how you read it in GitHub. And this is the commit against which the change was made. All right. Now, Shubham, we learned about branches. Now, let's say this is my baseline code, which is ready. Now, I want to create branch from this specific point. How do I make it? Can I do it using CLI? Yes, definitely. And we have already seen it in the previous section. But how to do it in GitHub? It is very easier to create branches in GitHub. Okay, so let's say this is the main branch, and now I want to create a pre-release branch. So I'll just type pre-release, okay, and just click on this thing, and your pre-release branch is now created over here, right? Now let's say you are adding few files over here. So let me just add file. So I'll just write new hyphen file dot txt. So this file is from pre-release branch. Okay, and let me just comment it. And the commit is done. All right. Now what will happen over here is it will say that a new branch has been detected and there is some push which is present over here. Now when I go to pre-release branch, okay, here it is saying that this branch is ahead of one commit from the main branch. Okay. Now main branch is the default branch. Now Shubham, how do I set a branch as default branch? For that, you just need to go to settings. Okay. Under settings, here you have the option for setting the default branch. Okay. So when I go to rename branch, okay, here you can rename, basically here you can switch the branch to another branch. So here I can change it to a pre-release branch, and here this label will be transferred to pre-release. Okay, and that is how you change the default branch. Okay, then now this thing is also done. Now the last thing is, now let us think that we want to have this remote changes into our local. How do I do it? So just go to code, copy this link, okay, and let me just open item. All right, and here what I'll do, I'll just go navigate to desktop. So cd desktop, and I'll just run git clone to clone the repository which is stored in the cloud into my local. Now, when I do git clone, that remote changes will be present in my local. How do I validate it? Let us try this. So cd GitHub hyphen tutorial. This was the repo name. Okay. Now here you can see it is detecting the main branch. Now when I do ls hyphen ll, okay, here you can see first.txt is present. Now when I do get branch, okay, it is showing one branch. Okay. But the thing is, let me just enter q and I'll just run get branch hyphen all. Here you can see the header is targeting to the main branch. Second, there are pre-release branch which is also present over here, right? Let me just quit it and let me switch to pre-release branch. Git checkout pre-release. Now, when I do ls-ll, you can see the second file is also present. And when I do a cat hyphen new file, you can see this is from pre-release branch. And this is the exact same text which we have written in pre-release branch in that specific file. And the file name is new file.txt. And this is from pre-release branch. Now, let us verify the commit. So, git log hyphen one line. These are the commits that we have made so far. So whatever we do on GitHub is possible with GitHub CLI, right? So in this section, we just learned about basic Git, okay, where we just created an account, where we created one repo, where we learned to create one branch, where we learned how to we can change a default branch, okay, and how we can take a remote clone from how we can take a clone from remote to local, right? So yeah, that was all. Now in the coming section, we are going to see the basic operation that we can do in GitHub, right? So yeah, that was all, and see you in the next one. All right, so in the previous section, we learned about how we can set up the remote repository. We learned how we create a GitHub account, and we just do the basic operations in GitHub that is on remote repository. In this section, that is in section 7, in operations, we are going to see some usually used commands which are used in software development on a regular basis. If you can see on this particular diagram, we are moving the code from one stage to another stage. You can see the initial place where the code is been present is on the working directory. Post that, we move the change on staging area. Now, once we are done with the changes, we move the changes to Git repository. Okay. And then finally it moves to the cloud, that is remote Git repository. In our case, it would be the GitHub account which we created. Okay. So initially, in order to move the changes from working directory to the staging area, we make use of git add followed by dot or the file name. Now, what is the significance between dot and file name? If you add dot, it will include all the files which were modified in the working directory. But if you want to move a specific file, okay, you will use a specific file name. Okay, now let's say we move the changes from working directory to the staging area. It's time for us to commit the changes and move it to the Git section, that is on .git folder. How would we do that? Okay, we already learned about SHA-1 hash. Okay, so in order to do that, we will need to generate a SHA-1 hash, right? That can be done by using git commit. So once the changes move into staging area, we'll move it to the Git repository by using git commit. Now the next thing would be, now since we are satisfied with the code which we have developed, we would move the changes to the remote repository, that is on the GitHub repository. Okay, so we'll make use of git push. Okay, now let's say there is a scenario that multiple developers are working at the same time on a same repo. How would you make sure that a person S has made the change? Okay, now let's take an example, a vague example, that we have two people, Lucky and Saptadeep. Okay, so these are the two developers, those who are working on the repository. Now, Lucky has done the push. Okay, so he moved the changes from Git repository to remote. But on contrary, Saptadeep did a design. He pushed it onto the GitHub repository. But does Lucky have those changes present in his local? No. Why? Because those changes are not present, and in order to make those changes present in the local, we make use of two commands, that is git fetch and git pull. Now, Shubham, what is the difference between git fetch and git pull? So this is the specific section in which we are going to cover these both command. We are going to see what is the key difference between both of them. Okay. Now, what is the difference between git fetch and git pull? So the basic difference is, in order to bring the remote changes into our local place, we make use of git fetch. Now, what is the purpose of git pull? Okay, so whatever changes are present in the remote, we will move it to the local, but at the same time, we are going to merge those changes in our local changes, right? How do we do that? We are going to see in the same section. Okay, let us move. So before even proceeding forward, let us first understand and clear our vision with local branches and remote branches. Okay, so the first is local branches. Now, Shubham, what do you mean by local and remote? So see, the terminology is only defining the purpose of it. Local meaning something which is present in your laptop. Remote meaning which is not present in your laptop, but it's stored in the cloud, that is on your GitHub account, right? So here, local meaning something which exists on your computer. You can edit, commit, and test the changes. Now, once you're satisfied with the changes and ready to share it with the world, that is on the open source platform, you will make use of git push. Okay, now once you do push, those local changes converts into a remote change. Okay, so yeah, local branch done, the branch which is present locally into your system. Remote branch is something which is existing on the remote server, right? So exist on a remote server, for example GitHub, it may be Bitbucket, it may be GitLab. Okay, the SCM whatever you use, okay, you can make use of fetch or pull to bring the changes from the remote to your local. Okay, for example, here the origin would be main, and in the earlier one the origin was main or feature one because it was a local change. Now, tip, we can use git pull to sync all the local branches with the remote one. Now, what is the meaning of that? Now, let's say Saptadeep was working on a design and he did push some changes on Monday 21st. Okay. Now, on Monday 22nd, he was on a leave, but a developer X was working and was continuing Saptadeep's work. Now, on 23rd, when Saptadeep is coming back to office, okay, he want the changes which was done by the person X. What would he do? He will make use of git pull because he want those changes to continue his work and get started with it. Okay, so yeah, that is the significance of git pull, to stay updated with the pull changes that is present in the remote repository, and that is how you bring the remote changes into your local server, right? Okay, moving forward, the next one is we are going to learn about origin. Now you might be wondering, every time when we make use of git pull, git push, okay, the header targets to the origin. What is the general meaning of origin? Origin signifies the zeroth point from which the change starts. Okay, here it has a resemblance with the header. What do I mean by that? So basically, origin is the default name given by Git, which gives the remote repository the permission, the authority to clone a project. What is the purpose? It acts as a shortcut to refer a remote repository. Second, it is used in commands like git pull, git push, and git patch. Okay, so here basically origin will target, okay, what is the origin at the current place? So here is what origin is coming from. Okay, this means pull the latest changes from the main branch of the remote server and bring it into the origin, right? So that is something we call as origin. Moving forward, okay. Next, we have few commands which we are going to demonstrate in this same video. The first one is git remote. Git remote is essentially used as an interface for managing the remote entries that are stored in the repository. Okay. Second is git remote hyphen v. Hyphen v is an abbreviation, an attribute, or an option which you can say, where if you use hyphen v, it will show you the remote repository URL. So let's take an example. Let's say you are been given a task. Okay, and now your developer lead is absent, and in his absence, you are supposed to work because you cannot stop your work because someone is not present in the office, right? So in your working place, just a person X is not present, and you need to start your work. Okay, you have created a local repository, and then you convert it into a Git repo. How do you convert a normal repo to a Git repo? You just initialize the command, that is git init. So by initialization, it will convert a local repository into a Git repo, right? So now you forgot the developer lead ask you what is the origin of it, or like what is the name of the repo that you created. So for that, you may use of git remote. It will show you the URLs from which it is pulling from and from which it is pulling to. Okay. Next is git branch hyphen I. It will list all the remote branches. So all the branches which are present at the git server. Okay. Next is git branch hyphen vv, which shows the local branch with the tracking and remote branches with the latest commit message. Last one is git remote show origin, which displayed a detailed information of the origin, which includes URL, track branches, pull and push merge settings. Okay, so let's demonstrate the same. So for this specific demonstration purpose, I have already created a approval admin repository, which you may find on my GitHub repository. So this is the repo that I will be referring to, and which you can clone and you can start working on it. So how do I clone? Just click on the screen dot, copy the URL, go back to your terminal and just type git clone. Okay, you may use this command git clone followed by the URL and press enter, followed by just do a cd to change the directory from your desktop to the approval admin form. Okay, now post that I have listed ls-ll to show you what all files are present. Okay, now if I want to see how many branches are present in this specific remote repository, I'll just run git branch. Okay, and here it is saying that there is only one branch which is present. Now Shubham, okay, one thing which I observed is here you can see there are 5 branches which are currently present. Then why only main branches cloned? So see, if you remember, while we were creating the GitHub account, I showed you how you can set a specific branch as a default branch. Okay, so basically here you can see the main branch is by default a default branch. Okay, that's the reason that only one branch is cloned, and you can see the main branch to be cloned over here when you run git branch. Okay, now let's run these commands and check what are the outputs. So when you run git remote, okay, it will show you the origin. Okay, now next is it is used for an interface for managing the list of remote entries that are stored in the repository. Now second is, I said let's say the developer lead is absent and you wanted to start a work. You created a repository but somehow you forgot the name. How do you make sure that the repository name which you have entered is the same as the one which you are pushing it to? So for that, just run git remote hyphen v. Here it will show you the origin from where the data has been fetched and the origin from which the data has been pushed. All right. Okay. Now next is git branch hyphen r. Okay, which will display the remote branches. So git branch hyphen r. Okay. Now let us compare with the remote one. So here we have something called development, feature 100, feature 200, feature 300, and followed by the default branch, that is main. Here if you compare, so these are the ones branch which are present at the remote. Okay, the origin signifies that these are the branches present in the remote server. Shubham, how do I make sure that the local branches are also be present? So yeah, let's do the demonstration. I'll just create a git checkout hyphen b for creating a branch and checking out to the new one, that is new branch local, and I am checked out to the new branch. Now when I run git branch hyphen r, it is again showing me the same data. Okay, here you will see the new local branch is not present. Why? Because the origin is only signifying that I am currently showing you the branch which are present in the remote server that is on your GitHub account. All right. Now moving forward, git branch hyphen vb, which shows the local branch with the tracking. Okay. All right. So when I do git branch hyphen vb, you can see this is the branch. Okay. This is the branch which was created right now. but it is not present in the remote server. That's why you will see the asterisk, which will define the asterisk as in the current header pointing to the new branch. Okay. Also, the main branch is been cloned from the origin server, but since it is the default branch, here we can see origin slash main, since it is coming from the remote. Also, since it is present in the local, that's why the two branches are present. That is new branch local and the main one, followed by the hashes. Since I created the new branch taking main as a reference, that's why both the hashes are same. Okay, so this we will cover in the history section, where we will be learning in depth about how do we recover a change from a specific point in time. Let me quit from here by pressing Q. Now git remote show origin. Now we want to see a detailed information, so I'll just run the same git remote show origin. Okay, here it will give you the latest changes, whatever are currently present. See, it will give you a detailed information of the remote branches and the local branches which are present. So the remote branches are development, feature 1, feature 2, feature 3, and main. And it is showing that all the branches are being tracked. What do I mean by track? Meaning all the changes are up to date and you can just check it out and you can just use the changes. Now, second is the local branches. Okay. And it will show that main branch merged with the remote main. Okay. And main pushes to the main, which is already up to date. So that's the basic difference. And it will also show you the output of git branch hyphen v, that is fetch and push changes over here. All right. So yeah, moving forward. Now, again, moving with the same question back, that is, what is git pull? So, git pull is a command which is used to fetch the changes from the remote repository and merge them into your current branch. It is a combination of git fetch and merge. Okay. So, for this, what I'll do, I'll just go to the branch. In the main branch, I'll just do some modification in the file. So, in this, I have init.sql and I'll make some changes in this init.sql file. So here we have something called current timestamp, and I'll just add one comment over here and just write adding remote changes. Okay, now once the remote changes are being added, I'm just going to commit it. Okay, now since I'm just doing it for demonstration purpose, I'm not just updating the commit message, but it is a good practice to define a correct or descriptive commit message, because see, this is a single branch ownership. Okay, this is a single repo ownership. I am the only owner of this repo, so I can write whatever commits I want. But since if you are working with multiple developers, multiple people at a time, you are supposed to write a descriptive commit message, okay, which you can use from the Jira ticket that has been allotted to you. All right, moving forward. Now, see, this comment on line number 7 is not present in my local. Let us verify the same. Git checkout main. Now you can see the origin is targeting to the mail. Now when I do ls and when I do cat.init.sql, you can see at line number 7, okay, that comment, the one which we added, is not present. Now if I want to pull the changes from the remote to my local, we have something called git pull. But what it will do, it will fetch the changes plus merge the change in my main branch. Okay, let us do the same. So when I do git pull, it will take the changes from remote, okay, and then it will insert it into the current file. Now when I again run a cat SQL, it will show the adding remote changes in the file itself. All right. Okay. Moving forward with the next one, that is git fetch. Git fetch download the updates from remote repository without changing your working branch. Okay. It keeps your local branch of local copy of the remote branch and keeps you up to date and lets you review the changes before even merging it to it. Okay. Let us demonstrate the same again. I am again going to take the example of init.sql, and this time what I am going to do is I am going to revert the changes. That is, I will remove line number 7 from here and will correct it. So this is for revert init.sql and I am going to commit on the same one. All right. Now let's go back, and here what I'm going to do is first let me clear the screen, and what I'm going to do is I'm going to fetch the changes. So git fetch. Now one question here is, Shubham, you didn't mention the branch name. How do Git know to fetch it from? Now, if you remember, it was the origin branch, the main branch, the default branch. So that is how it knows where to pull the changes from. But even if you write git fetch main, that would also do the same thing. Okay. Here it will say that enumerating objects done. It will count the objects compress the object, okay, and then it will find the delta. On what basis the delta has been found? The base changes plus the changes which are present in remote. So it will compare two changes, and that is how it will find the delta. All right. Now, what is delta? How do we find is basically we are going to explore in the furthermore sections where we are going to learn in depth about git diff. Okay. Yeah. And here these are the hash differences that will tell the changes made from and made to. Okay. Yeah. So that was all about git fetch and git pull. Now let's do a final comparison between both of them. So basically git fetch downloads the changes from remote repository but does not merge them into your local branch. But git pull on contrary fetches the branches changes automatically and merge them in your local branch. Okay. We can use fetch to merge the changes but with a review, but pull without even review. All right. So yeah, that was all about this section where we learn about git fetch and git pull in depth. In the next section, we are going to learn about pull request. I'll just give you a brief idea about pull request. So basically, you are going to work with multiple developers. There will be a lead who will be reviewing the changes. It would be hard for him to go to the branch and check every time. For that, you will be making use of pull request. Now, what it is, basically, you will raise a PR where the code changes will be present. There will be a part A, there will be a part B. Post those comparison, he will make a decision that yeah, we are good to make and merge the changes in the main branch, right? So yeah, that was all, and see you in the next section. Bye.
Alright, let us start with section 8 where we are going to learn about GitHub pull request. Now, as I said in the previous section that what pull request is, basically when you want to merge your change into the master branch, which is also known as the production branch, we make use of something called pull request. Now, why it is required, Shubham? Okay, now see, there are multiple people which are working in the organization, right? There needs to be a review required whenever we are merging the changes into the master branch, right? That will help us to reduce the bugs and the errors, right? Okay, so let us see the actual definition. A pull request is the way to propose a change that you have made in a git branch to be merged into another branch. In our case, it would be the main branch. Okay, now how does it works? Okay, so basically you don't merge your code directly into the master branch. You create a replica of the branch, you make your commit there. Once the changes are ready, then you push the changes to GitHub. Post that, you will raise a PR. A PR is reviewed by dev lead, and then once it is approved, it is merged into the main branch, that is the production branch, right? So let us see, here it tells that the developer will create a new branch, that is the feature one branch from the source branch. Okay, so let's take the example as main branch as the production branch, where you will be merging your changes. So from main branch, you will create a feature one branch. In that feature one branch, you will add the code, you will commit it, and then you will push it to the central repo, that is GitHub or GitLab. Post that, you will raise a pull request. Okay, and in that pull request, it will literally run a diff, okay, from main branch to the feature one branch, and whatever commits that you have done in between them will be acting as a pull request. Now post that, a reviewer will be requested where it would be your dev lead, okay, and then once he approves the changes, then the changes will be merged into the production branch. Now, why we should consider pull request in the first sense? Okay, it will enable you to help you with the code review and documentation. Okay, the first thing that it will do is it will help you in applying the code review process. Second, it will help you in collaboration. Okay, because when I say collaboration, let's say some sort of changes required, before even approving the changes, he can add some comments there. And when I say he is the developer, senior developer, right? Once the changes are approved, then the changes will be merged into the major branch. Okay, so it will help you to improve the code quality. It will help you to track the history by the PRs, and it will help you to prevent the bug and errors, right? So let us see pull request in action. For this specific change, we are going to make use of two repository. First is Siddhartharji, and second is my personal account. All right, okay. So let me create a new repository in Siddhartharji account. So yeah, let me click on new. Here I'll write GitHub pull request, and we are going to make it as a public repo, and then we are going to add a readme MD file. Okay, the repo is now created. Now let me just clone the repo. So for cloning the repo, we have the command git clone. Okay. All right, let me go inside the repo, that is GitHub pull request, and we are in the main branch. Okay, now as we discussed, okay, we are going to create one feature one branch. Okay, and through which user I am creating the changes, the branches, basically it would be this account. Okay, so I'll just write git checkout -b, and it would be feature -1. Okay, the feature one branch is created. Now what I'll do, I'll just add few comment over here. I'll create few files. So touch new, it would be 1 till 5 dot text file. I'll do git add dot to add it, and we are moving it to staging. Then git status again. Okay, then did commit -m, adding the baseline code. Okay, now git push origin feature one. Now question number 1, will this change get published into the feature one branch, or will it get published over here? The answer is no, because this is some another account, okay, which doesn't even have the access to push the changes over here. When I press enter, okay, here we are getting an error. It is saying remote permission to Siddharth Darji, okay, GitHub pull request is denied to the user, the Shubham. Okay, we are unable to access this repo, okay, and the URL returned with the error 403 because there is a permission error. Okay, now coming up to the interesting part, that how do we assign a permission to a specific user. So for that, we'll go to the repo itself. We are going to go to settings. Here we have something called collaborator, and then we are going to invite Shubham as a collaborator for this specific repo. Click on add people, and here you're supposed to write the username of the user. Now where do you find the username of the GitHub profile? Go over here. Okay, usually when you go to your profile or after this .com/, this is basically your username. Okay, so let me just copy the username and I'll just paste it over here, and here it has searched for my user. When you click over here and click on add, there will be a mail sent to Shubham for accepting the invite. For now, the current status is pending invite, and as you can see, the mail is been received. Now let me just go over here and open my Gmail, and this is how you receive the email invite. So click on view invitation and click on accept invitation. All right, now Shubham will act as a collaborator, and now he has the permission to push the changes on this repo. Now let me go back again, and here you can see in the branches section, there is only one branch which is currently present. When I go and rerun the command again, it will push the changes to feature one. All right, now when I go back again and when I do a refresh, feature one branch is also present. All right. Now the next thing is, how do I raise a pull request from feature one to main? Okay, you just need to go to pull request, and here you need to click on new pull request. Okay, and here you need to define the source and the destination. So here my destination is main, obviously, and my source is feature one branch. So it will run a diff and it will tell all the changes which are present in feature one, which is not present in main, can be reviewed, and then you can create a pull request. Here you can write the baseline code, and here you can just write the description of the changes that you are making. Okay, so this is PR#1 PR1. Okay, and when you go to preview, it is just like a markdown. Okay, and then you can just click on pull request. Now the initial thing is done. The pull request is now created. You can directly merge it, but if you want someone to review your code, you can just go on reviewers, and here you can select the person. Okay, now he or she will receive one mail regarding the review. Okay, post the review is done, you will be able to merge the changes. Okay, now the second is if you want to add any label. Now what is the meaning of label? Okay, so let us go back, and how do we create a custom label? So basically, go to the label, and here there are multiple labels which are already created by default. Okay,
So label is something which is used for identification, whether it is a bug, whether it is used for documentation. Just for identification purpose we make use of labels. So let's go here and let us click on labels, and let's say if you want to add this thing as a enhancement, okay, this label will be added in your pull request. So go over here and you can see the enhancement label is now created. Now when you click over here, okay, and if you want to create a custom label for yourself for your ease, you can go and create new label and just write development started, okay, and just click on create label. Now when you go back to pull request and click on this PR, you can go to label again, and this time your custom development started label is also visible. So the next time whenever someone goes to pull request, he or she will be able to identify with the help of the labels. Okay, labels are just used for identification purpose. Okay, and yeah, let us go back to this account, and here we might have received one mail for the review. Okay, and here it is saying that okay, this is PR1, and here we need a review from your end. Okay, and here this person is a dev lead, so he will go to the commits, he will check, okay, so these are the commits which are made against the file, and these are the files which are introduced. Okay, he will go to review changes, approve, and he will add a comment. So good to go, good to proceed, and submit review. Now once he submits his review, okay, we can go back again to the pull request. Okay, 1 second. All right, and here you can see the author added the comment, and he says that things are good to proceed, and then we can merge the pull request, and that is how we merged our first pull request. Okay, and then you can delete the branch as well. Okay, now the second question is, now what will happen if I raise a PR again? Okay, but before even merging I am adding few more commits. Okay, will it still be a part of the PR, or will it be considered as something else? Let us do the practical again. Okay, so we are in the terminal, and let me just switch to the main branch. So git switch main. Okay, and we are in the main branch, and now let me just create another branch. So git checkout, and before even that, let me just take a pool. So git pool, because we just merged the changes and it will be present in the main branch. Now when I do ls, all the changes which are present in feature one branch is now present in the main branch. Let me just create a new branch from here. So git checkout -b for new branch. So new feature. Okay, and we are on the new branch. I'll just add a few content. So vim new one.text, and here I'll write, hi, this is new text, escape :wq, git add dot git commit -m new text, git push origin, and this time the origin would be the new branch, that is new -fit. Okay, and the changes are pushed to the new feature branch. So when I go to the pull request, okay, and here when I go to the new feed branch, in the new file you can see the new text is present over here. Now let me raise a pull request over here. I'll just go to pull request, create new pull request, and this time it will be the new feed branch. Okay, the commit and the text which has been added over here. All right, create pull request. Okay, and here I'll write, this is new text enhance. Okay, writing a dummy text, and then create pull request. All right, now the challenge was, whenever a PR is created and before even merging, if I do a commit, okay, will it be a part of this PR or not? Let us demonstrate the same. Now the PR is created against main branch from new feature branch. What I'll do, I'll just add few more commit. Okay, ls I'll add commit in the new file, that is text new file. This is after the PR is raised, escape :wq, git add new file to git commit -m after PR, git push origin, new fit,
Okay, now these changes are also pushed. Now when you go back here, you can see the second commit is also present. Okay, because these changes are pushed, okay, before the PR is been merged. Okay, now when I go to conversation again, and here I can just mark this pull request and I can merge it directly without any issue. All right, so there is one more thing which I want you to tell. Okay, so let us first merge it and delete the branch. All right, when I go to GitHub pull request and when I open new file, you can see after PR changes is also be present. Okay, now let us go back to the slide. Here we are going to learn something called locking of branch, that is branch protection rule, because we don't want anyone randomly merging the changes into the main branch. What can we do? We can add some branch protection rule, that is we can lock that branch. How do we do it, Shubham? So we can just go over here. We need to go to settings. Okay, here we need to scroll down and here we have something called branch protection rules. Okay, all right, so we need to go to settings and here we have branches, and under branches you have to click on add branch rule set. So click on add classic branch rule set, and here you need to type out the branch name. So here it would be main, which we want to lock, and here just search for lock branch. So this will make the branch as read only branch. Okay, and whenever someone tries to merge the change into that main branch, he won't be able to do it. All right, so let us try the same. So what I'll do, I'll just add one more thing. I'll just remove one of the file rm-rf new text file. Okay, git add dot git commit -m, removing new file, git push origin new -feet, origin. Okay, the branch is pushed again, and when I'll do a refresh and when I create a pull request, okay, and here is new feed branch, create pull request, create PR. Okay, you won't be able to merge the changes. Now when I go to another account, okay, here new 5, you can see the merging is blocked because we locked this branch. Right here it is showing us the option to merge it by bypassing the rule. Why? Because we are the owner of this repo, but when it goes to some another user, it is saying that merging is blocked and you cannot merge the change in this lock branch. So this is called branch protection rules. Okay, so yeah, let us move forward. There is one more topic that I wanted to discuss with you, but before even that, let us go with the definition itself. Branch protection rules are settings for Git platforms like GitHub, GitLab, Bitbucket. They prevent direct changes to merge into the important branch, which is the main branch or the master branch, which we saw just right now. Now what it will do, it will prevent forced pushes. Second, it will require pull request review before merging. Third, it will require it will enforce status check. Fourth, good for signed commits, and it will restrict who can push the changes to which branch. Okay, now covering up the last topic, that is issue in GitHub. Now what is an issue in GitHub? Okay, issue in GitHub is a way to track bug, task, enhancement or feature request in a project. Okay, so what it is used for? It is used for tracking the bugs across your cycle, okay, across your sprints. Okay, the key features are you can add title or description to explain the problem. Okay, it can be assigned to a team member. It can include labels like bug or enhancement. It supports comment, attachment, and across references can be put over here. And then the final and the best part is it can be linked with a PR. So let us create one issue. Okay, let us go to this repo and I'll go to issue section, which you can find over here. We'll create a new issue. So we'll write need to remove blank files. Okay, and here you can write the description of the bug. Okay, so description of the issue flows here. Okay, need to remove the blank files.
If you want to add few hyperlinks, you can also add it here. So for now, let me just go over here and I'll just add a random hyperlink over here. Okay, when you go to preview, you can see something like this. Okay, all right. Now let me just create the issue. Now, as I mentioned earlier, you can also add labels in this issue. So I'll just mark it as a bug. Okay, and you can assign it to the people, you can assign it to yourself, and you can assign it to someone else. Okay, here I assigned it to Siddharth. All right. Now what we'll do is we'll go over here as a normal user. We'll go to issues, and here you can see the issue is created. Okay, and here you'll go and see the description. Okay, he is saying that we need to remove, okay, the blank files. Okay, all right, done. So I'll go to my terminal, I'll clear it. Let me just check how many branch do we have. We just have 2 branches, that is main branch and the new feature branch. All right, done. So let me just clear the screen. Let me just go to git pull. Let me just take a pull. Okay, clear. Git checkout main, git pull. All right, ls, these are the files that we have right now. Okay, now what I'll do, I'll just create a new PR from here. Git checkout -b new bug solve. Okay, and I'll remove the empty file. So ls, so we don't have text in 3 and 4 and 5 also. So rm-rf new, and we need to remove 3 till 5 and .txt. ls git status commit -m, and we are going to write a comment. So removing the blank files, git push origin new bug solve. Okay, the changes are now pushed to this specific branch new bug solve, and we are going to raise on PR. Okay, new PR, branch name, create pull request, and the PR is created. Okay, now the next thing is, before even creating the PR, you can just go and edit over here if you want to change the title. The one thing that I missed here is if you want to close a PR, how do you do it? So basically you just need to go scroll down and you can just close the pull request over here. Okay, the pull request is closed, meaning there are no changes which was required and we made it unnecessarily. But now let's say we need that changes. Okay, so how do we do it? Again, we need to go, we'll go to pull request, we'll create a new pull request, we'll select the branch again. Okay, and then here we are going to add few description. Just give me a moment. View pull request. All right, let me just add one more comment over here. New test, git add a new test, git commit -m, new file, git push origin, new bug solve. Okay, I'm creating a new PR over here. I'll go to the pull request, new pull request. Here I'll go to new bug solve. Okay, create pull request. Here, if you in the description, if you want to tell that okay, I am giving the resolution for this issue in this PR, you just go over here, copy the link, go over here and write solution to the issue. Here is the link. When you go to preview, here it will link the issue with your PR. Create pull request. Okay, all right, and yeah, here you can see the PR is now linked. When you go over here, okay, here under development you can search the pull request, and here we have new bug solve. Okay, and that is how you linked the PR with this one. Okay, here the pull request is 6. I think we linked a wrong PR, so I'll go to development again, I'll uncheck this one and I'll just go to the 6th one. Yeah, new bug solve, done. will link the PR with this issue, and here you can see Siddharth linked the PR with this issue. Okay, now what I'll do, I'll just bypass the rule and merge the changes. Okay, and I'll delete the branch. Now I'll go to the issues, I'll refresh it. Okay, and here you can write, okay, as we merge the PR, okay, it will close the issue automatically. So that is how you link a PR with an issue. Okay, now let me just summarize whatever we did so far. Okay, we created a branch from main. Okay, we added few changes and we raised a PR. Now there was a issue which was present. Okay, there was a issue which is closed now. Okay, and then what we did, we linked that PR with this issue, so that whenever we close that PR, we merge that PR, it will close the issue automatically, right? So in this section we learned about what is pull request, what is branch protection rule, and the third is what is issue and how do we link it with a GitHub PR. All right, so yeah, that was all for this video. In the next section we are going to learn about GitHub forking and tagging, right? So yeah, that was all, and see you in the next one. All right, let us start with section 9, where we are going to do a deep dive on forking and tagging, right? So starting with the first section, that is forking, and after that we are going to move forward with tagging. Okay, now Shubham, what do you mean by forking? Okay, let us go with the official definition, and then we are going to actually perform what actually forking is, what is the additional advantage of forking, and what does forking bring us into our plate, right? So a fork is a personal copy of someone else's repository on your own GitHub account. It allows you to freely experiment with the changes without affecting the original project. Okay, now what is forking? So basically, let's say Linus Torvalds, he invented Linux and he provided it open source. But the thing is, you can see there are multiple variations, multiple varieties of Linux distro present, right? But how does that thing work, right? Because the original source of the code was kept in some another repository where the owner was Linus Torvalds, and people did a replica at their own local. They tried to modify it and then they updated the actual repo. Okay, this is called forking, where we are not disturbing the original project structure. We are making a local copy at our end, and then we are working on the changes. When we are satisfied and we want people to experience it, then we raise a pull request, and then the changes are merged into the original repository. Okay, forking is just a method where we are just creating a replica of the original source, right? So yeah, how does it works? Basically, you just have to click on fork. It will create a copy of the actual repository in your GitHub account, and then you can make the changes. You can raise a pull request to the original source, and then whatever code changes you have made, it will be present in the original source, right? And why we should fork a repository? Because whenever we want to contribute in open source, we make use of fork. When we want to try out few changes safely, we make use of forking. Third, when we want to do customization in the projects, we make use of forking. And whenever we want to collaborate with teams, okay, with a larger audience set, we make use of forking. Now Shubham, how do we do it? So yeah, let's do the forking part. Here I have added few snapshots which will help you to understand how does forking work. So this is your GitHub account. Basically we will be needing 2 accounts for this specific demonstration. I'll tell you how to do it. So here we have something called this fork button, where we click, and when you click it, you will be prompted with this option where you will be creating the fork. You can additionally write the description if you want, and once the forking is done, you will be getting the repo here. Now Shubham, how do I identify whether the repository which I forked, which I copied, is from X source, right? Here the account is of Siddharth, okay, and the owner is Siddharth, but the copy is made by Shubham. But how do I know that the Siddharth is original owner of this repository? So basically below the repo name you will find forked from the username, right? So that is how you identify whether this is a forked repo or not. Okay, now as I mentioned earlier, for this specific demonstration we will need 2 accounts. Okay, so I'll be using Siddharth's account, this one, and I'll be using Shubham's account. Okay, so let me create a new repository over here, and here I'll just write it as forking demo. Okay, I'll make it as a public repo. I'll add a readme file, and then we are good. Okay, now this time we are not even giving access to the repo for this specific one. Okay, because earlier, if you remember, if you want
some another person to collaborate in your repository, you used to go to settings, and under collaboration you used to add the user. But this time we are not adding additional user. This time we are considering this as an open project where we want people to raise request, and once we are reviewing it, then we are going to merge it, right? So yeah, this is the repo which is now created, and right now Shubham doesn't even have the access of it. So the first thing that I'll going to do is I'll just copy the link and I'll go and paste it on my browser. Now here the account which I'm using is of Shubham, you can see. And now what I'm going to do is I'll go here and I'll just click on fork, and here I can fork the repository. Okay, if you want to give the description you can, but for now I don't want to do. And here we are copying the main branch. Okay, now let me click on create fork. Now at backend, what it will do, it will copy all the contents which are present in Siddharth's repository, the main repository, and it will create a clone at my end. Now how do I identify whether it is a forked repository or not? You can see it is showing that forked from Siddharth's. Okay, now when you click over here, it will redirect you to the original source, the parent one, right? Okay, the initial thing is done. Now the first thing is to notice is it is showing that the branch is up to date with Siddharth's forking demo with the main branch. Do you want to contribute or do you want to sync and fork? So sync and fork is, for example, now let's say Siddharth added few new files, but when you cloned it, you just got the readme.md file. Now how do I make sure the changes which are present on the parent are also present in the child? We can make use of sync fork. Now how to do it? Let's do the demonstration. I'll just copy the repo link from Shubham's account and I'll just do a git clone. Okay, so git clone. Okay, now when I go to working demo, I am on main branch, and as you can see there is only readme.md file which is present. Now I am going to Siddharth's account and here I am going to add a file. So here I'll write main branch.txt, and here I'll write this is the file from the main parent branch. Okay, now I'll commit the changes and it is going to commit to the main branch of Siddharth's account. Now we have two files, which is readme.md and main branch or text file. Now I am going to Shubham's account. I'll do a refresh. Now it will check whether how many changes are being proposed to the main parent. Now it is showing that this branch is one commit behind of the parent branch. So what I'm going to do is I'm going to click on sync fork and click on update branch. Whatever changes are present in the parent, it will bring to the copied branch, copied repo. So here you can see main branch.txt is now present. Now what I'll do as a regular user, I'll just make sure that I'll take git pull. Okay, so whatever changes were present, it is now present on my end. So this is main branch.txt, and now when I do cat file, you can see it is showing this file is from the main parent branch. All right, now let us start with the forking part. Now here we are going to learn how we can contribute using forking to the main parent branch. Right now, if you see, if I do git remote -b, you can see I am on Shubham's account, okay, which is a copied of the original Siddharth's repo. Okay, now what I'm going to do is I'll just create one branch, git checkout feature -1, git checkout -b, because we want to create and switch. Okay, now I am on feature branch. When I do ls, these are the two files which are present. Now what I'll do, I'll just add few files. Vim feature file child.txt. I'll write this is the file from Shubham's account. We are demonstrating forking and parent peer merge. Okay, I'll just add a random dummy text, and what I'll do, I'll just add the file git add feature file child.txt, git commit -m new feed file git push origin feature 1. Okay, now this will push the feature 1 branch on Shubham's account. So now I'll just refresh Siddharth's account and see whether the branch is present or not. Now by default there is only main branch because we haven't touched it. But when I go to Shubham's account, you can see feature 1 branch is present. And now when I switch to feature 1 branch, you can see there are 3 files which are present. Okay, Now the next thing is, now I am considering that whatever modification and customization I wanted to do over the base code, it is ready. I tested it, and now I want people to experience the change, the beta users. Now how do I do it? So I'll just click on compare and pull request. Okay, if you are not getting that option, what you need to do is you can just directly go to pull request, and here you can click on create new pull request. All right. Okay, so here there is one thing that you need to observe is, here it is selecting the base repository. Okay, so you are getting two options, whether you want to merge the changes in your parent account, okay, or you want to merge it to the source account from where you did a copy. So right now what I want to do is, I want to merge all the changes which I did on Shubham's feature 1 branch to be merged into Siddharth's main branch. That's why we are going to select the base repository at Siddharth and the base image as main. And here the head repository would be mine, and the compare branch is the feature 1 branch where we have done the changes. So here I'll write the title and the description as usual. This is from okay, I adding a random text. So I just added a normal description, and here are all the file changes, and I'll just create a pull request. Now we are going to wait. Okay, it is showing that there are no conflicts, and here I am not getting any option to merge the changes. Why? Because I am not the owner. The owner is Siddharth this time. Okay, now I'll go to Siddharth's account and I'll just do a refresh. Now here Siddharth will go to the pull request, as he is the parent of that, as he is the owner of that repository. He'll just open the PR and check. Okay, so these are the changes which are done by Shubham, and he added a new file by the name feature file text, and he added a text file here, and this is the commit which are done against it. Okay, what he'll do, he'll just check, he'll review the change, he'll approve it, and after the review is completed, obviously he is going to merge the changes. Now the pull request is merged and it is automatically closed. Okay, now the next thing that the people have to do is, now since the main branch is updated, like when you go to forking demo, okay, in the main branch you can see feature file child.txt is present. Now as a regular user, if you go to Shubham's main branch, okay, he still has the outdated branch. There are only two files which were present. Okay, one second. When I go to your repository, forking demo, all right, in the main branch you can see there is only two files present, but technically there should be three files which should be present. So what I need to do is, I'll just sync the repo and I'll update the branch. Okay, it will copy all the commits from the source parent and will be present over here. Now what I'll do, I'll just take a git pull. I need to just check out main, and then I'll just do git pull. So whatever changes were proposed, all the changes will be present over here. And now when I do get file, okay, one sec. Okay, get file, all the changes are now present over here. So this is called forking. This is how we raise a PR across a repository. Okay, and how you learned about forking. Now time to move on, and here this time we are going to learn about tagging. Okay, now Shubham, what is the general definition of tag? Okay, now imagine whenever you are going to any store, whenever you are going for shopping, by what thing you are identifying the changes, by what thing you are actually looking, and you are checking, okay, this is the price of this thing. It is the tag. Okay, because the tag details out this is the MRP, okay, and this is made up of this brand, and these are the material which are used. Okay, tag in Git does the same thing. Okay, let us go with the actual definition. Git tags are references used to mark specific points in the repository history. They are often used to label the release version. For example, 1.0, 2.1. This thing you have already seen in Play Store. Every time you go to the releases section, you will see the release version. Okay, there are two sort of tags in Git, that is lightweight tag and annotated tag. Lightweight tag is a simple pointer to a commit. It's like a bookmark. And annotated tag stores the metadata like the tagger name, date, and message. Okay, now Shubham, why we should use tag in the, okay, So it is used for marking release version. Second, it is used for tracking important commits, and third, it simplifies the deployments. Okay, this is the basic use of tags. Now enough definition is done, enough theory part is done. Now let us directly jump to the practical session. All right, let me just clear the screen. All right, so let us create the first tag. In Git, whenever you want to create a tag or whenever you want to mark a specific code line, you make use of git tag command. So that is git tag. And now since it would be the very first command, very first tag that we are going to create, we are going to mark it as version 1.0.0. Okay, now the tag is created. Now Shubham, how do I validate whether the command actually executed, or how do I validate whether the tag is actually created? So for that, I'll just run git tag, and here you can see the tag is created. Now if you remember, in the prior videos we learned about there are 4 sort of object types, right? And one of the object type was tag, right? So meaning there is one more entry which is being stored in the .git folder. Yes, definitely. So the initial thing is, if I go to my repo and I do a refresh, you cannot see a tag. Now Shubham, where do I see a tag? So basically under releases, this is the place where you can see a tag. Okay, so what I'll do, I'll just go back again here. So I created the tag version 100. Now how do I identify whether it is a lightweight tag or an annotated tag? See, the only difference between the lightweight tag and the annotated tag is, in annotated tag it will show the metadata. Now what do I mean by metadata? Metadata is the data of data, a crux. Basically, whenever you want to differentiate between lightweight tag and an annotated tag, basically the only difference is, in annotated tag you will get the data, that is the person who tagged the name, the date and the message. Okay, right now it is a lightweight tag. All right, because we didn't pass any sort of parameters. Now the next thing is we want to push it to the git. So for that we'll make use of git push origin, and the origin would be main, and here we want to push the tag 100. That's it. Now what it is showing, that we have pushed the changes. Now I'll go over here. Okay, I'll refresh, and here this is the place where you can see the tag is created, and this is the place where you can see that tag was actually created, and it is showing the merge pull request was created. Done. This was the initial thing which we learned. Now how do I create an annotated tag, right? So for that I just have to write git tag -a, and then here I will write the version. So this time I will mark it as version 1.0.1, and here I'll pass a message. So basically in annotated tag I mentioned that we will get the metadata. Okay, in one of the metadata, apart from the person who is tagging, apart from the date, we are going to get one message. So -f we are passing for the message itself. So this would be release version 1.0.1. okay, and now the next thing is I will again push it. So git push origin 101. Okay, now this tag is also pushed. Now when I go back and when I do the refresh over the tags, 101 is created. Okay, now the next thing is, how do I verify? Okay, now let us go inside the .git folder. Okay, and where do you find the tags? You'll find it under refs. So cd refs under tags. When you do ls, you will find these are the 2 files which are currently present. Okay, now when you do a cat for version 1.0.1, you'll find an ab hash. Now if I do git cat file, okay, and I want to know the type, and when I share the ab hash, sorry, when I share the hash, you will see the object type is tag. Okay, so yeah, that was the demonstration. How do we create a tag in Git? Okay, what are the 2 sort of tags that we have? One is lightweight tag, and second is metadata tag, annotated tag. In annotated tag, you'll get the details such as the person who created the tag, the message. Now if I do git cat file -fee, it will show me the details. Now Shubham, if I perform the same with lightweight tag, what would be the data will I get? So for that, what I'll do, I'll again do a cat version 1.0.0. I'll get this hash, so I'll run the command again. We are going to check the object type as well. So git cat file, okay, -t for type, and here I'm saying it is a commit object type. Okay, now when I read the content inside a lightweight tag, what sort of data do I get? Okay, you can see this is the data that we are getting. But when it comes to annotated tag, this is the data that we are getting, right? So that's the difference between lightweight tag and annotated tag. So this is the list of command that we have executed so far. So git tag followed by the version will give you the tag name. It will create a lightweight tag, but if you want to create an annotated tag, you will make use of -a followed by -m. -m defines the message that we want to pass, and the last is we are going to push it to the central, that is git push origin followed by the tag name. Okay, now the next thing, if you want to read the tag, how do you read it? So git tag -v. So let me just clear the screen. Git tag -v to know what went inside that tag. Okay, so here it will read the data and will show you on the screen. Right, so yeah, that was all in this specific section where we learned about git forking. Now what is git fork? Basically git fork is creating a replica in your own instance and then you are starting working on it. Okay, and then we learned about how we can raise a pull request, a PR, from your repository to the main parent repository from which you copied the code. Now the next thing is we learned about tagging. Now in tagging, it's just used for identification and marking the code stamp. Okay, now the second thing that we learned is we learned two types of tag, that is first lightweight tag and second is annotated tag. The difference between them is the ones which have the metadata is the annotated tag, right, where the object type is tag and the lightweight object type is a commit object type. Yeah, so yeah, that was all in this section. In the next section we are going to learn about git rebasing. Right, so yeah, that was all, and see you in the next one. All right, let us start learning about rebasing. Okay, so rebasing is a concept where we actually maintain a linear commit history. Okay, so the companies where we don't want distorted commits and we want just a specific single line commit history, that is the place where we make use of rebasing. Let us go with the definition. Rebasing is the process of moving or combining a sequence of commit to a new base commit. Okay, the primary reason for rebasing is to maintain a linear project history. Okay, now before even we move forward, to check it with the visuals. Okay, but the note is rebasing is something which we not perform on production or the master branch. Rebasing we usually do on a bug fix branch or a feature branch. Okay, so yeah, let's consider this scenario. Here is the visual for understanding the rebase. Okay, so there is a master branch, okay, a main branch from which we were doing incremental commits. Okay, now from C2 we considered it as a baseline and then we checked out a feature one branch. Now in that feature one branch we did some initial commits. Now after those three commits we said that yeah, we are good to go with this feature, but at the same time the other developer were working and they pushed few changes to the master branch. So in addition to C2 we have two more commits, that is C3 and C4. Now what will happen, these two changes are not present in the feature one branch. Okay, but they do want the commits, right? So what we will do, we are going to make use of git rebase. So what it will do, it will maintain a linear structure history for feature one branch and the final result will look like this. Okay, so this was before rebasing, and after performing the rebase, our commit history will look like this. So here the header was pointing to C2 because it was the base for it. Now the header will point to C4 because the base changed to C4, and that is how rebase works. Okay, now let me go back over here and we are going to make use of an extension in Visual Studio Code that is called git length. So you need to go to extension and just search for git length. Okay, and this is the one that we are looking for. One second. Yeah, so this is the extension that we are looking for, and this will help us to visualize the changes whatever we are making on the repository. So here you can see this is our project structure usually look like. It is a very messy one. Okay, we are going to create a simpler one so that you are able to understand the changes. Okay, all right, so let us first create a git repository. So what I'll do, I'll just create it on my local. So mkdir, let me write it as rebase, cd rebase. Okay, git init, and we have initialized it as a git repository. So what I'll do, I'll just open that file in a new window. Open desktop, and here we have rebase. Okay, all right, now what I'm going to do is I'm going to create few files. So I'll just write
new file .html. Okay, doc adding initial comments. I'll open terminal and I'll just write over here git add new file, git commit -m initial file from master. Okay, and at the same time you can see git lens, which will tell us the graph, okay, whatever we are doing. So right now we are on master, that's why it is showing the initial file from master, the commit message. Okay, let me just remove this one. Okay, now it would be easier for us to understand. Okay, so we are going to make use of this visual for understanding whatever changes are happening. Now what I'll do, I'll just create one more file, main.html doc. Okay, and here what I'll do, cd rebase git add dot git commit -m added main for master. Okay, and now here you can see the second commit is also present. Okay, now I'll create one more file. Okay, readme.md and vim readme.md. I'll just write this is for test rebase, escape -wq git and readme git commit -m added readme. Okay, and now when I go over here, you can see the commit message is also present. Now the next thing is, what we are going to do is we are going to create one feature branch. So git checkout -b feature -1. Okay, now we checked out to a new branch, that is feature 1. Now the head is pointing to this branch. I am going to add few more files. So touch new file, or let me write as first feed1.txt. New file is added. Okay, and what I'm going to do is I'm going to add let me add a comment, git add first feed1 git commit -m first feature1. Okay, and here you can see a new commit is added. Now the header for master is left behind, and now we are moving forward with the changes. Okay, now let me add few more files. So touch new feed2.txt vim new feed.txt. This is from feature 2, escape :wq git add new feed.2 git commit -m from feature branch. Okay, now if I go here, you can see one more commit is present. Now what I'm going to do is I'm going to check out to master. Okay, clear. Now if you go to git lens, you can see the header is changed to master branch. Now I am going to add few more commits over here. So here I am going to create two files, one blank file named blank master.txt. Okay, and git add blank master git commit -m added blank for master branch. Okay, now we are going to create one more file, or we are going to edit existing file. So vim main.html, and here we are going to add a body tag. So here I'll just write okay h1. This is the heading from master branch. Okay, heading 1 tag close, escape :wq git add me git commit -m added text for master branch. Okay, the initial thing is done, and now you can see there are two additional commits in master which are not present in feature. Okay, now I am going to add few more commits, so just give me a moment. Okay, so I'll just write touch new master file .text git add new master file .text git commit -m master file added. Okay, now here you can see there are 3 commits which are present in master but not present in feature. Now you can see the line. Okay, so here if you can see, if you can relate it with this diagram, we have created a few commits, and from that branch we checked out the feature branch. So here we did the same. We did an initial 3 commit, and from that place we checked out a feature branch, and then we did the initial commit in feature. Now we were good that the feature branch changes are done, and then at the same time someone did changes on the master branch, that is C3 and C4. In our case, these are the 3 commits which takes place of C3 and C4. Now the expected thing is, after rebase, I want a linear history for the feature branch. How do I do it? Okay, so for that what I need to do is I'll check out to feature branch, git check out feature 1 branch, clear, and here you can see the header is changed to feature branch. Now what I need to do is git rebase master. When I run a git rebase master, it has updated, it has rebased the entire file history into a single linear one for the feature branch. It is scary, but it is useful when you want to maintain a cleaner history for the feature branch. But will it impact the master branch? So git switch master. When I go to master, things remain the same for master. There is no change. Okay, yeah, but things change for feature 1 branch. So that is how we learn about rebasing. Rebasing is used for maintaining a clear history in a git. Okay, so yeah, that was all about git rebase. Hope you understood the concept. In the next section we are going to learn about git ignore. All right, yeah, so that was all, and see you in the next one. So let us start with git ignore. Okay, so git ignore is a file in git, okay, which tells which file not to be pushed. So let's take an example. Let's say you are working with node.js, and when you run npm install, at that time it installs node underscore module. There is a node underscore module directory in which all the dependencies has been installed, right? Those can be eliminated because those are something which are not required while pushing the code, because you just need to run npm install and you will be good to go, right? So in order to tell git that you need to ignore that directory, that specific folder, we make use of .git ignore. But the question is, how does git knows which file to ignore? So for that we have something called .git ignore file, a file where we define that these are the files which we need to ignore while committing, and git won't be counting that specific file. All right, so yeah, there are common patterns, that for example star.log, which will ignore all the log files, /build, which will ignore all the build directory at the root, secret file, which will ignore a specific file, temporary files, and we have important log file which do not ignore this file. So these are the files which we are supposed to not push to git while committing the changes. Okay, there are a few common git ignore type. For example, for Python we have few cache files. For Node.js we have node underscore module directory. For Java we have classes. For C++ we have exes, which we are not supposed to push into the GitHub. Okay, now we are going to do a demonstration with this specific repo. Let me just clone it. So git clone. All right, so let me just remove the existing one. Okay, let me rerun the git clone command. Okay, so it is cloned. So let me just go inside the repository, and here when I do the list, you can see these are the files which are currently already present over here. Okay, now the next thing is, you can see here there we have docker compose, docker file, we have init.sql, docker file, package.json, okay, ls-la, and here you'll see a .git ignore file already present. Okay, now the next thing is, I'll be creating few temporary files which I don't want to push to the git. So what I'll be doing is, so firstly I need to get rid of this node underscore module. So what I'll do, I'll just do rm-rf node underscore modules. Okay, git add dot git commit -m removing node underscore module. Okay, and then I'll just do a git push. Now when I go to my repo and when I do the refresh on my main branch, node underscore module is not present. Now what I'm going to do is, I'm going to create node underscore module folder again. So mkdir node underscore modules, and inside that I want to insert a temp.txt file. Okay, mkdir-v. Okay, now it will create the node underscore module folder. Okay, and in the git ignore, I'll just edit it.
dot gitignore. Okay, so let's say I want to ignore node underscore module directory. So what I'll do, I'll just write node underscore module followed by a forward slash. This will give an indication to Git to push all the changes except this folder and whatever is present inside it. So when I just save it, okay, when I do git status, it will not track node underscore module. Okay, it will say that git ignore file has been modified. When I do git add dot git commit -m node underscore module in dot git push, technically it should not push my node underscore module folder. And when I go over here and when I do the refresh, the only thing which it did was it just updated the dot git ignore file. Okay, if you go over here, you would see node underscore module directory present over there. Now the next thing is, this was just for folder. Now let's say if you want to ignore one of the file, how would you do it? So let me just create new file, clear. So I'll just create a new temp file. So touch temp.txt. Now this is the file. When I do git status, it is under untrack. Now I don't want this file to be present in git. Okay, so what I'll do, I'll just add it into the .git ignore file. So vim.git ignore, and here what I'll do, I'll just write the file name. So temp.txt escape:/wq. Okay, and now when I do git status again, you'll see it is just showing that .git ignore file is modified, and here this untracked file is now eliminated. Now when I do git add dot git commit -m ignore temp file git push, okay, it will only push the changes in .git ignore, okay, but it won't push the temp file. Okay, now when I go over here, you can see that new temp file is not present over here. The only change which was pushed was this thing, that is temp.txt. Now let's say there are few log files which are present in your repo. How do you eliminate it while pushing it? So let's create few log files. So I'll just create some log files, for example one. So let's say it would be temp 1 till 10, and we'll just give it a extension as .log. When I do ls, you can see there are 10 files which are present. When I do git status, these are under untracked. But what I want, I don't want this log files to be pushed while in the GitHub. So what I'll do, I'll just open gitignore. Okay, and here I am going to add one more entry for all the files that ends with .log extension escape:/wq. When I run git status again, you can see only the modified changes in gitignore will be ready to be pushed. So git add dot git commit -m added log entry in ignore, and then git push. Okay, now the changes are pushed, and now you can see when I refresh the screen, only the .git ignore file is edited and the log files are not pushed. So to summarize everything, .git ignore file is just an entry that we mark on Git which tells Git to not to push specific files, specific log files and specific temp files and specific folder not to be pushed into the central. All right, now there is one more website that I want to tell you, that is gitignore.io. okay, so this website is very useful for writing the .ignore file. For example, when you are working with Python, when you are working with Angular, okay, or when you are working with Java, you just have to select the language that you're working in, and you just need to click on create. It will give you all the ignore files that you have to create, right? So you just have to copy and paste it into your repo. This will save your time and will help you for creating the .ignore file, right? So yeah, that was all in this section. In the next section, it is a very informative section on Git log, because we have been dealing with Git, and Git entirely is dependent on commit. So there is something we need to focus on. Basically, it's the log. Git log, basically we are going to learn about how we are going to filter out the changes by author, by commit. So how that can be done, that we are going to to learn in Git Log. Alright, so yeah, that was all, and see you in the next section. Alright, so let us start with section 12, where we are going to learn about Git Log. Okay, so as we are already aware, whatever we do in Git, it has been logged through an entry, and that is called a commit ID. Okay, Git Log is a utility, a command in Git which helps us to see all the commits that we have done so far. Okay, so before even diving into Git Log, let me show you what actually a Git Log command output looks like. Okay, so this is how you can see a Git Log command, where the top entry is the recent activity that you have done so far. Okay, here you will get the commit ID, the SHA-1 hash, followed by the author name, the email address, the date, time, and the commit message, whatever was written. Now, if you remember, in the previous video, we deleted the node underscore modules, and we wrote the commit message as deleting node underscore modules. That's why it is every time said that whenever you're writing a commit message, it should give a specific meaning to your commit. Okay, here you can see we have added an entry in the ignore file. Now what do I understand? That I might have added one or more entry in the .gitignore file, right? So yeah, that was all about commit and git log. So let us first understand what actually git log is. So git log shows the detailed commit history, including the ID, author name, date, and message, which we already saw. So when I am saying ID, we are talking about commit ID, the SHA-1 hash, followed by the author name, the date, and the commit message. So these are all the information that you get on Git Log. But let's say if you want to get an output without the author name, date, and message, how do you do it? You are just concerned with a single line output. How do you do it? You just have to write git log -1 line. So when you do git log -1 line, it will give you the commit ID, the SHA-1 hash, followed by the commit message, whatever you written. Okay, so this is easier to read, easier to understand. Okay, against which commit what was done, and since it is consuming very less space, it is easier for us to identify what was done on which commit. All right, okay, moving forward. Now what was git log -1 line says? It says that it displays a compact version of the commit history with one commit per line. Okay, earlier we were getting a huge descriptive message that was ID, author name, author email address, date, and messages. But when you switch to one line, it will just give you one commit per line, that is commit ID followed by the commit message. Okay, now let's say you have been working in a project and there are multiple things that you have done. For example, you created a feature one branch, checked out from main, and then you did some development. After that you merged it, but how do you identify at what time it was merged? Here comes git log -graph, which shows a visual ASCII graph. Okay, it will show you where the merging was done alongside the commits. Okay, so let's go with that one as well. Git log -graph. Now you can see there is a linear history which is showing, because earlier we performed rebasing, if you remember. But if I go even down, you can see here a merging was done, and this is the merging ID. Merging was done by a cipher, and it was done against a pull request. Alright, so yeah, here you can see a graphical interface where we can see actually at what time the branch was checked out and the changes were merged. Okay, alright, moving forward. Next thing is git log -start, which displays the commit logs along with the number of insertion and deletions per line. Now, when do we use it? Basically, whenever you want to know what files were changed and what things were changed in that specific point, you make use of git log -start. So the output looks like git log -start. So here it will show you all the things which are present in git log, but in addition to that, it will tell you what files were changed, how many insertions were done, and how many deletions were done. For example, let us take the example of this example, and here what we did, we added an entry in the .ignore file. Here it is saying that only one file is changed, and that file is what? That file is .ignore file, and we added one more line, that's why it is showing as one insertion. Same goes for deletion as well. If I scroll down here, you can see earlier it was node underscore modules. Then if you remember, we changed it from node underscore modules to node underscore module directory. That's why it is showing as one deletion, and there were two insertion which was done from our end. Okay, and same goes for this specific commit where we deleted the entire directory. Okay, all right, let us go back, and here we have something called git log -p, which shows full commit full commit log along with the diffs which are introduced in each commit. This is used when we want to know at what commit what changes were made. So if I do git log -p, this is what you get and this is what you can expect. So here you can see, here you added a entry in git.ignore file. Here it will run a diff, okay, in the git ignore file. Here it defines that -a as the previous state and the earlier state, after state, post state, okay. And this is the entry that you added in the .ignore file. You added star.log. Remember in the previous video we added entry in .ignore file to ignore all the files which contains the extension .log. So this is saying the same. All right, okay, moving forward with git log, and here we have something called git log -n4. Now let's say there is a requirement where someone is asking you to find me out the last 10 commit. How you do it? So git log -n10. It will show the last 10 commit which were done on this project. If I want to see the last 4 commit, -n4, these are the last 4 commit. But again, if you want to combine it with some another command, that is -fn one line, you can do the same. -1 line. It will show you the commit followed by the commit message for the last 4 commits which are done in this branch. Okay. Next is short log. Now, Shubham, what is short log? Short log summarizes the commit history grouped by author with their commit message. Now, short log specific command is used when you want to know how many contributors are actually working in the specific branch, how many commits are been done by them, and who are the authors who did the commit. So let's make use of short log. Git short log. Okay, so here it is showing us 2 users. One is Shubham and second is Cypher. Here if you can see, apart from Cypher, there is a number 3 which has been shown, meaning there are 3 commits which is done by Cypher. But when it comes to Shubham, he made 26 commits in this specific branch. So that's the reason you make use of short log. But next, moving forward with the short log, now let's say if you want to see commit per author, like how many commits are done by this author and what is the count. So for that you make use of -n and -s. It will show that there are 26 commits which has been done by Shubham on main branch, and there are 3 commits which are been done by Cypher. Okay, moving forward with author type. Now let's say if you want to know how many commits are been done by a specific author, how do you do it? You make use of git log -author equals to, now here there are 2 things which you can pass. First is the username or second is the email address. I'll pass the email address for this time, gmail.com, and all the entries which has been done by this ID will be displayed over here. If I want to add it with 1 line, you can see a curated list is present over here. By Shubham, whatever commit has been done, it will be present over here. And if you count all this line, it will be 26 in total, which we have seen in the short log annex command. All right, moving forward. Now let's say, let me just run git log. Now let's take an example where you want to find all the commits which are done against a specific keyword. Now here in our kit is this node_module. So what I want to know, I want to find out all the commits in which the commit message consists of node_module. How do I make use of it? I'll make use of grep. Grep is a command in Linux, if you remember, which is used for sorting down the list, which is used for finding a specific keyword. The same thing we are going to use over here. So what I'll do, git log for running the entire, for getting the entire list, then -grep to searching the data, and here or data or keyword is node_module. So wherever node_module is present, it will list out everything over there. Now when I make use of -1 line, it will show only the commit ID followed by the commit message where node_module has been involved, right? Okay, now same can be done with username as well, but we have done with the commit message. Now let us move forward with git log with pretty part. Okay, now here I have something, a documentation to show. So here we have a documentation for devhints.io from which I have taken the reference, which you can use for finding out the data from git log in a prettier format. The format here would be git log -pretty and format equals to like this. So when you run this command, what it will do? It will give you all the hashes that has been done over this main branch. Now let's say, okay, if you want to display all the commit hashes from the log, you make use of format %h. Now where do you get the information? You get the information from this documentation. Here if you see, it will show you the commit hash. Okay, now if you want to see, let's say if you want to see the reference name, just replace this h with d, it will show you the reference name. Okay, now let us move forward, and let's say if you want to show the committer's name along with the commit hash for each commit, you make use of %committer name, and I want to display the hash in front of it. This is how you will get the info. So Cypher did a commit for this one, Shubham made a commit for this one. That is how you get the output. So that's the pretty of git log -- pretty command. Okay, that's the beauty of it. Now let's say if you want to know, there is a requirement where you need to find in this branch how many merge commits are present. So what you will do, you will run this command git log --merge. It will show you all the merge commit. If you want to say it on one line, you'll just run git log --one line. So we are just doing a permutation and combination. But let's say if you want to see only the commits which excluding the no merges, okay, so you need to find out the commit where no merge commit is present. So you'll just run this command and all the commit will be present where merging will be excluded. So these are all the commits without the merge commits. All right. Okay. Moving forward with the next topic, the important topic, that is Git Reflog. Now, Shubham, what is reflog? So let us go with the definition. These are the logs that Git keeps as a record. Git keeps a record of when the tip of the branch and the other references were updated in the repo. Git Reflog shows the history of change in the Git. It tracks where your head and branches are moved. Even if a commit is lost, Git Reflog can help find it. Git only keeps the reflog on your local machine, not pushed into the hosted repo, that is the central. And the main important point is Git reflog expires in 90 days. Okay. Now why it is useful? You can undo the mistakes which are done by using reset or rebase, or second, it can help you to find the old commit that are not present in the Git log. Now one thing to notice, whatever changes are present in Git Reflog, these are not pushed into the central in the GitHub account. Okay, so it is present in your local machine. Okay, all right. So in order to perform the operation of Git Reflog, okay, there is something that you have to do. Okay, in order to visualize all the changes that has been done in Git Reflog, I want to show you how does Git Reflog works. Then we will proceed with this command which you can see over the screen. So for that, what I'll do, I will ask you to go to Visual Studio Code, and if you remember, we have cloned this repo, that is approval -admin. You can find this repo over here. This is the repo that I am taking reference of. You just need to go to code and do a clone. After cloning, you need to open it on Visual Studio Code. Now, the important part, there is one setting that you have to do. You need to go to settings. Let me move it over here. 1 second. All right. Now here you need to go to settings. Under settings, you need to search for exclude. And now the reason is why we are doing this setting, because we want to see the .git folder. By default setting of Visual Studio Code is it will hide the .git folder. But for now, since we are doing this experiment, since we are exploring Git Reflog, we need to see what is happening under the hood. So for that, what I'll do, I'll just remove this entry and you can see the .git folder is visible over here. Let me close the settings, and here we need to go to logs because everything here is been maintained over logs. And here under logs, okay, here we have to search for a head file. 1 second. All right, so this is the head file which we were looking for. So it is present under log, and here you will find the header file. Now, what is this header file? In order to understand it, let me open the integrated terminal, which will make our life easier. Okay. Now, let me run git branch. Here we have 3 branches, new feature and feature 1. Now, just notice on line number 28, git checkout feature 1 there will be an entry which will be done over here, and it will show that Shubham Gaur checked out the file into feature 1 from main. Now when you do a checkout from feature 1 to new feature, that entry will also get logged over here. That's the beauty of reflog. It will track all the things that you do with your header. Okay, even if you move it from new feature to main, that thing will also be get logged over here. But the best part is these changes won't be get published into the GitHub whenever you do. So even if I run git status, you can see the working tree is clean, and whatever entry is been maintained over here doesn't affect your current project. All right, so that was to explain how does git reflog works. It just targets your head, and head file is stored under logs. Okay, all right, moving forward with the commands. So if you want to display the reference log of the recent update, you just need to run git reflog show. So whatever operations which we did, okay, see, we checked out from feature 1 to new branch, we checked out from main to feature 1, all those things are present over here, and the latest head is present over here, and the last head is present over here. That is how git reflog works. Now let's say you want to switch to a specific commit. How do you do that? You make use of checkout command. Checkout command is also used for switching the command and also switching plus creating a new branch. But here if you want to go to a specific commit, you can make use of checkout command. It switches your working directory to a commit with a specific SHA-1 hash. How do you do it? So for that, let me just run git log. Now let me go to the very initial commit, and let's say I'll just take this commit, Control C. Let me clear the screen. In my main branch, you can see these many files are present. But when this project was created, I was also sure that these many files were not created, but I want to see what were the initial files which were created during the initial baseline. For that, I'll just run git checkout followed by the SHA-1 hash. Oops. 1 second. Clear. Let me just copy the SHA-1 hash again. I'll go to the very bottom. I'll just copy the SHA-1 hash. Q. These are the files which are present in current main. And when I do git checkout followed by the SHA-1 hash which I copied, I am switched to the initial commit. And when I do the ls, you can see only these files which are currently present. Because at the main time, those files were not present. But now you can see these many files are present, meaning the context of this thing is you can just go to a specific point. All you need is a commit ID, and then you can just directly check out. Let me just go back to the main branch, git checkout main. Clear. Okay. All right. Now let's say if you want to go to a specific state of the repository in the nth entry of the reflog history, how do you do it? So let's say, let me just go to a specific history, git reflog log show. Okay, so here we are talking about this header. Okay, now if you want to go to a specific head point, how do you do it? You just need to identify your header point, and then you will be able to switch. So what we are going to do is, let us go to this head point, head 30. All right, so what we need to do is the syntax remains the same, but instead of SHA-1 hash, we will be replacing it with the header point. So git checkout head 30. All right, what it is saying, you are now in detached state. You can look around, make experimental changes and commit them. You can discard the commit and make this state without impacting the branches by switching back to a branch, which we already did. And if you want to create a new branch to retain the commits you created, you may do git switch -c followed by the new branch. But let us explore what it is trying to say. Here the head is at the commit where the commit message was removing node_module. So if you remember, in the previous video, we just removed the directory node_module, and then we added an entry in .ignore file. So this is saying the same thing, and here we just removed the node_module. This is at that specific point. Let me just switch back to main, and we are again back to main branch. Okay, now coming up to the last thing. Now Shubham, how do I create a branch from a specific commit? Because I identified the change which I was looking for. Okay, and now I want to create a branch out of it. How do I do it? So let me just run git log again, git log -1 line. Let us identify one of the commit. Okay, Okay, now let's say we want to go to this specific point. This is the place where pull request was merged, and after that I don't require whatever changes were done. Okay, so what I did, all I need is a commit SHA hash. Now how do I create a branch? You just need to write git branch followed by the branch name. So here merge revert, I'm just giving a random name followed by the SHA1 hash. When I do the same and when I do git checkout merge -revert, you'll see whatever changes were present will be present over here. Now the point to check over here is, if you remember, we did deleted node_module earlier, and here you can see node_module is also present over here. Now when I do a tree on node_module, all the files which were deleted are now present over here. So that's the beauty of git log, and that is how you play with git log command. Git log stores all the entry in the header file. If you remember, reflog is a tracker which tracks the head position. All right, so yeah, that was all in git log command, git log section. In the next section, which is a very important section, we are going to do a deep dive on git development operations. All right, so yeah, that was all, and see you in the next one. All right, let us start with git development operation. Till now we were just creating, developing, or understanding for git development operation. Okay, and right now we are actually starting with this specific section. Okay, this section is further subdivided into multiple topics where we are going to learn about git reset, git revert, git commit amend. We are going to learn what is git cherry picking, what is stashing, what is squashing, and how we can perform git squash over GitHub. All right, so yeah, to begin with, let's start with git reset. Now, what do you understand by the term reset? Reset meaning to undo a change, right? So likewise, the same way we have git reset. Git reset is a git command which is used to undo the commit or changes by moving the head to the current branch pointer or to a specific commit. It can also modify the staging area and working area depending upon the option used. Now here there are two things that we have to make sure. The first thing, here we can define the header or we can define the commit. Based on that, it will do the reset. And second thing is the option, due to which we can just mark the changes into staging area or the working area. Now by default, there are three sort of options that we have in git reset: git reset soft reset, hard reset, and normal git reset. Okay, which is also known as git reset mixed. So let us first understand what does git soft reset means. So in git soft reset, it will move the header, but it will keep the changes stage. Okay, it will be used when you want to undo a commit, but you want to keep the changes for a recommit. Okay, second is git reset or git reset -- mixed, which is the default one. So you can use this, and what it will do, it will move the header and will unstage the changes. And when you will use it, when you want to undo a commit and you work on the changes. All right, now the third one, the important one, which we have to use with caution, that is git reset, or it is also known as hard reset. What it will do, it will move the header and will discard all the changes in the staging area and the working directory. So we have to use this thing with caution, so because it will permanently delete the uncommitted changes. So the theory for git reset is done. Now let us actually perform the practical. All right, to begin with, I am going to make use of the same repository which you can see over here. All you need to do is just clone the repository and then you will be good to go. All right, now the first thing that we are gonna do is, let me just discard all the changes which were present over here, or let me just begin a start. And let me just do a start refresh. So I'll just remove this repository, rmfnrf, approval admin, and let me just do a git clone. All right, so here we are. Okay, now let me just run git log -1 line. Okay, here you can see there are multiple commits which are present. Now let's begin with git reset soft or soft reset. So what we need to do is, now let's say if you want to go till update init. Now as per the definition, what it will do, it will undo the commit, okay, and will keep all the changes into the staging area. So what I'm going to do is, I'll just write git reset -soft followed by the SHA1 hash. Now when I run git status, you can see all the changes are moved into the staging area.
right? So that is how we do soft reset in Git. Let me just do a git pull. So it will pull all the changes from the central, and I am back to square one. All right. Okay, there was one more thing that we have to notice over here. So when I was running, let me just do it again. Let me just soft reset again. Git reset hyphen soft followed by the SHA1 hash. So apart from moving the changes into the staging area, if I run the one line command again, it actually moved the pointer to that specific commit through which the commit was provided. If you see, this is the commit which we provided, and after that whatever changes were present, it is discarded. Okay, and all those changes are present in the staging area. So that is how we perform git soft reset. Now let me clear the screen and let me pull the changes again. All right. Now the next thing is, how do we do mixed reset or git reset? So for that, let me just again run git log hyphen one line, and I want to see the last 4 commits. So let me just go till here, and I just type git reset followed by the SHA1 hash. Now when I do git status, okay, it has moved all the changes to the working directory, meaning it has undo the changes, and secondly what it has done, it has moved the changes to the working area. Now if I want to proceed with working with it, I just have to add those changes to staging area, and then I'll work on it, and then I can push it. Now again, if I check my logs again, you can see it has moved the pointer to the node underscore module, that is the SHA1 hash that was provided during the reset. Now what I'm going to do is, I'm going to reset it again. I'll just do git add dot and I'll do a git pull. Okay, and now again I am into back to square one. I'll just check my logs again, git log hyphen one line, and yeah, all the changes are back again. Since my changes are stored in the central, I don't have to worry about anything. Okay, now the last one and the important one is hard reset. How do we do it? So see, let me go till this point where we are removing the node underscore module directory. So what I'm going to do is git reset hyphen hard followed by the SHA1 hash. Now remember, earlier when we were running git status, we were getting something, but here it has deleted all the changes which were present, right? Now when I do git log hyphen one line, just notice this SHA1 hash D6068A, and you can see it has moved the pointer to that specific one and deleted all the things which were present. So that's why it is said git hard reset is a destructive command, so we have to use it with caution. All right, let me just take a pull, and again I will be back to square one. All right, so yeah, that was all about git reset, where we learned about 3 things: git reset soft reset, hard reset, and normal git reset. In soft reset, it will bring the changes to the staging area. In git reset, it will move the changes to the working area. But when you use hard reset or git reset hard, what it will do, it will delete the changes which were present in your working and staging area. All right, so yeah, that was all about git reset. Now moving forward with the next one, that is git revert. Okay, now what is revert in the first sense? Reverting means something. Now let's say you added a new file, okay, you worked on it, and accidentally on the next commit you deleted the file. Now you want that file to be back, but you don't want to use reset, okay, but at the same time when you were recovering the file, you want a commit, okay, which says that this file was reverted back. So that thing is actually done by git revert. Okay, so let us go with the definition. Git revert is a command which is used to create a new commit that undoes the changes made by the previous commit without altering the project history. So whatever we do, we have an intact history of it. So why we should consider git revert in the first place? Because it will keep the commit history intact. Second, it is ideal for shared repository. Third, a very safe alternative to git reset for undoing commit. Now, how does it work? Okay, so instead of removing a commit, git revert create a new commit that reverses the changes of the specific commit. So how do we do it? So yeah, we are going to see the example again. Now again, as I mentioned earlier, in git reset and git revert, we can do it with header, and also at the same time you can perform the action using the commit ID. Now I am showing it with a SHA1 hash in the following videos. In the following section where we are going to learn about amend, we are making use of head. So yeah, both things will be covered in the same section. So yeah, let us do git revert. Let me just check out to a new branch, git checkout revert branch. Okay, and I need to provide one parameter over here, -b, so it will create a new branch and I will be switched into it. Now the next thing is I'll create a new file over here, so touch new file revert, git add a new file revert, git commit -m, added new revert file, and I'll push this branch, git push origin revert branch. Now what it will do, it will push my branch along with the changes to the central. Now if you go over here, okay, new revert file is present over here and the commit is done right now. Now the next thing is, what I'm going to do is, now accidentally I was working, okay, and let us assume that I deleted this file by mistake. So I'll just delete the revert file again, new file revert, git add new file revert, git commit -m, deleted new revert file, okay, and then what I did a git push origin to revert branch. If I go over here, you can see this file will get deleted. I'll just have to refresh it, and yeah, new revert file is deleted. Now after some time someone says that, hey, the file which you deleted was an important file and you might have accidentally deleted it. So how do you recover it? You will recover it by using git revert, okay, but at the same time what it will do, it will create a revert commit. So how do we do it? So for that you will need a commit ID, so git log -1 line to see the log, okay. Yeah, so these are all the logs that we have. Now you'll come to know by reading the commit message that yeah, here we added the file and accidentally this was the place where the head is pointing, and this is the SHA-1 hash against which that file was deleted. Now if I want to revert back the changes, how would I do it? I'll just write git revert followed by the SHA-1 hash. Now here it will give you a pop-up. It will this pop-up is basically for the revert commit message. What do you want to say? So here I'll just press I and I'll just write deleted new revert file, and here I'll just write revert success. Restoration. Okay, escape :wq, and yeah, file reversion is completed. How do you check it? Just do ls new revert file and you can see the file is present over here. When I do git status, nothing is present, and when I do git push origin revert branch, okay, the changes will get pushed over here, and now when I do a refresh, my new revert file will be present over this branch, that is git revert, and yeah, this is the file, and here you can see the revert commit message is also present, which says that the deleted file is now recovered. Now when I go to git log -1 line, you can see the file was created initially, then it was deleted, now again it was restored using this specific commit against this commit ID, right? So yeah, now let me just check out to my main branch. Okay, that was all about git revert, which is used against reset because it is considered as a safe option where we want to preserve commit history. So whatever we do is been logged in the commit message in the logs, right? So let us move with the next section, that is git commit amend. Now what do you understand by amend? So basically, let's say you were doing some changes and accidentally you did a wrong commit message. Now you want to edit it. How do you do it? Basically, you will make use of git commit amend command. So git commit -amend is used to modify the most recent commit either by changing the commit message or by including the new changes in it. Okay. Now basically it is used for correcting the commit messages, but apart from that you can also use it for adding few more files, few more changes into the last commit message. Note, this only works on the last commit message. That's why it is specifically saying that it is used to modify the most recent commit. Okay, now what are the sort of use cases? It is used for correcting a typo in commit message, first and the important one. Second, it is used to add the missing file or changes to the previous commit. And third, it is used for tidying up the local commit history before even pushing. So yeah, let us see git commit amend in the action. So I'll just check out to a new branch, git checkout -b amend branch. Okay, now when I do git log -1 line -n1, because this will be the this will be the commit message where we would be doing the amend operation. Okay, so here let's say instead of deleting node underscore modules, you need to write deleted node modules. So what you are going to do, you are going to type git commit -amend -m followed by the message that you want to pass. Now here what we are going to do is, now see, git commit -amend -m followed by the commit message. Now what it is signifying is we are going to amend with the message. That's why we are adding one more parameter, one more option, that is -m. Okay, so here I am going to write deleted node underscore modules. Let me just check the commit message again. Here we are writing deleting node underscore module, and this time we are writing deleted node underscore module. So we are just renaming the commit message. Now when I do git log -n1, you can see the commit message is now amended, meaning the commit message is renamed. And now I can just push the changes, git push origin amend branch. Okay, so that is how we make use of amend. Amend is used for renaming the last commit. Now can this be done with GitHub desktop? So yeah, definitely. Let me open our old friend which we used. Okay, so yeah, just click on add local repository from the local device, and here is the approval admin which we cloned, and click on add repository. Okay, right now we are on amend branch, and if you go to history, here we have amended the last commit. Now do you want to rename the commit again using GitHub desktop? If yes, then you just have to do a right click on amend commit, and here it will give you a pop-up. Okay, are you sure you want to amend the commit? At the end amend flow, GitHub desktop will enable you to force push the branch to update the upstream branch. Force pushing will alter the history on the remote and potentially cause problem for other collaborator in this branch. So this is just a warning, no need to worry. So just click on begin amend, and here you need to type the new message. So here I'll write deleted node modules using GitHub desktop. Okay, and click on amend last commit. Now the amend is completed, and when you go to history, you can see deleted node underscore module using GitHub desktop, and then you can publish the branch. So that's how that simple it is. Git fetch is done. Fetch origin and click on publish branch. Or even you can do it with console. So when I do git log -1 line -n1, okay, this is the new commit message that we have done with the GitHub desktop, and now you can just push the changes, git push origin amend branch. Let me just take a pull. So what actually happened right now is we were using GitHub desktop and GitHub command line at the same time. That's why it was confused where to take the changes from. So the upstream was unset, so we just set the upstream right now. So what we did, we just defined that git branch --- set upstream to the origin, and here we are just saying that origin / amend branch is same as the amend branch which is present in the local. That's all what we did. Okay, so let me just clear the screen and let me just do git checkout to the main branch. All right, now here we learned about git amend. Now let us move forward with the next topic, that is git cherry picking. Now what do you mean by cherry picking? Okay, cherry picking is a process where we are just taking a selective commit ID from one branch to the another branch. Now let's say you are working on a project and there are multiple commit IDs that you are dealing with. Okay, and in those specific commit, the 5th commit is the selective commit that you want to promote in the master branch. How do you do it? So basically that can be easily done with git cherry pick. Okay, so let us do the demonstration for the same. Git checkout -b cherry pick, and we are inside the cherry pick branch. Now let's say I'll create two files, touch new one.txt, git add new one.txt, git commit -m, first file. Now I'll add another file, touch new two.txt, git add new two.txt, git commit -m, second file, then touch new three.txt, and I'll do git add new three.txt, git commit -m, third file. Okay, and then I'm going to push this branch, git push origin cherry pick. Alright, now when I do git log -one line, okay, now here you see there are three files which we created, that is the first file, second file and third file. Now what does cherry picking say? Git cherry pick is a git command which is used to apply specific commit from one branch onto the another without merging the entire branch, because here we are only taking selective changes. Cherry picking is the act of picking a commit from a branch and applying it to other. Now when you should use it, when we should consider cherry picking, you only want one or few commits from another branch. Second, it is useful for hot fixes or backporting changes. Third, it helps in maintaining a clean focus history. So how do you do it? So basically for that, the only thing that you need is the SHA-1 hash. Now let's say from these three commits, whatever we made, okay, we created three files. In the first file, we wrote the commit as in the first creation of the file, we gave the commit message as first file. When we were creating the second file, we gave the commit message as second file, and same goes for the third file. Now let's say first file is the one which you want to move to some another branch. So what I'm going to do is, let me just create git checkout main. Right now I am on main, and if I do ls, you can see there is no new file which is present by the name first. Okay, so what I'm going to do is I will just write git cherry pick followed by the SHA-1 hash which we took from the cherry pick branch. When I do enter, you can see the first file is now present in my main branch. When I do ls, you can see new one.txt is present, and now when I do git log, you can see the first file is present on top of the main branch. So that is how you do cherry picking using command line. Can cherry picking is possible using GitHub Desktop? Well, definitely yes, and it is considered as easier process when you do it with GitHub Desktop. So let us try to do the same. So let me just check out to cherry pick again, git checkout cherry pick. Okay, and let us create one more branch so that we can cherry pick all the three commits to the new one. So I'll just go back to the main branch again, git checkout main. I'll just create one more branch from main, git checkout one branch. That can be okay. So let me go to GitHub Desktop, and here you can see my current branch is one branch where we have the first file. Okay, now what I want to do is I'll go back to cherry pick branch. Okay, and here you can see I don't have second file and the third file. So what I'm going to do is I'll just select the changes that I want to move. I'll just do a right click and click on cherry pick two commits. Now here it is asking me to select the branch where you want to move the change to. So I'll just move my change to one branch and click on cherry pick two branch. Okay, now if you see, all the three changes are present over here. Now when I go to command line, okay, let me clear the screen again, and when I do ls, new file 1.txt, new 2.txt, and new 3.txt file is present over here. And when I do git log -one line, you can see first file, second file, and third file is present over here. So that is how you perform cherry picking, a selective change that you want to move from one branch to the another. Let me just move back to main branch again, git add git push origin. Alright, now moving forward with the next one. stashing. You might have heard about stashing and squashing. Since this sounds very much similar, you don't have to get confused with the terminology and the working, because stashing and squashing both are different thing and both have their own significance when it comes to working. Okay, now what is stashing? Okay, stashing is something, now let's consider a scenario which will help you to understand why we should consider stashing and what is the importance of stashing, right? Okay, now let's say you are working on a feature. Okay, there are 10 files which you created, and at the same time there was an issue in production which was given as an hotfix. Okay, so a senior developer comes and says, so bro, there is an issue in the production and we need to immediately solve this issue because it is acting as a hotfix. So he's expecting some development work from you because you were working on that component. So you cannot say no to that person, right? So what you have to do is you'll just check out from that specific branch. But the question is, you were working on a feature, right? Will you discard it? No. Here you will make use of stashing. So what stashing will do, it will store your changes temporarily into the working area, okay, into the .git, and then you can switch back to the branch, okay, the hotfix branch. You'll work on the hotfix, you'll give the hotfix, and then once everything is done, you'll come back to your branch. Now, will you find your changes back? No, definitely, because it is stored somewhere else. You need to pull it out and then you can continue your work. That is how stashing it. So let us go with the definition and then we are going to perform stashing in this place. So what is git stashing? Git stash temporarily save your uncommitted change in tracked file so that you can work on something else and come back to them later. Okay, why we should consider git stash? So you want to switch branch without committing unfinished work. Second, it helps in keeping the working directory clean. Third, lets you pause your work, fix something else and resume it later. And how does it work? So git saves the current state of working directory and staging area and then reverts them to the last commit. Okay, all right, so let us do git stash in action. All right, we are going to see git stashing in both command line and CLI. Okay, so first we are going to see git stashing in command line. Okay, so yeah, let's say you were working on the main branch. Let me just create a real life scenario. Let me just check out git checkout to feature one branch, feature 100, and let's say you created new file, touch new feature 1.txt, and then you created another file, new feature 2.txt, new feature 3.txt. Now at this same moment, a developer comes, a senior developer or a supporting engineer comes to you and says there is an issue, okay, and we need to give a hotfix and we need your support. Okay, and I am in the situation, I am in between something and I cannot lose and I cannot discard my current change which I have done. What I'll do, I'll just make use of git stash. Okay, now what I'm going to do is I'll just do git stash. Okay, first I need to add it to the staging area and then the working area, and then I'll do git stash. Now what it is saying, saved working directory and index state work in progress on feature 100 against this SHA1 hash. Okay, now what I will do, I will go back to main branch, git checkout main, and now since he said it is a production issue, we need to give a hotfix. I'll just create a new branch, so git checkout -b hotfix. Okay, and now let's say this was the file which was creating the issue, that is new1.txt. I'll just do vim new1.text and I'll just write hotfix provided, and now once it is done, git add new1.txt, git commit -m hf provided, git push origin hotfix. Now see, the hotfix is done and now you want to come back and you want to restart your work. So what I'll do, you'll just do git checkout feature 100, and now the thing is, whatever files you created is not now present. So will you start your working again? No. What you have to do, you need to see the stash list, okay, because you just stashed the changes and you just temporarily stored it some another place. So git stash list, and you can see a stash is present over here against this SHA1 hash. Now what you want to do is, I want to work on the stash which are present, which are stored in a temporarily location, and then I want to restart my work. So what I am going to do is, I'll just do git stash apply. What it did actually, whatever changes were temporarily stored in a space, working space, it bring it back to the staging area. Now when I do ls, you can see feature3.txt, feature1.txt and feature2.txt file present back. Now what I'm going to do is git commit -m feature is ready, and then I can push the changes. Okay, and that is how you perform git stashing. Okay, now git stashing we did on command line, and can we do it on desktop? Yes, definitely. But before doing that, there is one more command that I wanted to cover in git stash, that is pop. So let's say I'll just create one more file, touch new git add dot, and now let's say you did git stash. Okay, now after git stash, I'll just list this git stash list. You can see these are the stash which are currently present over here. Now let's say I don't want the changes which are present in the stash list. What do? I'll just do git stash pop again, and it will remove all the changes which were stored in the stashing area. All right, now the next thing is, Shubham, I want to do stashing, okay, using GitHub desktop. Can we do it? Yes, definitely. But before that, let me just check out to the main branch. Okay, so we are here back again to the main branch, and now what I want to do is I'll just go to my feature1 branch. Okay, and here we have future ready commits. Okay, and what I'm going to do is, I'm going to check out feature1.txt, and here what I'm going to do is, I'll just add one more file, touch new desktop.text, git add new desktop.text, and then what I'm going to do is, I'll go back here. Okay, and here let's say I want to switch, okay, to some another place. So I'll just go to main. Here it will give me a prompt box and say, you have changes in this branch, what would you like to do with them? Do you want to leave the changes, or do you want to bring the changes to main? I want to leave the changes on feature1 branch, and here it is saying your progress will be stashed on your branch till you come back later. So I'll just click over here and I'll just switch the branch. Now let's say I have given the hotfix, and now I will come back to feature1 branch again. Okay, so what you have to do is, you have to go to changes, and here you can see view your stash changes. You have one change in progress that you have not yet committed. So when you click on view stash, okay, you can click on restore, and whatever changes were present, you can just restore it, and then you can mark it as a commit. So stash recovered, and then you can commit it to feature1 branch, and then you can go to history, and you can see stash recovered commit present over here. Git log, and that is how you can see the stash is been done using GitHub desktop and GitHub CLI. All right, easy enough. Now let's move with the next topic, that is git squash. Squashing is something, if you go to general terminology, squashing is like compressing something. The same thing we are doing with commits. Okay, git squash is the process of combining multiple commits into a single commit. It is commonly used during interactive rebasing to clean up the commit history before merging. Okay, as I mentioned earlier, now let's say there is a feature that where you are working, or let's say there is a bug fix which you are giving, okay, and there are n number of commits, let's say 10 for now. Okay, and when you are providing the commit, the final commit won't be all the 10 commits. You just have to give one commit against the bug fix, right? So here you can make use of squash. You will squash all those 10 commits into a single one, and that would be given for the PR merge. Okay, so why we should consider squash? It makes the history clean and readable. It will combine related changes into a meaningful commit. Third, useful for merging into the feature branch. Now how does it work? Using git rebase -i, you can mark the commits to squash into the above. It combines the changes and allows you to edit the commit message. Okay, so yeah, we are going to see git squash with both command line and GitHub desktop. If you want to know what would be the easier option, it would be GitHub desktop, obviously, because squashing in GitHub desktop is very easy. But yeah, before even going to GitHub desktop, let us cover git squash in command line. Okay, let me check out to main, and here I'll just create new branch, git checkout -b squash. Okay, now let's say I'll create few files, touch squash 1 till 5 for now .txt, and you can see all these squash 1 till 5 files are created. Now what I'll do, git add squash 1.txt, git commit -m squash 1, git add squash 2.txt, git commit squash 2, git add squash 3.txt, git commit -m squash 3, git commit and then we are going to add git add squash 4.txt file, and then we are going to do a commit against squash 4, git add squash 5.txt, and then the final commit message, that is sq.5. When I do git log -1 line -n6, you can see squash 1 till 5 is done over here, and the header is pointing to the squash 5 file. Now when I'm giving this file, when I want to give these changes to someone else, okay, what would I do? I will give a single commit against all the file. Okay, and how do I do it? But before even that, I'll just create a backup branch for this one, git checkout -b sq backup for the desktop, because we are going to perform the same operation using desktop. Okay, now let me clear the screen and let me just do git log -1 line. Okay, now here you can see all the commit message which are present over here. Now what I want to do is I'll just copy this SHA-1 hash and see whatever changes I am giving from here till the header. Okay, I want to give it as a single commit. What I'm going to do is I'll just write git rebase -i followed by the SHA-1 hash. Now here it is saying okay till what point you want to do the squashing, but I'll just quit it for now because I need to take the commit of the previous one. So I'll just take the SHA-1 hash till here, quit, and I'll just do git rebase -i, and I'll just provide the correct commit ID. Now see, there are 5 commit which you can see over here, and here it is giving you multiple options that you can perform over here. You can just revert a commit, you can just edit a commit, you can squash, you can fix up, but right now what we are going to do is we are going to do a squash. So for that we just need to replace this pick by S or by squash. So what I'm going to do is I'll just press I, I'll just edit it, okay, and I'll just remove the pick from here, and I'll just add squash over here. So S for all the 4, and I'll just keep the first commit as is. Okay, now see, this is the SHA-1 hash and this is the commit message which we did. Okay, now what I want to do is against this commit ID it should compress all the changes into a single one. Now once everything is done, I'll just do escape :wq. Okay, here it will give the commit message for all of them, but I just want a single commit message. So what I'm going to do is I'll just add a hash in front of all the commit messages which were given against the file. So I'll just add a hash over here, this one, and the last one. So the final commit message would be sq-1. So here I'll just edit it again, final squash commit message from console escape :wq. Okay, and the squashing is done. When I do git log -1 line, okay, you can see the final squashing is done and all the 5 commits are now eliminated. Okay, and now if you want to share this file, you just need to do a cherry pick and all the 5 file changes will be moved over there. Now can we do it with GitHub desktop? Well, yes, definitely it would be easier for us. Now let us go to GitHub desktop. Okay, and now what I'm going to do is I'll just move to squash branch. Okay, now if you remember, these were all the commits which we did. Okay, and now what I want to do is I just want to compress it into a single one. I'll select the commit IDs, commit messages, and I'll do a right click and click on squash. Now I want to give a final commit message. So squashing using desktop. Okay, and here is the description if you want to give any, and then click on squash commit. Now if you see, it has squashed all the 5 changes into a single commit by using desktop. So see, using desktop for squashing, it is very easy. Using desktop for cherry picking, it is very easy and very convenient. You just need to know the mechanism, how it is working at the backend. That's why we are covering both command line and desktop at the same time, so that we are handy. We just know what is running at the backend, what command is running at the backend, right? So yeah, let us move forward with the next one, that is GitHub pages. So yeah, see you in the next section where we are going to explore GitHub pages. Just want to give you our highlight what GitHub pages is. Let's say you want to display a portfolio. Is there any place where you can display it? You'll get your answer in this section. So yeah, see you in this one.
Wait a minute!
Okay, so there was one thing which we forgot to tell you, that is how you can perform git squash over the pull request on a GitHub central repo. So yeah, let us explore the same. Okay, so what I'm going to do is I'll just push all the changes which are present over here. Okay, git push origin sq backup desktop. Okay, and now what I'm going to do is I'll just add few more commits over here. So I'll just add touch new file, git add new file, git commit -m for pr squash. I'll just add one more file, touch another file. I'll just add git commit -m for another pr merge. But it is showing git add another file, you have to include it. Okay, I just have to do a git add another file, and now I'll just do a commit for this one, git push origin squash branch. Okay, now I'll go to my central repo. Okay, and here you can see I am on squash branch. Okay, and then I'll raise one PR. So compile pull request, and instead of revert branch, I'll just search for squash branch. Okay, and this PR I'm going to merge it with the main branch. Okay, and if you can see, there are 3 commits which are present over here, and at the bottom you can see these are all the changes that we are doing against this PR. I'll just create a pull request. Okay, our initial job is done. Now the next thing is what will happen if I do a merge right now. Okay, so see, when you create a pull request, okay, here you'll get an option enabled. Right now it is checking for the ability to merge, but the thing is it will just check whether will you be able to merge or not. Everything goes right, then it will give you a green button, and then you can merge the changes. Now what will happen if you just click on directly merge? It will create a merge commit. Okay, now let's say there is a bug fix that you are giving, there are multiple hotfix that you are giving over a feature branch. So how do you get eliminate of this thing, all the merge extra commits? You can make use of squashing while doing the PR merge. Let me just do a refresh so that the things are present for us and I can show you the live changes. Okay, so now let's consider that you want to merge this request. Okay, so when I do merge pull request and confirm merge, you can see there is a merge commit which is created against it. So when I'll just go back, and when I do git checkout main, and when I do git pull, and when I do git log, you can see there is a merge commit which is created against it, which we don't want, right? So for that, what I'm going to do is, let me just create another file. Let me just go back to the same branch, that is squash branch, and I'll just add few more files. So let's say touch new.sq, git add new sq, git commit -m for sqpr. I'll just add one other file, git new sq2, git add new sq2, git commit -m for another pr merge 2, and here I'll just create one more file, git new -sq3, git add new sq3, and then I'll just add the commit message for merge 3. Now what I'm going to do is I'm going to push the changes to the origin of squash branch. Git push origin squash branch. Now let us raise one more PR against it. So I'll go to pull request, okay, and here I'll go to the branch name squash branch, compare pull request. Here I'll just rename it to my squash branch, and I'll merge the changes to the main. Now if you remember earlier, okay, now let me just show you one more thing. If I go over here, okay, in approval admin, in the main, when I go to the commit history, you can see the merge pull request commit is present over here. Now let's say if you want to maintain a cleaner history, how do you do it? So while merging, so let's say you create the pull request, okay, now here it will check the availability to merge. Now everything is good and the base branch is clear. You have a drop down over here, and here you have 3 options: squashing and merge and rebasing and merge. What rebasing and merge will do, it will add the 3 commits on top of the main branch. Okay, so here you can see the description. The 3 commits of the branch will be rebased and added to the base branch, which we don't want. Squashing and merge, what it will do, it will combine all these 3 commits into a single one, and it will get merged into the base branch, that is the main branch. So what I'll do, I'll just select squash and merge and click on squash and merge. Now here you can give the commit message. So here I'll write squash and merge for the parent, and I'll do confirm squash and merge. Things are done. Now what I'm going to do is I'll go here and refresh my history. Now see, earlier you were getting a merge pull request along with the 3 changes, okay, along with all the 3 commits that you have done. Okay, if you go and open the third pull request, you can see there were 3 commits which were present: another PR merge for PR squash and PR squashing using desktop. You are getting those 3 commits. Along with that, you are getting an extra commit. Okay, if you want to get rid of this merge commit, you can just make use of squash and merge, right? So that was all about squashing and merge. And yeah, we covered a lot of development operation in this section 13. Hope it did add some value to your learning. Now let us meet in the section 14, that is GitHub pages. All right, so yeah, that was all, and see you in the next section. All right, welcome back. In this section we are going to learn about GitHub pages. Okay, as I mentioned in the previous section, that in GitHub pages, okay, we are able to host static website which are made up of HTML, CSS and JavaScript. Okay, so in this specific module, in this specific section, we are going to cover 2 methods. Okay, one is directly via a repo, another also via repo, but there is only a slight difference that we are going to do. Okay, now how do we use it? So that is something that we are going to do in this specific one. There is a tip, okay, only static website. Okay, there should be no PHP or backend that should be associated with this one. And one more thing is, if you want to host your website with using custom domain, that can also be done. That I'll show you how you can do it. Okay, there is an option present over GitHub settings. All right, so yeah, let's get started. So here is our GitHub account that we are going to utilize. You need to go to repository, and here let us create a new repository. Now here the point to note is, here the repository name should be your username followed by the username followed by .github.io. okay, just remember this is the owner of the repo, followed by this should exactly match your username followed by .github.io. okay, now once it is done, the second thing that you need to make sure is you need to make this repository public. If you make it as private repository, things won't work out for you. Okay, now the next thing is create the repository. The initial thing is done. Now what we have to do is just clone this repository. Okay, so git clone repo name. Okay, cloning is done. Now let us go inside the repository. Okay, and we are here. Now what we have to do is let us create a basic HTML page that we are going to host over here. So code dot to open Visual Studio Code. Okay, all right, now VS Code is fired up over here, and here we are going to create one file named index.html file. Let us go with the emits, and let me write one heading over here: h1 lorem some text, and let me give a para lorem 10 h2 lorem 9. I'm just adding a basic text, so no need to worry about it. And yeah, I think that's it. We are done. Okay, now what I'm going to do is I'm going to push these changes. Okay, so yeah, enough of texting is done over here. Let me save it and let me go back to terminal. You can push it from here also. So let me open the integrated terminal over here. Okay, and now git status, git add index.html file, git commit -m index file, and now git push. Now it is asking for a keychain value, so let me just enter the password over here and let me get back to you on this. Alright, so yeah, we have pushed the changes, and let us go to the repository and check whether the changes are actually pushed or not. Okay, so I am here and let me just refresh the page, and here you can see the index.html file is present. Now there is one more thing that you need to point out over here is that is this orange dot. Okay, so when you click on it, okay, some actions are running behind it. Okay, so you can directly view it from here, or either you can go it from actions. Okay, so if you click on details, you will be present over here. So what is happening right now? Okay, so it is building your project and then it will deploy, right? And then you will be able to see your changes over the GitHub server. Okay, now if you want to check where my changes are present, okay, you just need to write https:// followed by the repository name, whatever you have written, and whatever text you have pushed so far will be present over here. Okay, so yeah, this was the gibberish text, whatever we pushed is present over here. Okay, so this is method 1. Now Shubham, if I want to update this text, okay, what will happen on the next commit? So that can also be done. Okay, so now the next time whenever you are going to push another change on this specific repo, okay, another GitHub action will get triggered. Okay, it will build and then it will be deployed. Okay, and then it will take some time to reflect, and then the data will be visible over here. All right, so yeah, that was the first thing. That is how we do the changes. Okay, now the second thing is what if I want to push the changes and I have the code present in my local? Okay, and how do I do it? And Shubham, you told there are 2 methods. Which one is the second one? See, right now in this specific one, we didn't even made any change, right? Technically, we just created one repository by the URL, and post that we just push the changes, and then we access the site with the repo name itself. Now what is method 2? The method 2 is very simple. So for that, again, you have to create a new repository, and this time I'll write portfolio GitHub. Okay, and now again I'm going to create a public repository and click on create repository. Things remains the same, and the next thing that I want to do is I will go and clone the changes. So let me go outside this repo, git clone portfolio GitHub. Okay, now the next thing is there are already few files present on my local, okay, which I am going to move under this portfolio GitHub repo. Okay, the changes are moved. Now what I am going to do is cd portfolio GitHub, okay, and git status. If you see, there are new files which are currently present. Okay, git add dot git commit -m added baseline files. Okay, now before even I push it to GitHub, okay, I want to show you how does it look in local. Okay, so let me just open a new window, and here I'll just open the folder. So it's under desktop portfolio GitHub. So now when I open it, okay, I'll just show you how does my index.html file look like. Let me just copy it, or I'll just show you this one side by side. So this is the website that we are gonna push. Okay, there is dummy data present over here. Okay, so now let us push the changes. So git push. Now if we take reference of the previous one, will my changes be present over there or not? See, so in the previous segment, what we did, we just provided the repository name and our work was done.
Will it be the same this time? Let us try the same. So let me go to portfolio GitHub again, and here you can see first of all there is no trigger which is present over here. Now if I just copy the portfolio GitHub and replace is with the username, nothing will be present. If we will get an error 404 nothing found. Okay, there is a setting that you have to mark down when you do it on custom repository. Okay, so is there any limit to host website? No, there are no limit. How many, so like the number of repos you can create, the number of website you can host over GitHub for free, right? Okay, the next thing is you need to go to setting. Okay, under settings you need to scroll down, and here we have something called pages. This is specifically for GitHub pages. Now here you need to specify which branch the code is present into. It is present in main branch, and then you have to click on save. Okay, now as I mentioned earlier, if you want to provide a custom domain, you just have to type it over here, and then things will be present over there, right? Now let us wait for some time. Okay, and the page will be present over there. All right, so as I mentioned, it just took 1 minute. Okay, and my URL is present over here, and I'll just click over here, and you can see my website is live within 1 minute. Okay, I don't even had to wait for some time. Now the second thing that I wanted you to notice is the pipeline, the GitHub action got triggered, and the job was success. If you want to see how many actions are running for your repo, just go to action, and you can see the page was deployed. And this is something which you can see, which you can experience by your own self using GitHub, right? So yeah, that was all about GitHub pages. Okay, and I hope you understood how do we deploy a website, a static one, again using GitHub pages, using GitHub repository, right? So yeah, that was all. And in the next section, which is the last section for sure, we are going to learn about Git hooks. So yeah, see you in the next one. All right, let us start with section 15, where we are going to learn about Git hooks, which is the last topic in this video. Okay, so now what Git hooks are? Okay, Git hooks are few executable files which get executed, okay, whenever we perform any action. Okay, now let's say you are going to do a commit, okay, and there is a specific pattern that you need to follow, okay, but the team is not following it, and you want to enforce the changes. How do you do it? You will make use of Git hooks over here. Okay, so we have something called pre hooks and post hook, which will do the job and will make our life easier. So what hooks will do, basically you will define a shell script or a Python script, okay, which will run before the commit and after the commit. So whatever scripts which are getting executed before the commit is being done, that will call pre-commit hooks, and whatever script will execute after the commit is known as a post-commit hook. Okay, so yeah, Git hooks are scripts that run automatically at certain points in Git workflow. They help to automate check, enforce rule, or trigger action before the key operation is done in Git. Okay, these files are stored in .git under hooks folder. Okay, here we are going to cover two major hooks, that is pre-commit hook and post-commit hook. So pre-commit hook, as I mentioned earlier, it works before the commit is done. Post-commit hook works after the commit has been done. Alright, now what pre-commit does, it prevents bad code from being committed. Second, post-commit, what it does, it triggers the action like notification. So why post-commit is being used? It is just used for notification. Pre-commit will actually do the job before the commit has been done. Alright, so here we have one diagram which will demonstrate how does the things will work over here. Alright, so yeah, our changes are present in the working directory. Then we move the changes by using git add a dot. Okay, now when we are adding a commit message, git commit -m, it will just execute the hook, pre-commit hook, and then it will give you the notification. Now if everything is good, it will move to the next stage and will trigger the post-commit hook. If not, then it will say, hey, things are not good over here, just remove or make this specific modification, and then you will be moved to you would be good to go with the next one. All right, and then again a post-commit hook will be called, and then you will be good to go. So this is how hook work in Git workflow. Now let us understand what is Git hook and why we should consider Git hook in the first place. See,
Git hook first is used for enforcing coding standard. Second, it catch mistakes early. It will save time with the automation, and it will ensure clean, reliable commits has been done. Okay, yeah. Now where Git hooks are stored, it is stored in .git hooks folder, and we just need to make it as an executable file. So whenever we are working with them, we are good to go with it. All right. Here you can see there is one example for pre-commit hook. What it is doing basically here, I have added shebang, then it is printing a message that we are running your pre-commit check. Post that it is looking for console.log, and then if console.log is present, then it is showing that yeah, you need to exit. Right here we have two sort of exit code, exit 1 and exit 0. If you add exit 0, it will allow the commit, but if you add exit 1, it will just wait until and unless you remove console.log, and then only it will allow you to do. All right, now same goes for post commit hook. What it will do, it will first it is printing that logging commit, and then it is storing the value into the git commit log.txt file. All right, so yeah, let us work with pre-commit first. Okay, I am going to make use of the previous repository. Okay, now the one thing is, now Shubham, I don't know how do I write a shell script. We have something called ChatGPT, and the screenshot which you see over here is something which is generated from ChatGPT itself, right? You just need to write that I need to create a pre-commit hook, and please help me in writing a shell script for the same. Okay, for me the parameter is console.log. For you it might be any debugging file or any .log. Okay, so yeah, that can be done by adding the prompts, and ChatGPT will create a beautiful script for you. Okay, now if you exactly copy paste this shell script, there will be one issue which you face. Okay, that you have to write down in the comments. All right, I'll tell you at the end. All right, so right now what we need to do is, let us go back, and here let me just go inside the .git folder. So let me do ls-la. Okay, and let me go to .git folder, so cd.git, and here we have something called hooks. When I do ls-la, you can see there are already few sample files which are present, but we have to work with a few files, that is pre-commit file. Okay, so we are going to create a new file, so vim pre-commit, and here what I'm going to do is I'm going to define a shell script. Okay, and here I'm going to start it by writing shebang line. So the one which you see over here is known as shebang. Here we are telling the shell that you have to use is a sh shell, right? So I will be writing #bin/sh. If you want to use bash, you can just write bash. Okay, here I'll write checking the logs in the files, and here what I'm going to do is I'm going to add one condition. Here what it is going to do is it is going to search, okay, for console.log. It will exclude the directory .git, and then it will print the message commit block. Console.log is filing the code, and then it is going to exit escape :wq, and then I am going to create one more file, that is post commit. I am again going to write shebang /bin/bash or sh, and here I'll just print all validations done, logging changes. Okay, for now this will be good. And for both of them, what I have to do is I'll just get executable permission chmod +x pre-commit and post commit. Clear. Now everything is looking good. The only thing that I mentioned over here is if you run this specific script, it will work, but the thing is it won't exclude from .git folder. The one which we wrote, if you see over here, you can see we have added exclude directory.git. Okay, so what will happen? So let's say if you find a console.log, while committing it will work fine, but the next time is when you delete it, okay, from the file, it will be still present in this script. Okay, so that's why we are excluding the directory.git, and that will do the job. So let me just create a console file over here. So console.log, and here I am going to store it in the file name app.js. Now again, let me just remove it. We have created accidentally over .git folder app.js. Okay, let me go outside from here and write. This is the place where we are supposed to create the file. So yeah, echo console.log and git commit git add app.js git commit -m adding log file. Now here is something that you need to focus. See, if you go over the diagram, okay, we are over this place where we are about to do the commit, right? So here the pre-commit will get triggered automatically, and when I press and enter, you'll see it is saying checking the logs in file, and here in app.js file it found console.log, hence commit is blocked. But when I do git status, you'll see it moved into the staging area. But Shubham, you said that it will block the commit. But yes, actually it blocked. When you do git log -1 line, you'll see only the initial commit is present over here. Now what is the next step? What I'm going to do is I'll again go over here and I'll just remove few text from here, console removed, and I'm going to rewrite the file, and when I do get app.ts, you can see console remove is present and we remove console.doc. Now will the pre-commit work this time? Yes, definitely. So what I'm going to do is when I'm going to run git status, you can see the file has been modified. Now there is one more thing that I wanted to tell. Now let's say if a file which is already moved into stage and you don't want to move, you want to travel git add dot and then git commit path, you can directly do the commit by using git commit -am. Okay, now what am does, it will add it and then will do the commit. So okay, I accidentally added a blank commit, so pardon me for that. Let me just do the commit again. Okay, git commit -am, and here I'll write consoles removed. Okay, and here you can see the SHA1 hash is present, okay, and the file is changed. Now when I do git log -1 line, you can see the commit is done. And there is one more thing to observe is, okay, that is post commit log. Okay, here it is saying all validations are done and log changes are been logged. So that was all about pre-commit and post-commit. Okay, if you are facing any issue while creating a pre-commit or post-commit, feel free to use ChatGPT and it will definitely help you while for writing a commit file, right? So yeah, that was all about this section, and I hope this really added value to your learning. So yeah, that was all, and thank you very much.
Congratulations on making it too far till the end, where you have learned a lot about the course, where you have learned from the basics till the advanced of GitHub. Now, as promised, I will give you the cheat sheet and the PPT jot down in the description, where you can just use it for your reference and for your learning. So yeah, congratulations once again. Keep learning, and I will see you in the next one.